ฮัลโหลคุณเราได้ยินไหมคะไม่ได้คุณเรา
What are my words? Read.
พูดใหม่สิ
Read. Read.
ได้ยินสิ
Okay. Enjoy my checks.
ไม่สน เราได้ยินไหมคะ
Yours.
এটা জানো
เสียงมันมาจากห้องนู้นนะคุณเรา
জানো কি জানো বললে তাহলে
Test 1, 2. Okay, now can you hear, right? Okay, clear? Okay, can you repeat answer to me, please? Unmute yourself and answer to me.
ฮัลโหลได้ยินค่ะ
Okay, good. Okay, that was good. Oh, okay.
Solo volume. One more time. Only timing. One.
Have you received that?
You just send now?
Yeah, it is in my pen drive also. It is.
Okay, you can upload now. You made a change, yeah?
Yeah.
Okay, yeah, can you make?
Does it matter for hall one or hall two? Hall one?
He's in the no. This is a room 2.
Yes.
All files should be here. That he's in the room 1, right?
Yeah.
Yeah, that
I-
computer. That computer. Yeah. So whenever the make people making a presentation, right?
Yeah.
Okay. So we need to share the screen. Yeah. So when PowerPoint is open.
Rajesh is here. He will be hosting hall two. You take care of it here.
Okay.
And then
You cannot minimize Zoom.
Sorry, this is all-
recording.
hall two. So I'll be here.
Yeah. So
Can
the
I call
po-
Rajesh?
It's okay. What it is like this thing. We have all the files in the desktop.
Yeah.
And room
Room
2. Okay, room
Yeah.
2. Morning.
Morning.
Okay, so afternoon. And yeah, Mr. Narayan Das said he can't make it.
He said he cannot make it. He sent.
Just a minute.
No, but he also had one there. Okay. That's not me. টোটাল রাউন্ডটা হয়ে গেলে দ্বিতীয় রাউন্ডে যদি বলে দিচ্ছিল তো বলবো অসুবিধা হবে বারবার তাহলে স্টার্টিং করলাম তারপরে বলে Ask me what. He did some career partition to yes. Hello, kalau ada tuh
Yeah.
So I think this one.
This is one.
This one.
Yeah, it's the old one, right?
This one.
Okay. You're going to replace?
Yeah, they are the flash drive one.
Huh?
But I think I uploaded it
I given your mail.
in the email, right?
Yeah. It's starting from B3 version 6.
Sir, actually it is live online telecasting. Online telecasting, that's why.
Oh.
Okay, some of them like government. Right?
So cost lecture will be in that part.
Okay.
Well, I did not know this.
Yeah.
Can you admit the person also to this?
Okay.
The well, stop recording. Yeah.
Sir, you are muted. Excuse me, sir, you are muted. We can't hear you.
I think.
Okay, am I audible now?
Yes, yes, very much.
Okay, thanks for the confirmation. So the scope of my presentation will be little bit introduction about our organization and the mega trends. I'll touch upon some mega trends and development on the new functionalized rubber, particularly for the SSBR and also certain lithium BR, functional lithium BR. I will touch upon those grades, which we called is now Q technology functionalization. And also we'll discuss about the high Muni NdBr, which is required for the better or very high abrasion resistance. And then we'll touch upon this Erlangshow sustainability roadmap as well. Okay. So Erlangshow is a joint venture. Initially, it was a joint venture formed by Lanxess and Saudi Aramco in 2016 with the 50-50 joint venture in 2016. And later on in December 2018, it was 100% taken over by the Saudi Aramco. So now it's in 100% subsidiary of Saudi Aramco. We have more than 12 production sites in 9 countries and 7 innovation centers, and have the corporate center in the Netherlands. And we serve the entire rubber industry with our broad product portfolio. That I'll come to here. So we have in our product portfolio, BR. So butadiene rubber, we have cobalt BR, lithium BR, and NdBr as well. Then we also produce emulsion SBR and solution SBR. In the butyl category, we produce regular butyl, bromobutyl, and chlorobutyl. And of course, we have also are present in the NBR, HNBR, CR, EVM, and EPDM rubbers. So coming to the tire requirements, basically. So nowadays we have seen that automobile industry is going on under disruptive changes. There are many changes are happening because of the safer fuel requirement. So the vehicles are going for the EV type segments or hydrogen fuel segments. They are getting ready for that. Then the share mobility and autonomous driving, they are forcing the automobile industry to get the changes, and that changes leads to the change in the tire requirements and the tire design. So the major tire design changes, what the tire companies are asking is first is improved rolling resistance. Okay, that is happening through the improved materials or reducing the weight of the tire. Then the improved wear resistance of the trade compounds, and that is because of the for the EV segments, you know that the initial high torque is very high, and that leads to the high abrasion resistance if we don't change our compound or the tire design. And also the requirement from the environmental point of view, you need to have the lower tread wear particles. Then because, and also the requirements are coming for the comfort and the noise, because now the noise in the EV vehicle, the noise coming is because only of the tire noise. There is no noise from the engine. Then because of the increased load from the battery, there is a requirement for the improved air retention, and the tire companies are improving the inner liner as well, so that they can have the better air retention. That will also give the good fuel efficiency. And tires are now smart tires. They are talking with the road, and they are always giving you they are giving the information about the temperature, wear, and the air pressure as well. And all these calls for for the autonomous driving and these things, they calls for the lower tolerance for the tire failure. So you can't afford any tire failure because of all this automation and autonomous driving as well. And because of these tire requirements, there is the requirements for the polymer or synthetic rubber manufacturers as well. And what synthetic rubber manufacturers they are doing is new functionalization technologies. They are developing new functionalized technologies to cater particularly the silica compounds, which is very vital for the meeting the various labeling requirements or lowering the rolling resistance. Then polymers and compound with improved abrasion resistance is also required because of this other requirement for the high wear resistance. And also we need now sustainable polymers from the tire industry. They want to make the sustainable tires, and that's why they ask for the sustainable polymers. So today's my presentation will be focused on these 2-3 points what the companies are doing to address these issues. And of course, the other developments is synergistic development with the fillers and performance additives, so that the total solution we can offer to the tire industry. Then the master base technology and improved inner liner technology and self-sealing technology and conductive polymers. These are the other area where the synthetic rubber manufacturers are working. So this is our typical product portfolio of the functionalized SSBR, if you can see, right? So Buna FX, these are categorized based on the glass transition temperature. The most popular functionalized SSBR are Buna FX. This is under the category mid TZ SSBR. We can categorize as high vinyl functionalized SSBR. And these are Buna FX 5000 and Buna FX 3211 is our existing functionalized SSBR, where they have the vinyl content of around 50%. And in the Buna FX 3211, where the vinyl content is 32%. The new technology, what we did is introduce is the Q technology. So where what we did is because what feedback we got from the customers are the performance of functionalized SSBR are good. They are giving the lower railing resistance, but the issue is with the processing. So the functionalized SSBR processing is not so easy. So what we did is we met this branching, extreme branching with this functionalized SSBR, new functionalized SSBR. Also, we did the certain coupling. So that will help in the processing and change in the functional group, which we called is the Q technology. So Buna FX 4321Q is like again the mid-TG functionalized SSBR having the 43% of the vinyl and 21% of the styrene content. And that is having the new functional group, which we call is Q functional technology. And that this polymer is for the very low RR application can be used because of it is the higher vinyl content. And also the your styrene content is also the 21%, which gives the balanced in the wet grip or handling properties. Then we have the low TG SSBR. So now the trend is also for the tire companies to moving towards the low TG SSBR. So in this category, we have this Buna FX 3211, which is our existing SSBR, and FX 3221QQ is the new grade having the with the new functionalized group and again with the branching. And the molecular weight of this SSBR, this new Q technology SSBR is also higher as because of the requirement of the high wear resistance. So the low TG SSBR, this is having the TG of around minus 62 degrees centigrade, minus 61 degrees centigrade for this Buna FX 3211. So they can be used alone even without the betadine in the formulation. Whereas the mid TG SSBR, normally they blend with the certain amount of the betadine to get the desired glass transition. Then Buna CB 80FX, this is not the SSBR, but this is our functionalized lithium BR having the glass transition of minus 90 degrees centigrade. And here the functionalization is for the silica technology. So this is also another trend for the tire companies to going for the use of functionalized lithium BR as it improves your polymer filler interaction better. And the functionalization is possible with the lithium BR, where of course there are attempts to functionalize the NdBr also as well as the other grades, but the lithium BR functionalization is more popular. It is easier to do the functionalization in the lithium BR betadine rubbers. And hence you will find that there are lithium BR available functionalized for the carbon black and as well as the functionalized lithium BR for the silica. So functionalized lithium BR for the carbon black can be used for your under tread or sidewall application, whereas this functionalized lithium BR for silica can be used for the silica application. So these are the new functionalization or coupling chemistry. This allows higher molecular weight functionalized SSBR with very good processability behavior. So the important thing is that they are very good processable. These new functionalized SSBR, they have the very high polymer monoviscosity. If you go for like FX 4321 and FX 3211, they have the polymer monoviscosity in the range of 110 and 115. But if you look at the compound monoviscosity, that is drastic reduced. And this is happening because of the extreme branching. So compared to this our standard functionalized SSBR or existing functionalized SSBR, the compound monoviscosity you can reduce with the help of this Q functionalized technology. And that helps in your the processing as well. That gives you the smoother garbage dye extrusion as well as the better polymer filler interaction and helps in the reducing your rolling resistance of the compound with the good processing. So I am not going into the detailed compound study. These are available with us. If you are interested I can always share you separately these compound studies with this polymers, but because of the time constraint, I cannot go with the detailed compound studies here. Sorry. And this is our portfolio of NDVR, you see, and this NDVR here we have also in the right side, we have given with respect to performance versus the processability. So performance with respect to your abrasion resistance and the rolling resistance as well. So if you look at the other category of BR, which is like cobalt BR, they have the good processing wise, the best processing, but the performance will be little lower than the NDBR, respective NDBR. So Buna CB24, the standard is NDBR having the Muni viscosity of 44 will give the better performance than any of the cobalt BR of similar Muni viscosity. Whereas the Buna CB22 having the higher Muni viscosity of around 63 will give even more performance than the CB24. But again, the processing will be little bit challenging, as you understand that the higher Muni viscosity will lead to have certain issues with your processing. And then we have the higher, again, more higher Muni viscosity of the polymer CB21, which we are now no longer producing. That gives the maximum performance, but it's having a difficulty in the processing. And to address this processing issue of this NDBR, those who cannot do the processing, we come with the easy technology. So this, if you look at this ND24 easy, the processing is at the level of the cobalt BR. Those who cannot produce, we can provide them this ND24 easy, where the processing is similar to the cobalt BR, but the performance is at the level of CB24. And similarly, ND22 easy is at the processing level of CB24 with the performance of CB22. And the new addition is ND20 easy VP, which having a very high Muni viscosity of 80, and it's having a very good performance, as good as your CB21, our previous grade, but with the processing level of CB22. And this is happening because of this easy technology. Again, normally this NDBR are linear structure, highly linear structure, but here this ND20 easy, we have given a high Muni viscosity with the extremely branched macrostructure to make it processable. So though it is a branched, but still it is giving the performance better than the CB22 because of the higher Muni viscosity. So you look at this comparison of this CB22 versus this ND20 easy VP grade. Okay, so this ND20 easy in the right side, you can see this the blue square that represents the ND20 easy grades, which have the the blue square is representing the CB22, which has the rolling resistance indicator RRI, which we measure as a rebound 60 degrees centigrade divided by 10 delta at 7%, which we measure at strain sweep curve, and that is also representing your rolling resistance indicator, and also dividing by the 10 delta at 60 degrees centigrade. So I can show you the this is the formula for the rolling resistance indicator. So if we consider this rolling resistance indicator for CB22 as 100, so and then for the ND20 easy, this comes to around 108 or 110, in the range of 110. So around 10% improvement of the rolling resistance indicator we are having with the improvement in the stiffness indicator. So stiffness indicator, how we measure is like modulus at 300% and hardness and G prime at 15%. So this stiffness indicator that will give you the prediction about the handling. So for the handling, you need the good stiffness, and it's a little bit always challenge that when you are going and improving on the rolling resistance, you are normally compromising with your handling. So here, what with this ND20 easy, you are improving on both the direction simultaneously. And at the same time, because of this easy technology, you see the Garvey profile extrusion behavior. So that's more smooth. So ND20 easy is more smooth. Garvey die. So it's also processable. So again, if you need more detailed component study, please contact us. Then I'm coming to the other requirement coming from the tire industry is about the sustainable polymers and sustainable solutions. Okay. So this I am representing here this Erlangshu, our sustainability roadmap, where we are working on the 6 strategic block. So first, our strategic block is reducing the greenhouse gas emission. And so our target is driving towards the carbon neutral by 2050, which is aligned with our parent company, Aramco. Then second strategic block where we are working is to provide the customers with the product environmental footprints. So this is requirement from our customers because they also would like to calculate their own product environmental footprint, which is not possible without providing the data from our side. So we are working on that. So for few category of the product is already available, and for others we are working, and we will be able to provide all the product environmental footprints data to our customer. Third is as a responsible chemistry, we are working towards the reducing the chemicals of concerns. So any chemicals like used in our manufacturing process, like catalyst or intermediates, so everything or any antioxidants also. So if it is hazardous one, that we are removing from our manufacturing operations across all the plants. And then fourth strategic block is the sustainable products. So we are shifting our feedstock over time to renewables and the other materials. So we have already started working on that. And for that matter, we have started taking the ISCC plus certification of our products. And few of our products are already now available for you as an ISCC plus certified polymers. Then we are also working and collaborating with our partners on developing the sustainable applications, especially supporting new mobility. Okay. Just a minute. It's the old one actually, the presentation. Okay, but no problem.
1 second. I need to share the screen. Sorry, guys. There are many calls to me, so sorry.
Yes, we can see the screen now. Thank you.
Yeah, thank you, sir.
Right. And then also we are doing certain corporate social responsibility, so as to positioning Erlangshu as a reliable and responsible rubber company. Oh, I cannot move this slide. What is it?
Yeah. That is pointed.
No, but not amazing. Okay. Okay.
So it's like
Listen.
can
Yes. So ISCC plus certification. So just a little bit about this ISCC plus certification. ISCC is globally recognized sustainability certification scheme of international sustainability and carbon certification. And this allows us to use Erlangshu to use the bio-based, biocircular, and circular sustainable feedstock into the existing production. So bio-based means the directly coming from the bioproducts like your sugarcane and other things, the ethylene produced from that we can use, and that we are using in making our like EPDM products, Keltan Eco products. Then the biocircular means coming the feedstock coming from the biological waste. Okay. like your and that is used by the naphtha crackers. They use this bio-based wastage, produce the monomers, and they provide us these monomers that we use, and that we call is the biocircular, and circular is the like your plastics and other waste. From there, if we derive this monomers, and that we use, and that is called the circular. So we are using the all these three approach to use the renewable feedstock into our manufacturing. And these are tracked through a certified supply chain, which we can always demonstrate. It is certified through this IECC plus organization. So first we received this IECC plus.
ISCC plus. Care about stop learning in this. It's not. It's not.
Okay. Yeah. Retirement. Okay. So this ICC plus certification. So we already received this ICC plus certification for our EPDM facilities in the Netherlands, and already this butyl facilities for the from the Singapore plant. So now it is available. Our BR plant in Dormagen, Germany is also now undergone the successfully undergone this audit, and soon we will be able to offer this our betadine products from the Dormagen as an ICC plus certified material. So how this ICC plus certified value chain works is like you use both sustainable and fossil based feedstock. Okay, and this both the mixture of sustainable and fossil based feedstock is going together into the naphtha cracker, and there what we are receiving is the both ICC plus certified monomers and the regular monomers, and that monomers together is used in the synthetic rubber production, and from this synthetic rubber production we can categorize both ICC plus certified rubber as well as the your regular rubber. So this ICC plus certified rubber, the mass, whatever the mass is used as a sustainable product will be used, the same amount of the mass will be considered in the your ICC plus certified rubber as well. So this is we call this a mass balance approach. So of course there is a physical connection within the supply chain. It means there will be certain input from the sustainable feedstock, and typical sustainable feedstocks are blended together with the fossil feedstock in production process, and the amount of sustainable feedstock in the process and attributes it to the final product using verifiable bookkeeping. So that can be always audited and that can be verified. So the amount of ICC plus certified polymer you buy from us, so that much amount you can always claim as a sustainable content in your product. So this is a verified chain that can be used, and this is this way we are producing the sustainable polymers. So these are our currently certified ICC plus certified facilities. So EPDM, as I told, and butyl and the EVM. These products are already certified. External audit already completed with the BR for the Dormagen plant. And next, we are planning for the emulsion SBR and BR plant in Trinfio, NBR and BR as well from the Orange and Lavansu plants. And after that, we are targeting the audit of all our other sites as well. Okay, thank you. Any question?
Thank you very much, Mr. Bandit, for your excellent talk and a lot of information, sharing information. And for you, also for your information, one you mentioned about bio-based Ian, and we also part of that is here, and we'll be talking on sustainable processing for ECO grade.
Okay, great. That's great. Okay. Thank you.
you have machines. So that data incorporate, it is from the sugar, right? From the ethanol actually. And the say difference between the naphtha rate actually and the actually from derived from the is there any specifications of ethylene that is given?
Yeah, so here, so from the eco grades, what you have received from this uh, sugarcane, okay, this eco grade, that is traceable through, or you can measure through the C14 analysis. Okay, here from the ISCC plus certified, you cannot, but it is only the certificate. So this is the amount of the ethylene we have bought, and that is the maybe the source is maybe the sugarcane, it may be the source, other source as well. So that we are buying this ethylene from that the naphtha cracker, the our supplier, they are providing us this uh, monomer from certain renewable sources. So ethylene as well as the propylene, and that both things we are adding into our process, and that's why we are able to give you the certificate. So that's basically the mass balance approach in the ICC plus. Whereas this Kelton Eco, which we have provided earlier, that is basically the originally we have used this ethylene from the sugar cane. So that is the difference. So that is only for the certification. Technical differentiation, you may need to evaluate this eco grade because it's a really a different monomer. But whereas in case of ISCC plus certified, this is this is added already during the naphtha cracking. So there is the product wise, if you consider from the standard product, there is no change in the standard product for the ICC plus certified. Technically, you don't need to evaluate this ICC plus, whereas this eco product, you may find little bit difference because of the monomer difference. But it's of course very negligible difference is there. Yeah.
Any question? Yeah. Oh.
You are offering eco-equilibrium. How is the price of eco-equilibrium compared to your conventional eco-equilibrium?
Yeah.
What is the price difference about between?
I think my sales, okay, because the price difference will be high, definitely. You can contact us. I am not aware because I am technical looking after, but definitely the any eco product, even this ICC plus certified products, their price wise it's higher right now. Yeah, true. Yeah, that's true. But because the right now the raw material prices are also higher for us, so that's why we need to take them higher prices for these products. But it's in the long term, we consider that when everything will goes for this type of the renewable sources, then the prices will be similar in future. No, it's not like that because there are other manufacturers, they are also producing and their prices are also higher because they also need to buy the monomer from somewhere else. And then the cost, input cost is higher. That's why this rubber cost will be also higher. Eco EPDM we are offering, only we are offering, but I am talking about the ICC plus certified polymers. So that is also offered by the other manufacturers as well. But then again, the prices will be higher for them also.
Good morning. So actually, my question is that we are using eco rubbers or ISCC plus certified rubbers. These all are raw materials or starting materials. But when we using these materials, the end product, and in this end product, how much sustainability is there? Is there any method or any quantification method that I can measure how much sustainability is there in the end product?
So if you are, okay, right. So if you are like buying ICC plus certified polymer, okay. So this will be almost 100% sustainable, mostly, okay. 100% or maybe like suppose if it is a bromobutyl, so bromine is not the ICC certified. So it will be around 92% sustainable product. So whatever the amount of the polymer you are using, accordingly, you can always calculate how much percent of your product is sustainable. Yes. So same mass balance approach you can always use in your product. But you also, if you are also selling it as a sustainable product, you also need to go for the certification, ICC plus certified. So if you go for the certification, automatically you need to declare what are the materials you have used and how much the percentage of the sustainable content it is there. And accordingly, the sustainable content of the product will come into that in the certification itself. So if your say in your product, suppose 20% is the rubber, and out of 20%, say 10%, half of the rubber you have used sustainable. So always you can say that 10% is your sustainable product. Provided if you want to increase, like Dr. Naskar is telling, to increase the sustainable content, you can always use the other sustainable ingredients as well, like fillers, other chemicals, process additives. Everything is available nowadays. So that also you can use, and you can increase your sustainability content of overall your product as well. Thank you.
Thank you.
Moving on, our next speaker is Dr. Srikala from MG University. She is, associate professor and currently director of School of Polymer Science and Technology from Mahatma Gandhi University. She is also prestigious Alexander von Humboldt Fellow from Germany. With this brief introduction, yes, I would invite Dr. Srikala to deliver your show.
New one here. The new one today's. Yes. No. This one here.
Share? Yes, sharing.
Yeah. Yes, this is. It's sharing. Yes. Very good morning to all. Thank you for the nice introduction about me. Before entering to the talk, I would like to extend my sincere thanks to the Technobiz and especially Professor Kinsuk Naskar for inviting me to this Rubber Innovation Forum. And it's mostly the first time in Calcutta. And basically, I am from Mahatma Gandhi University. And just to introduce our place, actually, this is the southernmost part of India. I am from Kerala. And the central part of Kerala, that is Kottayam, actually, where Mahatma Gandhi University is situated. And Kerala is always say as God's own country because of its nice climate, its cultural heritage, and a lot of backwaters. And there's very special about Kerala. And Mahatma Gandhi University is recently ranked among 13 universities in India as NAC in the accreditation A++ grade. And also we have NARF ranking and in the World University ranking in 500 band actually. And we received many times the Chancellor's Award also. And coming to the topic, I am dealing with the sustainability in tire technology. And we are doing some sustainable aspects, especially in the field of nano generators, introducing nano generators into the tire applications in tire. Actually, we have an ongoing project with Apollo Tires for introducing a piezoelectric nano generator in the tire layer, actually, inner layer. And as an introduction, the tire is a combination of material science, chemistry, structural engineering, and mathematics. The function of a tire, that is, as all of you know, it's change and maintain the direction of the vehicle and absorb shock from the road surface, transmit accelerating and braking force to the ground, and support vehicle's weight actually. And each component has its specific application, its specific function, and these are the very known parts of this tire, and each have its own function. And the first pneumatic tire was invented by Robert William Thomson, and is patented by Dunlop in 1888. As all of you know, Michelin in 1895 introduced a set of pneumatic tires for cars, and Goodyear patented vulcanization in 1898. And tires are manufactured using overlapping layers of fabric coat in this 1948 timing. And Michelin introduces the first radial tires in Europe, and the leading companies compete with the radial tires in this 1983. Then after 2000, there's a thorough research is going on in reducing the rolling resistance, safe comfortability, intelligent and green tires, and smart tires, introducing smart tires into the vehicles. And this is the scope for the research actually nowadays. The sustainability initiatives, we can utilize raw materials from sustainable sources, and also we can use the recycled materials and reuse it. And the flat tire technology, the technology of the tire, selection of the rubber compounds, and promising solutions for automated driving and electrification, sensor technology, introducing sensor technology, and the green tire technology. And autonomous and electric vehicles are becoming very popular, and many companies are ongoing their R&D research there. And the need for research is for stronger constructions and more robust rubber compounds, optional grip and low rolling resistance, less noise, cost-effective EV tires actually. And focusing on the lowering of the rolling resistance. Actually, what is rolling resistance? The conversion of mechanical energy into heat during rolling, defined as the force opposing the vehicle movement, and it directly influences the fuel consumption and carbon dioxide emissions. And to reduce rolling resistance, we can reduce the carbon dioxide emissions, thereby more sustainable, and lowers the environmental impact actually. And the tire tread accounts for a significant portion of the rolling resistance. Hence, we have to tailor the tread compound actually. And carbon dioxide emissions and rolling resistance, the key strategies are material selection, weight reduction, and design optimization. And I'm concentrating on material selection actually, then critical in determining the tire performance. And advances in materials to balance the durability and low resistance. Then innovative rubber alternatives are, we can utilize many other, instead of a normal Hevia NR, we can replace this NR with other Russian Dandelion, guayule rubber, etc. And they also give more advantages, sometimes more mechanical properties and advantages, more environmental effects, more environmental benefits. And you can see by using this rubber, this special rubber, we can get more sustainability. And bio-isoprene is a sustainable innovation. This development is co-developed by DuPont and Goodyear using genetically engineered E. coli and synthetic rubber production to reduce dependence on fossil fuel derived isoprene. Introducing the bio-isoprene. And another sustainable materials that can be used in the rubber compounding is soybean oil. That's a key substituent. And that has got, that extends the tire life by 10%. There is the research works. And sustainable processing oils in tire manufacturing. And we can use this oils derived from agricultural sources like palm, cashew, flaxseed, castor oil, etc. Innovative use of oils, lemon peel essential oil that enhance the tensile strength and homogeneity in rubber composites. And orange oil by Yokohama Tire, they introduced 80% of non-petroleum based tire materials, 20% reduction in rolling resistance. Then many materials, reinforcing materials using that we can use bio origin. And one important one is rice husk ash. As we know, the rice husk is highly contented by silica, and we can extract it easily. And the yield is very high, and it is commercially available, cheap material, and environment friendly, 100% sustainable. And another filler is a lignin, and we can get both these in the nano size, nano filler as we can utilize in the rubber. And this innovative biofillers, BioTread by Goodyear, starch-based filler that replaces silica and CB. That's the carbon and silica that also can be used. Enhanced rolling resistance, reduced tire weight, lower energy consumption during production. And these are these benefits. And these are the cellulose-based materials used in the rubber industry. Then we can utilize this cellulose-based in various parts of the automobile parts. We can selective parts you can use in the exterior components like these, and interior components, speakers, carpets, and many applications inside the automobile. We can utilize this sustainable materials. And the recycling is one of the main strategy, and it is already utilized by many tire companies. And you can see the pyrolysis process. This is the recovering carbon black is already by Continental Tires. They use the pyrolysis process for recovering the carbon black, and that can be again utilized. And the sustainable carbon black by Black Cycle Group, and they also use this same technique, the pyrolysis. And the benefits of sustainable carbon black is they are giving improved strength, enhanced electrical conductivity, and a better rolling resistance for tires. And hence the recycling of tire, this is a very good initiative. And Michelin's vision is 100% sustainable tires by 2050. And because they can rely on butadiene monomer that is synthesized from ethanol extracted from biomass like waste food, rice husk, or corn stover that is left unused in the agricultural land. Then that can be, if we utilize this kind of material, integration of 4.2 million tons of wood waste into tires we can incorporate. Polyester yarns, regenerated textiles from PET plastic waste we can convert if we use this integration of 4 billion plastic bottles waste into the tires. Then utilize the natural rubber. It is underutilized actually. Michelin is committing more towards supplementing the renewable rubber or the natural rubber, different varieties of natural rubbers in different parts of the world. And styrene monomer can be for synthetic rubber can be derived from waste polystyrene. And 80,000 tons of polystyrene waste, that's a very large quantity of polystyrene is in the waste form that can be integrated into the tires. Carbon blacks, as I mentioned earlier, recovered carbon blacks from end life of the tires. 56 million used tires can be recycled. Then non-toxic resins, high performance resins from resorcinol, formaldehyde, or isocyanate is used. And with that, they aim 100% sustainable tires. And the recycling of the cross-linked tires that we already mentioned, waste tire pyrolysis, and yields valuable byproducts with the pyrolysis oil and carbon black. And this can be again utilized. And there's a potential use in tire trucks actually. And sustainable initiatives, these are some of the sustainable initiatives by various companies initiated actually. And these are the various materials, sustainable materials again, that can be utilized in the tire manufacturing. Various, all are 100% sustainable. And sustainable nano generators, one of our main research area is developing nano generators, fabricating, and the introducing sustainability also in the nano generators. And this can be effectively introduced into the tire for monitoring, for the real-time monitoring of pressure, temperature, or tread wear into the tire to make that smart tires in the modern day actually. And this nanorator offer a promising solution by harnessing energy from the tire motion to power internal sensors, and thus enables continuous monitoring of tire parameters without the need of external batteries or frequent manual intervention. And the power generated is a very lower amount nowadays. The research work is going on only, and the nanotechnology can do something, and it can, if the higher amount of current can be produced, then it can be utilized for more actually. And these are exploring various nanomaterials for converting mechanical and thermal energy into electrical energy. That's the flexible nano generators. We can synthesize, we can fabricate nanogenerators, that is from various, the piezoelectric effect, triboelectric nanogenerators are there, then from photovoltaic effect, pyroelectric, and thermoelectric effect. We can fabricate various types of nanogenerators depending upon the material and also the dynamic or what is the mechanical or electric heat energy which is available. And these are the carbon-based nanoparticles in nanogenerators. And we can effectively utilize the various forms of carbon-based nanoparticles. 0 dimension to 3-dimensional carbon-based particles are available. And that can be effectively utilized. For example, graphene is a very good material, which is more conducting. And normally in the nanogenerators, barium titanate is a very good material used in the nanogenerator for onboard real-time tread wear monitoring. And I am mentioning some of this published work in the field actually. And this already they have succeeded in this work. And zinc oxide grafted barium titanate. And we can replace, normally the PZT is used in the piezoelectric generators. We can remove by the more lead-based systems by other systems, and will be more sustainable then. And here we can see the monitoring, the tire pressure monitoring system. We can introduce nanogenerators, and we can use the sensor for pressure variation. And this is another work on dual function, more textile based tire nanogenerators that is introduced inside this one. And the nylon textile is serving as an internal tire cord material for triboelectric positive layer, and triboelectric negative layer will be there. And this is the functioning. While rolling the tire, the electricity is created by the mechanical force there. And this is another work on on-vehicle triboelectric nanogenerator for self-powered sensor for tire pressure monitoring. And the fabrication and insertion into the tire is different in different work actually. And this is the compressible hexagonal structured triboelectric nanogenerator that can be used harvesting tire rotation energy, and that can be also used for monitoring the tire pressure and other slide sensing systems actually. And these are various, this is used for LED lighting actually. The during the motion of this tire, the mechanical energy is converted by triboelectricity. And the future scope is introducing the nanomaterials. Maybe the natural rubber also we are utilizing to generate more output for these nanogenerators. And we are utilizing the mexene. Mexene is a very novel nanomaterial, and this mexene can be introduced into the natural fiber and other systems and we can tailor the system for the desired properties of the nano generator, and we can get more power actually to this, and we can introduce the nanocellulose, actually the more sustainable materials we can utilize. And this is the challenge is difficult to build a competitive process to replace fossil fuel derivatives actually. And more research is needed to conserve and improve resources and change the way of development and usage technology. And we have to go to more sustainability in all aspects actually. And I would like to introduce the ongoing research work at Mahatma Gandhi University. And we are concentrating on all these types of works there. One is mainly on nanogenerators, and another one is the bio research actually. This is tissue engineering, wound healing applications of these nanomaterials, and MOF modifications of aerogels actually. The cellulose nanofiber, extensive research is going on in cellulose nanofiber and aerogels out of cellulose nanofiber. And it is MOF modified for gas sensing applications. And this is the green tire technology. We have two projects with Apollo tires. One is on introducing cellulose nanofibers onto the material of the tire material, rubber compounding. And the another one is the introduction into the sustainable nano generator into the tire actually. And the green tire, the research work is going on there. And this is edible coating, and for the vegetables and fruits, the sustainable edible coating, that is one area of our research. And the water remediation, introducing many biosustainable polymeric films, especially from starch chitosan blend. That's a very good blend, and that we can make it to a foam. And cellulose aerogels can be made into foam. And these foams, aerogels, are very good in the water remediation, removing heavy metal ions, and also the microplastic and nanoplastic removal from the water body. And several projects are there. And these are the main areas we are concentrating. And in our laboratory, we are utilizing the PVDF for the nanogenerators, PVDF-based piezoelectric nanogenerators in order to introduce into the tire. And that is, we are in the first phase of the study, and for more flexibility, we are blending PVDF with the polyurethane, PVDF polyurethane blend, and then reinforcing it with the silicon dioxide grafted graphene oxide. And these are the characterization part actually. And yes. Okay. And this is a piezoelectric nanogenerator we fabricated with the PVDF and polyurethane. And these are the, we know that PVDF beta phase is a highly piezoelectric, and we can find several applications other than tire with the motion of the human movement, and also various applications in biomedical devices, in biomedical applications, and in every area we can find the application of nanogenerators. And automobile industry is only one. And these are some other research areas we are doing in the water remediation, the biomaterials like carrageenan beads. Then this is chitosan, is a very good material for several applications. This for water purification we are utilizing. And this I already mentioned, edible nanocoating. And this is the tissue engineering, the electrospinning technique we utilize for fabricating the tissue engineering, the wound healing applications actually, and conducting various studies. And this is the gas sensing applications with the metal organic framework, cellulose aerogels. And this is one of our main work, utilizing the biopolymers, and is the main strategy of the polymer department actually. And here we utilize biopolyurethane, synthesized biopolyurethane from natural rubber. And normally it's an isocyanate pathway for polyurethane synthesis. But here starting material is natural rubber, and we convert it to polyols, and then with through a non-isocyanate pathway, we synthesize biopolyurethane, and that can find several applications in various fields actually. And that's about our work. And I just want to introduce the school, the new school started at Mahatma Gandhi University, and by a Clarivate analysis, we are placed in the first place in Polymer Science Department. In Mahatma Gandhi University, we started School of Polymer Science and Technology in 2023, offering a master's program in Industrial Polymer Science and Technology, and also an executive MTech program for employed persons from industry and institutes. We are starting this year, and in for executive MTech program in polymer science and nanotechnology. And the peoples who are working in various industries or research institutes can join for their MTech. Who are interested to get in polymer technology or nanotechnology can join. And also we are conducting several certificate courses and postgraduate diploma courses in the school. And I bring your attention to the new, the proposed conference, Polymera 2024 from December 1 to 4. And that is doing in collaboration with IIT Kharagpur, and Professor Kinsuk Naskar is also one co-chair of this conference. And that will be from 1 to 4. And I invite all of you to join this conference. And the first day of the conference is at a specific workshop on 3D printing. And we are concentrating on the 3D printing. We have a bio 3D printing unit, a very new, highly sophisticated bio 3D printing unit there in our, we have a nanomedicine section. And we are conducting a workshop, one-day workshop in collaboration with the IIT Jammu and also the Sri Chitra Institute of Science and Technology in Trivandrum. And this will be one-day workshop. And I invite all of you to be a part of this conference. And thank you for your attention.
Madam, can you hear this?
Bridging the industry and the learning application. I saw in the second last slide, there is a course which says bridging for application, industrial application.
The last but one slide, that is a program, yeah? Yeah, the MTech program. That's an MTech program in polymer science and technology. That will be for international students also can join, and outside the state also can join. That will be in online mode. And sometimes the exams will be offline, and that will be conducted in hybrid mode actually. Yeah, 2-year program. 1 year, for 2 semesters will be there, and the 1 year will be the project work actually. That is mainly, there are several inquiries from industry people, and that is started especially for industry people actually. Yeah.
Okay, thank you. I think we have to go by the time. So please come here.
Big hand, guys. Come on. Yeah. So we have Mr. Mehul Patel, sir, is going to be given next talk. Yeah. Okay. Sir, can you share your screen so that we get started?
Okay.
Yeah. Can you put a presentation mode, sir? Okay. All good. Yeah. I think, those of you in the rubber industry in India, one person that everyone must know is Mr. Mehul Patel, sir. Okay, currently is a part of the Elastomics as a technical director. He's going to give a talk on the bioadditives for the rubber and tire industries. What are the new developments? Biopole. Yeah. So join me to welcome Mr. Mehul Patel, sir, to give a talk on the developments in the bioadditives for the rubber industry. Over to you, sir.
Thank you, Mr. Peram. Thank you, everybody, for joining me this morning. I appreciate your presence. I apologize for not being physically present today. Obvious reason was yesterday, the problems which were there in Kolkata. Thanks to Technobiz for arranging this hybrid session for me, and I'm very grateful for the same. Since yesterday, friends, we have been hearing about sustainability and biodegradability. I'm here to add some more points towards the same, actually. I'm not able to change my slide. Okay. The topics which I'm going to be covering today are the critical role of sustainability and biodegradability, Biopol, our journey and milestones, Biopol's impact in rubber compounds, a comparison with conventional chemicals, and key takeaways and future outlook. As all of you know, sustainability could be from the fresh resources, the green resources, as well as from the recycled materials. All right, so here is the definition of sustainability. It refers to the ability to maintain or support a process, system, or activity over time without depleting natural resources. This is very important, and causing any harm to the environment. While biodegradability is the material which would tend to biodegrade on its own after 3 months, 6 months, 1 year, or whatever, actually. And it's very important to have a good biodegradable material present in your compound. Biopol, for that matter, is not only sustainable and biodegradable, but it is also meeting all the compliant to all the regulations from Europe and USA, as well as it is made from the natural resources. You know, I will be telling you something more about this little later. What is our vision? Our vision extends beyond business success, not the only reason why we are here in this business or with this product. We strive to foster inclusivity and global stewardship, setting new standards for environmental responsibility across the industry. So that is very important. And with this vision, we are going ahead to offer the biodegradable material and biosustainable material for your applications. Our mission is, it's a bio-based science, and fractionation is the process which we will be following, or we have been following to produce our products. By replacing harmful chemicals with our eco-friendly solutions, we aim to prevent toxic pollutants in the ocean and waterways, safeguarding marine life and promoting a healthier, more resilient environment, not only for the marine life, but also for the human life here. So it's very important that all the rubber industry personnel use the material which are, biosustainable and bio-based material and non-harmful materials. Yeah. These are the 3 types of materials which we want to offer, or we have to offer. First one is the Biozone. As you can see, Biozone 200. This is an anti-ozonant which will replace some of the anti-ozonants currently used by the industry. Then this is BioVive 300. That is an antioxidant which will again replace the currently used antioxidant. This is BioGuard 400, and these are the retarders. This material will tend to give you the retardation effect during your processing. All these 3 products which we are offering today are natural, of course, made out of natural resources. They are circular, from dust to dust, or the soil to soil, as we call. It does not contain any harmful chemicals, and there are no microplastics present also in our product. Believe me, these bags are also going to be biodegradable bags. So everything we are going to be offering, it's a total composite biodegradable material as well as biodegradable bags packaging. Now, this is the photo of our plant. As you can see, our materials are made from the cotton waste, and the biofunctional plant, a biofractionation plant is seen here. All right, this is one part of the plant which we have just photoed here. The plant is located in Dudapur village, which is north of Ahmedabad in Gujarat. Is about 100 kilometers north of Ahmedabad in Gujarat. And it has already started functioning, and we are ready to offer the material as on today. What has been done is that we ensure the personal procurement of biomass, the cotton waste or cotton stock, which is used to produce these materials, we have what we call is biopol program. This biopol program, carries along with them the farmers, the aggregators, the raw material suppliers, and all other people who are getting involved with this process. So we ensure that the personal procurement of biomass from farmers within a 15-kilometer radius, as on today, at our own expense. So we have already tied up with all these farmers to ensure that we get the constant supply of the raw material. Apart from cotton stocks, we have been working on the rice straws, Juliflora as well. And for any reason, if cotton stocks are not available tomorrow, if they are in short supply, then we will be able to switch it over to the other raw material which are also available plenty in that area actually. Now, we have been working on the development of this product for last over 7 years. Fine tuning has been done to a great extent now. Of course, there is still always a possibility of further fine tuning to take place to improve the performance of the product in rubber compounding. We are focused on creating commercially viable and sustainable solutions. This particular technology which is available with us has been patented in USA, and it is, going very fast in USA as well as in European countries. In fact, last month we were in Europe and we have got very good response, very good interest from the European manufacturers as well. This is in collaboration, as I told you, it's in collaboration with the farmers. We have already tied up 965 farmers as on today. And we are working further on, more and more farmers to get tied up. So we don't have any problem on raw material availability. It's going to be obviously creating positive impact and community development while doing this. So that is the reason I told you that it is not only financially or commercially oriented venture, it is also from our heart, we want to make sure that the life of human being improves and the environment on the earth also improves in future. What is the current issue? I think most of you would know that 6-PPD, which is an anti-ozonant used by the rubber industry, is a problem and is likely to be banned in very near future, particularly Europe and US and other developed countries. What happens is that when the 6-PPD gets exposed to the ozone environment, you form 6-PPD quinone, which is a toxic substance, and that is not allowed. So when the tire wears down, the material would ultimately end up in either a still water or a river or somewhere where the fishes are present, and it will endanger the fishes which are present or the other marine life which is present in the environment. Industry currently has no viable alternatives to 6-PPD. There are a lot of R&D going on to replace 6-PPD from many other angles. The 7-PPD is being done. There are other bio-based materials which are being worked on. I mean, my previous speaker spoke about lignin, for example, not as an anti-ozonant, but as a filler, which is being done. So all these things are happening. And here we are ready with the material, establishing ourselves in the industry and offering the material to replace 6-PPD. I will be obviously showing you some compounding data also subsequently to indicate how it works, in the rubber compound. The issue with 6-PPD, toxicity to aquatic life, as I already told you, pollution during production. During production of 6-PPD also, it can be harmful to the human being who are exposed to the 6-PPD material. Persistence in environment and regulatory concern. Of course, this is very important. Cal 65 or Prop 65 in USA, California 65 or Prop 65, or the similar European Union regulations are creating problem for 6-PPD to be used. Most of the tire companies whom we spoke and most of the rubber companies whom we spoke in Europe particularly told us that by 2030, they wish to have at least 70% of their products, the additives converted to bio-based materials. And hence they showed great interest in our material as well. Now, this is the video where, our incoming raw material, the in-process raw material and the final product are being tested. The lab is equipped with very modern machines, very modern equipments. All right. So it gives you some insight about the product quality which is going to be coming forward. Sorry, have to escape this maybe. Yeah, okay. Okay. Our products, all these three products which I've told you meets the rich requirement, the pH, SVSC, Cal 65, EUDR, you must have heard about, which is coming in force from January 25, and ROHS, the health hazard. All these health hazards are taken care in our product actually. So we will be able to provide you certificates towards this if you want. Now let's get into the rubber compounding. What we have done is that we have taken natural rubber and SBR combination, a typical tire trade formula, may not be a current one which is used by the tire industry today, but 47 PHR of HAF and about 7-8 PHR of aromatic oil. Of course, aromatic oil is not the one which is to be used today in today's time. The bio-based, like my previous speaker spoke about soybean oil, or there are materials which are soya-based derivative oils which are available. This could be added. Here in our case, we have replaced TDQ 1.5 PHR and 6 PPD 2 PHR with 3.5 PHR of biopol. Now, biopol, when I say, it means 1.5 PHR of bio 300 and 2 PHR of biozone 200. Put together is 3.5 PHR here, right? Against 1.5 and 2 put together is about 3.5 PHR. So it is a nature rubber-based formula where this thing would be very important. Ozone resistance and oxidation properties are very important. Here are some of the physical properties. The hardness is going up slightly when you add biopol. This is one thing which we observed is that the viscosity as well as hardness increases when you add biopol in the formula, but it's manageable. It's not increasing too high. Tensile strength drops by about 2 or 3% or 4% at the most. But other physical properties, if you see the aging properties, after aging properties, with regular TDQ 6 PPD, the drop in tensile strength was minus 6.6%. Against that, with biopol, it is minus 1.51%. And drop in elongation and break was minus 19 and minus 9.41. So antioxidant properties are good here, comparable here, I would say. At the same time, ozone resistance, and if you see 50 pphm, 20% strain, with 6 ppd and TDQ combination, these cracks started getting observed after 24 hours. While when biopol, the compound which had biopol present, it started cracking. Minor cracks were observed after 48 hours. Started cracking after 40 hours. So it's almost 100% improvement here, I would say. I don't want to claim that it is always going to give you 100% improvement, but at least it will be 10-20% better than the regular combination of TDQ and 6 ppd. Now, since the biopol is slightly polar in nature, we thought of trying in nitrile rubber also, nitrile being polar rubber. So in nitrile rubber 35L, which is the 33% ACN containing rubber, we thought that we should try biopol as a what you call synergistic material. So we replaced TDQ with biopol 1 PHR. So TDQ and MBI antioxidants in formula number 1, and the formula number 2 is biopol and MBI antioxidants, which are present. Everything else remaining the same. These are the rheometric properties, and to our not to our surprise, really, we were expecting the TS2 value to go up, but the T90 value slightly came down. So that is a bonus, actually. I mean, even if it does not come down, even if it remains the same, the increased scotch time is definitely going to be helpful to the rubber industry during processing, during extrusion, or during molding, or during calendering. You obviously want to have higher scotch time and same cure time or a lower cure time. So here is the case where the scotch time has increased and the cure time has gone down slightly. As I told you earlier, one of the observations which we have made is the Muni viscosity goes up. Even at a low level of 1.52 pHr or 2.5 pHr biopol present in the compound, the Muni viscosity goes up. It can be advantageous, it can be disadvantageous. So you need to take care of this particular property when it comes to producing a particular product in your factory. MH value, since the ML value has gone up, the MH value is also gone up slightly. Now let's look at the physical properties in nitrile rubber. The hardness came out to be the same. Here, since maybe because of polarity, the tensile has gone up from 182 kilogram to 186 kilogram per centimeter square. The elongation has dropped slightly. And after aging properties, 100 degree, 48 hours is quite critical condition to expose the samples to. At that level, the after aging properties like tensile strength and elongation and break are more or less same. In fact, elongation and break is slightly better as compared to the regular TDQ MBI combination. Yeah. We also thought that we should try out the BioGuard, which is a retarder, in while replacing PVI. So formula number 1, there is no PVI, there is no biopol. Formula number 2 has 0.5 pHr of PVI. Formula number 3 is 0.5 pHr of biopol, replacing PVI at the same level. And formula number 4 is, doubling the biopol content to 1 pHr instead of 0.5 pHr of PVI. And if you see particularly you would be interested in, when it comes to PVI, you are interested in the scotch time, 3.74 minutes without any retarder in formula number 1. With PVI, it went up to 9.07. Considerable improvement was seen. But with biopol also from 3.74 at the same dosage of 0.5 pHr, it has gone up. And at 1 pHr, it has gone to 5.95. Now, you would appreciate, and here also is the case where, the cure time is not going up so much. You would know that always when you think of PVI, you don't have to have so much of scotch safety. If you are having a problem of scotch to a small extent, you can consider this biopol material in the formula and take advantage of, whatever improvement you see in terms of the scotch safety, and also take advantage of the techno-commercial benefits, because biopol obviously would be much cheaper as compared to PVI as retarder. Yeah. Now, when it comes to the physical properties, we don't see much difference. No retarder versus the biopol I'm talking about. You see, the slight addition of biopol has slightly reduced the tensile strength, but that can be managed very easily. Now, modulus is going up slightly. As I told you, the stiffness goes up slightly. So MH value, modulus, the Muni value, all these goes up when you increase when you add the biopol in the formula. All right. So it's not significant differences there, but definitely there is a difference which is observed. Now let's talk about, I'm trying to give you the straight comparison with Biozone 200 and 6-PPD. The point here I would like to mention at this stage is that Biozone 200 is a slightly polymeric material, number one, and it does not melt, unlike the 6-PPDs or TDQs, TMQs type of materials, all right? The melting point is much beyond 300 degrees centigrade for Biozone 200. So since it is polymeric material, it will not tend to migrate from one end to the other during storage of the final product, cured product. And it does not give you any staining, all right? So that is one of the advantage when you talk about replacing 6-PPD with Biozone 200. 6-PPD is synthetically made. This is a biopolymer. You know, it's a bio-based material. As I told you, cotton stalk is used to produce this material. So it's a biopolymer. Since the molecular weight is in the region of about 5,000, 7,000 numbers actually. Okay. It is high molecular weight, low molecular weight, obviously. Non-extractable because of the higher molecular weight, while 6-PPD is extractable material, all right? So the acetone extraction, or of course, it's not water extractable. 6-PPD also, IPPDs were water extractable, but 6-PPDs can be extracted in presence of any of the solvents. So that could be a problem, which would not be the case with Biozone 200. It is not eco-friendly, obviously. This is eco-friendly, potentially toxic, non-toxic, derived from non-renewable sources, derived from renewable sources. Every 3 months, we have, the crop of cotton stalk coming up. So it is definitely, and it is dust to dust or soil to soil, actually, you see. Superior long-term protection may degrade over the period of time. And it is an innovation solution. This is an emerging technology, while this has been used for a number of years together. The issues with TDQ, toxicity, skin and respiratory issues it can create, environmental harm, harmful to, if it is persistent and constant exposure to human being also, it can be harmful. It alters the rubber properties, temperature limits. It is ineffective at high temperatures. Now, my experience here, I would like to share, if you put two different dumbbells, one containing TDQ and the other not containing TDQ, no other antioxidant present in the second formulation. If you were to expose it for some time, let's say 100 degree or 80 degree for 24 hours, 48 hours, it could happen that the TDQ from one compound will migrate to the next compound, which does not have any TDQ, and give you better physical properties after aging physical properties. So this migration is possible with TDQ type material, which is not the case with biopol material. Again, non-renewable, obviously, and this less sustainable, this thing. When you compare 1 to 1, it is non-volatile, volatile, does not migrate, it can migrate, it will have a tendency to stain. This does not stain. At this stage, I would like to tell you that our material is brown in color. It's a powder which is brown in color. So when you add it to your colored compounds, it can change the color. Whatever color you get the first time, the same color would continue to be there for next 3 months, 6 months, 8 months, unlike the TDQs and 6-PPD, which can give you the staining problem and change the color of your product over the period of time. Does not interact with peroxide. This being a polymer, it does not interact with the peroxide. It can interact with the peroxide. It is REACH and FDA compliant, may not be REACH and FDA compliant, stable and unstable, to the acidic and alkaline environment. Now, as I told you, our material is brown in color. Of course, we are in the process of converting this powder into pellets also. So, which would be also sustainable pellets using the sustainable polymers as the binders, which would come in future from our stable. But this powder is about 300 mesh powder. Hence, you'll get very easily dispersed into your rubber matrix. And once it gets dispersed well into the rubber matrix, it's going to do its job actually. You see, sitting every corner of the rubber matrix, Is going to give you anti-ozone and antioxidant properties. So at the outset, I would like to conclude that bio-based rubber additives have the potential to replace conventional additives which are found to be harmful. All right. In next 5 to 7 years, we expect the developed world, and slowly it is creeping into our country also. We have had opportunity of talking to a few tire companies in India also, and they have shown great interest in trying this out. And in fact, we have already signed 1 or 2 NDAs with some of the tire companies here for the trials to be taken in their tires, and see how they can improve their product as well as how we can, improve our product as well to meet their requirements. So as I told you, European customers have encouraged us considerably in last 2 months' time. Talking to us on a regular basis, willing to take trials, have gone ahead with taking some trials as well. So we are very encouraged to promote this material, and we feel that the Biopol would obviously lead the way in future to come. I would like to acknowledge Technoviz for providing the platform to present this paper. Once again, for allowing this hybrid session to take place. Biopol's management for their unwavering support, my co-authors for their valuable technical contribution, and the audience, of course, you are the most important for all of us for your patience and engagement. Remember, Biopol is leading the way in sustainable additives. It is a green chemistry and it provides the lasting solutions. Many of you would have questions about its availability as well as the pricing and all these things. You can reach us out at any of these contact details which are provided here. We will be too pleased to support you with the data. Thank you very much.
Thank you very much, Mr. Patel, for your
Yes, please.
excellent talk, and it really addresses very important issue of the rubber industry these days. Okay, so I also would like to inform that Mr. Patel is also responsible for ACS Rubber Division coordinator. So you can also address all the delegates present over here to become the member of ACS Rubber Division as
That
well.
would be nice, sir. This is a good opportunity you're providing to me. American Chemical Society obviously is based out of America, and they have a rubber division where they organize a lot of seminars, webinars, exhibitions, and all these things. They also come out with 3-monthly publication called Rubber Chemistry in Technology. So members who are, American Chemical Society members who are members can obviously attend these webinars and attend these seminars and the exhibition practically at no cost to them actually. The normal American Chemical Society membership fee is close to about $300. But if you are an Indian Rubber Institute member, IRI member, we have an understanding with American Chemical Society, and you pay $25 every year, and you can take advantage of these webinars. Last year, for example, we organized along with ACS, we organized 16 formulating Fridays, they call actually. So every Friday there was a lecture on different topics, either synthetic rubber or testing or making a formula or extrusion or calendaring and things like those. So 16 Fridays, there was a presentation from different speakers from all over the world. Where members can attend these webinars free of cost. Only problem is that these webinars are at the night time, 8:30, 9 o'clock, 9:30 or something, because the American time is 12 hours ahead of us, or not ahead, behind us actually. So when they start speaking in the morning, it will be night in the Indian subcontinent. Yeah. But you can certainly take advantage. You can visit their RCT, which is a very good publication they come out with. I'm sure Professor Naskar also has some papers given out to RCT,
yes,
you know.
yes.
Yeah, yeah. So whatever, new developments which are taking place, they are being published in RCT, Rubber Chemistry and Technology, and you can take advantage at no extra cost of $25. So if you are interested in joining American Chemical Society, please approach your branches, the IRI branches. For example, we have branch in Calcutta, whom you can approach, and they will tell you how to become the ACS member. Or if you have any difficulty with any of your branches, you can, approach me directly, and I will be too pleased to guide you. We have almost 250 members from all over the country becoming ACS member every year. And that continues for last 22, 23 years. It has been continuing, and we hope to have new members also joining us for this same membership. Thank you.
Thank you very much. Maybe one quick question. Yeah.
Yes, please.
thank
I am Karika Sakaro from Prince of Concord University in Thailand.
Sorry, I'm not able to hear you clearly since I am online. Is there any way it can be made better?
Okay. Can you hear me better?
Yeah, little better. Go ahead, please.
Okay, I try to speak louder. Concerning one of your results, comparing between 6 ppd that used together with GDQ, and you compare with your biocoal product. Okay, the aging properties seem to be foreign, and you show the ozone resistance, but I wonder whether that is based on static or dynamic ozone resistance test, and have you done both of that? Because 6 ppd is also good for dynamic anti-ozonance, and have you tested the fatigue resistance? Because one of the problems that we cannot really compete with 6 ppd because they provide three properties: antioxidant, anti-ozonance, and anti-fatigue. So I don't see a complete picture of this additive if we want to compare with 6 ppd. So have you tried testing those also properties? So,
Yes, I was expecting this question, madam. Thank you for your question. There are two ways of looking at this particular question. Is that 6 ppd can also be used for non-dynamic application, as you would know. So the non-tire application, when it comes to 6 ppd, does not call for the dynamic properties. Only when it goes to the tire application or the such dynamic applications, there the DMA will have to be done. We have done the DiMartia flex testing, and the results are very, very comparable. And the reason why we have tied up with couple of tire companies in India is to find out the dynamic, properties, the rolling resistance, the heat built up, and things like those. But in the meanwhile, since our quantities are not very large as on today, we are more focusing to the non-tire applications. And the sheet manufacturers, the conveyor belt manufacturer, hose manufacturers, oil seal manufacturers have already started getting into this and started using this material actually. So to answer your question, DiMartia testing has been done, though I have not projected here, but DiMartia testing has been done, and it has been found to be similar. The other dynamic properties have not yet been tested. I think within a month's time or month and a half time, we would have those data also available with us. That is the time when we will think of approaching tire industries also. Because our quantities is likely to be increased, in future as well. So that is the answer.
Okay, thank you very much. Okay.
Yeah.
Thanks for it, Mr. Patel. Okay.
Yes, please.
Okay, thank you so much.
Thank you very much, sir. Thanks a lot.
Yes. Our next speaker is Dr. Nivedita Kashyap. I think it is the last speech before the break for the topic. She did study in Calcutta University, Polymer Science, and then afterwards she did PhD with Professor Bhaumik in IIT Patna. That time Professor Bhaumik was the director of IIT Patna as well. And now she's in the SI Group, India, and she'll be talking today also on sustainability aspect. She'll give an overview on recent developments on sustainable additives for tires and technical rubber goods. With this brief introduction, please join me in welcoming Dr. Lakshmi.
PDF, that's right.
Okay. So, good morning, all. Today, I will talk on some sustainable initiatives that SI Group is currently working on for tires and technical rubber good. Since morning, we have heard about that from the Arlancio that they are working on the sustainable elastomers, and also last session it has been a very good session for the 6 PPD replacement. I will quickly go through overview about SI Group is doing currently in that sustainable mobility, and mainly two additives I will mainly talk about. One is that biosourced rubber curing accelerator. It's commercially we have branded it as Nogat BioExcel, and second one, it is a antioxidant used for the manufacturers of elastomers, which is a replacement of TNPP. So TNPP now it's regulated and restricted by European Union and US from last 10 years. Just I'm quickly going through what is SI Group. So SI Group is a global leader in making additives both for rubbers and plastics, and also in the field of antioxidants. We have mainly 3 divisions in polymer solution, industrial solution, pharmaceuticals. So like I am working with Polymer Solutions Group, which is taking care all the additives and antioxidant that is made for the tires and rubber industries. We have 20 manufacturing facilities along with 2 innovation centers, and we are spread all over throughout the world, and our headquarters is located in Houston in Texas. So SI Group has sustainability developments also focused on 5 main key areas, and to improve ourselves in the sustainable development, we are continuously working on to few things we are focusing on, right, to make our products more sustainable, more HVAC compliant. Like we are trying to reduce the toxicity profile of that existing products portfolio, and also by introducing the bio segment in our product, so that customer can use it for long time without any complaint, because this SVSC and the regulatory concerns is very dynamic. They will change every year. So accordingly, we are developing a product so that it can exist for longer time. And for that, like SI Group, we have our products for the tires and technical industry in the field of resins. We are making phenol formaldehyde resins, and SP1068 is a very well-known tackifier which is used all over the world by all the tire industries and in the TRG segment. But currently there is a regulations coming in Europe and USA to reduce the HVAC content that is present in the SP1068 tackifier. So we are working on to make this product more regulatory compliant by reducing that HVAC, bringing down to below 0.1%. And in the bonding resins portfolio, like bonding resins, normally resorcinol monomer is that widely used in that making the bonding resins, but resorcinols is also has regulatory concern because it easily goes in the water, and also during the vulcanization it will release in the environment, that is harmful for the worker. So that's why SI Group has already developed a bonding resin which is completely resorcinol free, Elastobond BA3410. It has up to 30% of bio content present in it, and we have compared that performance of this product with that conventional resorcinol based resin, and it delivers equally comparable performance. Now, today I will talk on this bio-based accelerator, that is Norgard BioXcel, and in the second part I will talk about that Western 705T, which is the nonyl phenol-free secondary phosphate accelerators. Coming to the Norgard BioXcel has around 85% of bio content, and nitrosamine nowadays a concern. It generates during the vulcanization, and again in some cases is carcinogenic. So Norgard BioXcel does not contain any harmful nitrosamines that listed in the TRGS 552. We have done some study on how that Norgard BioXcel is different from the conventional accelerators. So this is a volatility profile, and here we have compared with the conventional accelerator, which is TMTD, TETD, and morpholine type. And you can see the boiling point of all the accelerators is below 100 or somewhere around 150 degree, where that volatility of that Norgard BioXcel, it's more than 150 degrees centigrade, close to 200. So during the vulcanization temperature, the possibility of release of the Norgard BioXcel in the environment will be very less. And when it reacts with that NOx that generated during the vulcanization process, it will generate the nitrosamines. So the volatility of the nitrosamines generated from the BioXcel will be like its boiling point is above 300 degrees centigrade. So thus it makes a much safer option to using as an accelerator compared to the conventional accelerators, which is TMTD and TETD. And apart from that, due to its chemical structure, it will reduce the blooming and discolorations, and it is compatible with almost all types of natural rubber, suitable for both black and colored applications. So DPG now it's nitrosamine free, but currently there is regulations which is imposed on DPG by the European Union. It is proven as a reproductive toxin under the category of CA2 and also under the category of CAT1B. So under the category of CAT1B, it is restricted to use for any consumer applications. And there is some study already carried out which shows that DPG is found in the water leachable component, which is leached from the rubber articles. So in our lab, we have carried out some study with BioXcel, and we made a silica straight formulation with DPG and the BioXcel and carried out the water leaching study. So what we have found that in the water extract, the DPG is present at an amount of 3.6 ppm, but Norgard BioXcel is below the detection limit. Now, if we look at that concentration of DPG and BioXcel present in the rubber, it's slightly different, because when we made the formulation, we found that the Norgard BioXcel is effective even when used half of that amount of the DPG. So here we have shown some data for the silica trait compound. This is a high silica trait compound, normally used for that low loading resistance PCR tires. And for that, currently it is interested for the EV vehicles also, because that EV vehicles, it needs to be fuel economic, and to reduce the trade wear, that silica trait compound will be interested for that EV vehicle manufacturers. Now, if we look at the formulations, the DPG we have taken around 2.2 pHr, but BioXcel in the first formulation, we have loaded 25% of that of the DPG, and is the third one, it is 50% to the DPG amount. If we look at the cure characteristics, that DPG, like it's shows a like cure curve, and there is no scorch delay, but a scorch delay is observed in case of BioXcel, and which makes is more safer in terms of vulcanization and provides more scorch safety. For all the cure characteristics, it reached a plateau like the DPG. So cure characteristics, similar type of cure characteristics can be achieved with BioXcel as we are getting with the DPG, and Muni viscosity value are also comparable. Let's have a look at that cure properties. Like we have measured that scorch time, that is T5 at 135 degrees centigrade. So when we increase the loading to 55%, there is a reduction in the scorch time. but at the 25% loading of that DPG, that almost similar performance of DPG and BioXcel has been shown. And TC90 also similar type of characteristics has been observed. The maximum torque that is related to that crosslink density is similar for all the three recipes. In the right side, we have shown that G dash, that is the uncured modulus. Now, uncured modulus we have measured during storage, because what happens, silica is being polar in nature. When we store the compound, uncured compound, there will be rise in that storage modulus. Now, DPG stabilizes because it's basic in nature and it will interact with the acidic surfaces of silica, and then it will stabilize that modulus during the storage. So we want to see whether the similar kind of effect that BioXcel can deliver. So what we have seen, even after the 7 days of storage at 2 different loadings, there is no significant increase in that uncured modulus. So which refers that BioXcel can also offer the similar type of like Muni viscosity stability during the storage condition. We have also detailed data, detailed work which is done on that BioXcel, where we cover all the mechanical property testing and dynamic properties. But due to the time constraints, I am not going into much details. So in summary, we can say that with what we have observed, BioXcel when loading at a 25% or 50% of a DPG, we have seen improvement in the low temperature performance, that is ice and snow traction, rolling resistance, and wear abrasion. Also, the mechanical properties that we have tested, the performance was at par with that of the DPG. It indicates that the DPG, that Naugaard BioXcel can successfully replace DPG in the silica trait formulation. Now, apart from tire formulations, TRG is another segment when BioXcel can be used. What we have found that BioXcel is can successfully replace when used synergistically or alone in many of the TRG applications. So, which covered EPDM rubber for generic hose applications, nitrile rubber, and natural rubber. It is very efficient for that vulcanization systems, and when acts as a sulfur donor. It says 85% of bio content, and it is present in 2 forms. Like we are offering 2 forms, one is solid, another is the liquid. In the solid form, it is dispersed with a carrier. So tire industries is preferring solid form. That's why we have come up with the form. But when you are doing the formulation with the solid form, it is 70% active. So you need to balance your formulation accordingly. But the liquid form, it is 100%. So it can exactly like lower its doses half of the DPG and can get the similar performances. I am going to that second part of my discussion, that is Western 705T. So Western 705T, it's a secondary phosphites. Normally when we making the elastomers, so 2 types of antioxidants are used. One is phenolic, another is the phosphites. Phenolic antioxidants mainly gives the stability during storage, where the secondary phosphites antioxidant, it gives stability during the processing. It protects the color and also stabilizes the Muni viscosity during the storage. Now it replaces the TNPP, because TNPP, when the processing, it will generate nonyl phenol, and nonyl phenol is a HVHC, and it is banned in the European Union and USA from the last 10 years, and it is also banned in China in 2016. China has limited the application of nonyl phenol in its products, which is less than 10 parts per billion. But when during the processing, the TNPP, it degrades and releases the nonyl phenol, we could not really control the amount of that nonyl phenol released in the environment. That's why that Western 705T is developed. Like TNPP, it is also liquid in nature. And we have compared the performances. What we have shown, it gives excellent color protection and also good Muni viscosity retention. So we have data for that emulsion SBR. So here we have carried study when the conventional phenolic AO, that is AO 520 is taken. AO 520 is similar to Ergonox 1520. And along with that, we have mixed iodinated phenol. And another recipe, we have used the TNPP with iodinated phenol. Now, if we look at the aging study graph, so Muni viscosity, Western 705T blends means we have used phenolic antioxidants also. Along with that, 0.4 pHR of Western 705T used, which shows a better retention of Muni viscosity during the aging. And during the mixing, we have studied the torque. So for the unstabilized system, there is a drastic reduction in the torque. But for the standard AO system, the torque is stabilized, but in the meantime, we can see some peaks are there, which indicates in that time the cross-linking takes place. Now, cross-linking indicates that the material is not so stable. It may degrade during the process, but when we use that Western 705T blend, we can get a stable plateau. And along with that, like 705T also adds the hydroperoxide. So the main action of secondary hydroperoxides, all the secondary phosphides acts in a similar manner. It will add the hydroperoxide that is generated during the process. And hydroperoxide further catalyzes the degradation process. That's why Western 705T offers better protection during the processing when compared to that standard phenolic antioxidant than currently industry is using. And here we have compared the color of that unstabilized ESBR and the standard AO. So for the unstabilized ESBR, it turns brown after the process, which indicates pyrolysis has been takes place. For standard AO, we can see some dark spots and the material also is not even. But for Western 705T, the color is better. Also, no visible dark spots is there. So few more data for NBR. So NBR, same way we have tested the Muni viscosity compared with that standard AO, that is AO 520. And under the aging condition, better retention of the Muni viscosity is observed for NBR. And here we compared the color with that NBR manufacturers for different parts in the world. Like we have taken sample from Europe and Asia, and then compared with that NBR stabilized with that Western 705T. So it's noticed there. Yeah. So for Western 705T, the color is lighter, but for the other products which made by that conventional standard AO, the color is darker. So in conclusion, we can say that like Western 705T is a sustainable antioxidant when stabilizes that synthetic rubber. And we have more data for solution SBR, nitrile rubber, butadiene rubber, and EPDM. So for all these rubber, Western 705T will act in a similar way, and it offers good retention in the Muni viscosity and better color. And definitely it will value to the end users. So Western 705T is available as its own form in the liquid form, but sometimes there is a requirement for to blend with that phenolic antioxidant. So SI Group is also offering that. It's also available in the binary blend form. So today I'm concluding here. So that's all my side. Thanks for your patient listening.
So thank you very much for your talk. I would like to discuss something on your rheums.
Yeah.
The chemical. When you compare DPT and your new product, right?
This one?
BioXL.
This one? Yeah.
I mean, if I noticed from the chemical here, okay, DPT should slosh down. But when we apply the no gas,
Yeah.
then we have a type of population at the beginning of the chemical, and that is a kind of indicator that we don't have a complete salinization. You see, It's not a plane. I mean, we don't have Scotch stadium in this case, but it shows a small hump in the beginning, and this is population. What we
So like the DPG has a different structure and Nougat BioXcel has a different structure. Sorry. So Nougat BioXcel has much higher molecular weight compared to DPG. So might be like what we have observed that this kind of graph we have carried out for all other formulations also. So for all the formulation, this kind of delay is there. So maybe it's due to what you are saying that might be also true because having higher molecular structure, it will take some time to disperse in the system.
Because pharmaceutical compound, we know that DPT can boost the cyanidation, so enhance the cyanidation efficiency. And that is the role, one of the role of DPT in addition to the accelerator.
Yeah.
And there's a proof already from many articles. So I want to have a look closer in that. Because if you, I mean, okay, DPT is toxic, and if we have alternative, that will be great. But if we want to replace it in especially high load and silicon compounds, you need to also consider the effect of DPT on cyanidation booster
Yeah.
to make sure that we have enough cyanidation. Otherwise, we will have population, and then later on, it will be kind of influence on the property later on.
Okay, okay. It's a really good suggestion, and we are working more because this is a new product. So currently what we have observed that all the QA properties like the data we have shown is comparable, but that flocculation part, how it's really gets agglomerated during the process. So we have not looked into it. So thanks for your suggestions. Yeah. Okay.
Yeah. Very good topic. Yeah. Yes. Thank you very much. We can so guide and I will go 15 minutes of break. Good job. Thank you. If it is there.
Have it.
Great fan of.
Really? He's now retired, but he's still support.
But what kind of the
Yeah. I mean, he extended his job. But yeah, now I'm hoping to cannot.
सर आज कितने बजे पता है आज कितने बजे पता है सर
5 बजे.
5 बजे
Yeah, yeah,
5 से 5:30
yeah, around that. Yeah.
I listen to you.
Scan it.
This is on the Yeah, that's it. So maybe there's a. Yeah, check, got 17 years in. All these, this sneaker silent technology was actually being started by me. When I went to the Garson field, got here already. Yeah, after that, the brand, it was, it's coming back. Another 5 years to come back. Then in last 5 years, I was in Reliance. So what about coming back now? Yeah, it's not about the. Talk about the. How much? Aquis can be used as a. Not as a replacement of budgeting. It can be, 25, 25 grand, 13, 75, 25%, the same, or something like that. We use that. Simply. Up to 330 also you can go, provided it is from the trade board. But it's very difficult. The quality control is the key. The quality control of this. So if you really want to have sourcing. Not only sourcing, actually there should be a constant visual on what they are using. It is not that you just leave it around and then they will give you anything,
Hey, Dr. Sujit, can you hear me? I saw you're all logging only.
Yeah, I can hear you very well. I have logged in.
Okay, fantastic. Can you open your cam as well?
Yeah, I can check it.
Yeah.
We are 100%.
Okay, good. Oh, super. Good to see you, sir.
Yeah,
I
thank you.
wish that you were here. How's the floods and all right? What's the situation with the floods?
Oh, partially okay. So
Yeah.
some part is okay, some part is still down, kind of.
Oh, okay. I see. Okay, can you share your screen? And I want to test your share screen. Yeah.
I will.
Using it is very.
See, we are having coffee break around 10 minutes more. And after that, we'll have one presentation for 10 minutes. And then you will be invited to give a talk. Yeah.
Okay. So that will be around 12:30.
Yeah, around 30 minutes altogether. Yeah. So stay on so that when it's finished, then we invite immediately. Yeah.
I will stay on and
Yeah.
let me just try sharing my screen. Is it visible?
Yes, we can see our screen now. Yeah.
Let me go to the full screen mode.
Yeah.
Yeah. Well, what is seeing now?
I see the recent advances in the first slide, I guess, the recent advance in passenger car technology, car tire material technology. Yeah.
Right. So done. So then I will
Yeah.
I will stop sharing now.
Yeah.
I can
Okay,
be
so
in the conference now, right?
Yeah.
Okay. Okay. So fine.
So you can stop sharing, and when I invite you, Professor Kinsuk will be inviting you. Okay, I'm taking another room. Okay, for this room, Kinsuk is taking care of. He will invite you, and you share the screen and turn on your camera. Yeah.
Okay.
Okay. Super. Thanks. Yeah. Yes.
Thank you. Let's get. Okay. So.
পয়েন্টটা দিচ্ছে আর টিপতে হচ্ছে
এমনি টিপতে হচ্ছে মনে হয়
না
হয়তো
পয়েন্ট
পয়েন্ট যাচ্ছে না এখন জব
চালাইনি বোধহয়
পয়েন্টটা
দেখি 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 দে
উপরে উপরে টান করতে হবে তাই তো
হ্যাঁ এখানে হাত দিলে এটা বন্ধ হয়ে যাবে হ্যাঁ
ওটাই করা যাবে
এখন চাপা পড়ে যাচ্ছে এখানে না না পরেরটাতে যাচ্ছে না পরেরটা
পরে যাচ্ছে না তো
লক করা আছে
তাহলে এখান থেকেই করতে হবে কিছু করার নেই।
না 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 স্ক্রিনটা লক করা আছে
ও আচ্ছা
ওরাম
হয়তো তুমি তাই দেখলাম আমি।
ভিডিওটা করলেও
সেটাই ব্যাপার আমি ওর প্রত্যেকটাই সকাল থেকে দেখি পিডিএফ এ কনভার্ট আছে
হ্যাঁ ব্যাস
আমারটা আজ এখানে দেখেছিস আজ আমি পরে দেখছি ব্রেক
এটা এটা কি বলবো ভাই এটা কি বলবো
মাইক্রোফোন ধরে বসছে
কেন
দাঁড়িয়ে বলতে আমি খাবি না মাইক আছে মাইক আছে হ্যান্ড মাইক আছে হ্যান্ড মাইক আছে সবাই দাঁড়িয়ে বলছে আমি স্ক্রিন শেয়ার করতে হবে
আমার অন্য একটা ছিল ওটা পেলাম থেকে একটু আগে পাঠালাম এটা না
আরে ও সবার নিচে একটা করে ব্যান্ড লাগিয়েছে তো
কোথায় কোথায় সেট করেছে
পেরাম কি এখানে উনি পাঠিয়েছেন
হ্যাঁ ওই সব মর্নিং সেশনে পাঠালাম উনি অলরেডি আপডেট করলেন তো
আপডেট করেছে তো
হ্যাঁ,
করে দিয়েছে তাহলে তো এটাই
এই
হওয়া
আবার কখন
উচিত।
বলবে রে
এটা কোন জায়গাটাতে
তাহলে ওই ফোল্ডারেই রাখা উচিত এটাই হওয়া উচিত তাহলে
এটা একবার খুলো তো
দাঁড়া 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 এই তো 29/8
না এটা না এটা না এটা
এটা নয়
এই জিনিসটা ছিলই না
আচ্ছা তো একবার
আগে
পেরামকে একবার তাহলে
দাও,
বলতে হবে
সৈকতেরটা তুমি
হ্যাঁ,
করো,
হ্যাঁ।
তুমি অ্যানাউন্স করে দাও সৈকত
আচ্ছা
তারপর সিরিজেরটা আমি করবো অন্যটা পরে আসি একটু চেঞ্জ হবে হ্যাঁ ও আমার আরো পিছিয়ে যাবে লাঞ্চে পিছিয়ে যাবে লাঞ্চের পর লাঞ্চের আগে লাঞ্চের আগে হ্যাঁ আমার লাঞ্চে একটা বেশি হবে সুদীপ একটা হয়ে তারপর জিভা তারপর আচ্ছা কোথায় আছে দেখি
Did you not delete yet that one? Where is this?
in the morning you have saved
Yeah. I know. That is not used. No, I already put the name for it, right?
maybe in some different name
So he's online or so within 10 minutes.
Yeah, Srijit is here. Which one?
This one.
I think this one.
Give me just a second, let's just say.
Yes.
This one, I do this. Yeah.
Yes, sir.
Let's push this one up a little bit. Yeah. Good.
Yeah. Good afternoon, all. So down the line, we have our speaker, Mr. Shaikat Banerjee. He is a senior research fellow from IIT KGP, Rubber Technology. So he will be talking in the new type of cross-linking system for a special, very specialty grade rubber, that is the fluoroelastomer we know. So over to you.
So good morning, everyone. So I'm starting my presentation. Myself, Shaikat Banerjee, SRF, under the supervision of Professor Nikhil Kumar Singh, IIT Kharagpur. So my presentation topic is new sustainable cross-linking system for fluoroelastomer. So actually, fluorelastomers are high performance elastomer. In 1957, DuPont actually has launched it, and actually, basically, the presence of that highly electronegative fluorine atom and that actually gives that very high bond strength of that carbon fluorine bond, and the bond strength is at about 485 kilojoule per mole. That means it is very high bond strength. And due to the very high bond strength of carbon fluorine bond, and as well as that van der Waals interaction between the hydrogen and fluorine atom, gives excellent chemical resistance, oxygen and ozone resistance due to the saturated backbone of that FKM, and also that as oil and solvent resistance due to the polarity comes from that highly electronegative fluorine atom, as well as that good thermal and electrical stability also. So I'm basically working on FKM because there are different grades of different types of fluoroelastomers like FEP, MC, FM are there. But basically here I am working with FKM, and having that normally this can be divided into two categories. One is copolymer and another is star polymer. Copolymer, the monomers are basically phenylene fluoride, that is VDF, and HFP, hexafluoropropane. And for tar polymer, the monomers are additional monomers each tetrafluoroethylene, and the basically the FKM is prepared by emulsion free radical polymerization. So the conventional cross-linking systems for FKM are that diamines, dihydroxy curing system, radiation curing system, and that peroxide system. For that diamine system, basically normally that hexamethylene diamine salts are used, the carbamate salts are used, not the diamines, normal hexamethylene diamine or ethylene diamine are used because due to that actually gives very high Scotchiness. So that's why the carbamate salts of that diamines are used. Because actually the Scotchiness comes from that high reactivity of that diamines. So that's why the carbamates are used. Another cross-linking systems are the peroxides I have already told, dicamyl peroxide and Luperox 101 XL45, that is 2,5-dimethyl 2,5-dihydroxybutyl peroxyhexane is used as a cross-linking agent for FKM. Radiation curing is also used, gamma energy radiation, but the widely used cross-linking system for FKM is bisphenol, and the different bisphenol grades are there. Bisphenol S, AF, F, different grades are there. because the bisphenol derivatives actually gives better compression set property, compression set resistance, as well as the high, that means better that mechanical properties and chemical resistance also. So that's why the bisphenol derivatives are widely used processing system for FKM. But the main problem for bisphenol A is, according to ECHA, European Chemical Union, that this actually bisphenol causes endocrine disrupting activities as well as reproductive disorder. So that's why my main objective is to replace the bisphenol system by some alternative bio-based material, sustainable material. So we have to achieve desirable mechanical properties as well as some other properties like bisphenol. And another objective is to that should be completely non-toxic. That means completely cytotoxicity activities should be eliminated for that new sustainable system. So this was the objective of this research. So this is the formulation I have used. Here, FKM I have already told for this system. Normally, magnesium oxide used as inorganic base to cause the HF elimination initially. Calcium hydroxide used as the cure activator. MT black is the N990 used as a normal filler. Basically, Carnauba is used as the processing aid. Bisphenol system, the conventional system, and I have used bio-based research. Actually, some research derivatives actually used. I have not disclosed here due to some confidential issue. So here I have just write research. So so research is the exploratory curative. And the BTPPC is the phase transfer catalyst that normally basically used benzyl triphenyl phosphoname chloride. And here I have also invented some another thing, that is dispersion medium. I have used that diacetyl alcohol. Normally in the conventional formulation, no dispersion medium is used, but I have used dispersion medium due to that means to disperse the resorcinol in FKM elastomer matrix, so that to reduce the scorchiness. So this is the process flowchart. Firstly, that master batch prepared by that internal mixer, master batch from that BTPPC and that resorcinol system. And then the other chemical ingredients like calcium hydroxide, magnesium oxide, that means Carnauba wax, and that simultaneously they are added to the mix to form the final compound. Then RP analysis is done. Then press cure at 170 degrees centigrade for 10 minutes, post cure for 230 degrees centigrade for 24 hours. Then the other cytotoxicity test, processing density, mechanical properties, compression set, and some different tests are done. So from that results part, I have seen that we have got comparable cure characteristics. Compare that you can see the so the red one is the exploratory curative, the resorcinol derivatives I have used, and black one is that bisphenol system. So you can observe that we have got comparable cure characteristics between both the processing system, that conventional bisphenol and exploratory resorcinol derivative system. We have also got comparable mechanical properties, got comparable compression set. You can see 24% for the resorcinol system, but and that is, but conventionally 20% compression set property for that FKM. And we have also got comparable processing density for this resorcinol system. So the possible cross-linking mechanism by resorcinol is like this. Firstly, that calcium hydroxide that acts as the cure activator actually reacts with that benzyl triphenyl, that means BTPPC benzyl triphenyl phosphoname chloride, and then it actually acts that reacts with that. This is the so this is the resorcinol part. It forms the reaction intermediate that actually attacks the phytol that FKM elastomer. Then actually two type of reaction actually form that means occur here. Firstly, that HEV elimination, and secondly that rearrangement reaction to form this diene. Then ultimately that reaction intermediate or attacks the diene to form the final cross-link. This is the ultimate mechanism, cross-link mechanism by resorcinol. Then I have done that cytotoxicity study of research phenol. I have seen that that means cytotoxicity study, the MTT assay study actually. So from the IC50 value, we can conclude how much that what type, that means the for which chemical is how much cytotoxic. And we have observed that research phenol is less cytotoxic compared to bisphenol A. You can see from the result here. From this result, you can see that means IC50, that means how much amount of that chemical is required for 50% of cell death. So you can observe that very less amount of bisphenol required for 50% cell death, and research very high amount, 478 micromolar. That means research is less cytotoxic compared to that bisphenol system. So my conclusion is that research derivatives that I'm not disclose here. So this is less cytotoxic compared to bisphenol A system. We have got comparable physico-mechanical properties, Quetelet density, state of cure, rate of cure with the conventional bisphenol system, and as well as the compression set resistance also we have got that is comparable between the conventional bisphenol system and exploratory research derivative system. Thank you.
Thank you very much. One question only.
Actually, this is bio-based receptional derivative. This is not that normal receptional monobenzoate or receptional acetate that is from chemical industry that is called. This is bio-based receptional derivative.
Oh, yeah. Because you can come here. Name or Hello, Dr. Nair. Could you hear me?
Yeah,
Good,
I can
yeah.
hear you. I hope
we are happy to see you here today. Okay. Because we already did mention to all the delegates that yesterday you could not make it because of the flooding situation there. And I think it is better. Okay, we can see you very nicely. Okay, so I won't take much time to introduce Dr. Nair. I think everybody knows that he is currently the Vice President of R&D Center of Excellence, CEAT Limited. And we have long association with Dr. Nair and his relatively young group for last, decade or so. And he will be speaking on recent advances in passenger car tire material technology, what he could not make today, but we are happy to welcome you. So okay, please join me in welcoming Dr. Nair. And so what to you, Dr. Nair?
Thank you, Dr. Naskar. Thank you for introducing me, and thank you for inviting me also to this very important conference. First of all, it's very regretful that I could not reach there because of unforeseen scenarios going on in Baroda. There is a flood going on here, and we had many challenges to travel. So please accommodate the online version of my presentation. I will start now. Let me ask a question. Am I audible very well?
Yes.
And is my slide is moving?
Yes, sir, you are audible.
Yeah, okay. My slide is moving, right?
Yes.
Yes, sir, your slide is movable. You can speak.
Okay, so this is the brief agenda for the next 15 minutes. I will try to cover to give you an overview about what's happening in the passenger car material technology. So if you look at the history, so maybe somewhere in somewhere around 2000 onwards, people started using the silica technology. So silica technology, we all know that has completely changed the way compounders used to work, and we could give a lot of advantage just for the tires by reducing the rolling resistance or improving the fuel efficiency of the tire. That was a big shift in the material technology. Then later came many improvements in the solution SBR, and solution SBR supported silica in enhancing its performance. Then late last 10 years, I can see a big change in the resin technology, which is getting introduced, started with 5 or 6 PHR, reaching up to 40 or 45 PHR of resins are used now in the tread compounds to enhance the grip and the rolling resistance and all. So we can say that another big jump which was happening now was about the silanes. So silanes are also extremely helping the entire silica technology and solution SBR silica technology to enhance the fuel efficiency or reducing the rolling resistance. So this all 4 or 5 material technology, we will be focusing on this presentation because this is a very vast subject. I will try to give you a little bit of insights about all this material technology. Is my slide moving? Sorry to ask this again.
Yeah, sir, you can proceed. It's moving.
Yeah, okay. So yeah, you can see my slide, the slide number 3 now, right?
Yes, sir, we can see your slide. Please
Yeah.
move on.
Yeah, okay. So this slide is talking about all the challenges which the tire material technologies are now facing. We are always requested with improving the performance needs, whether it is a very high speed requirements of an autobahn kind of a driving where extremely high speed is needed, or emerging requirements of the regulations which are connected with many countries, sustainability challenges. There are a lot of things to be achieved for the tire industry for meeting the sustainability regulations, and always there is a pressure to reduce the price. So we are actually in a business, so we need to be optimized about the cost. So these are all the major things which are actually driving the material technology today. And if you look at the rolling resistance, why I'm talking about rolling resistance, it is definitely a very, very important thing, because here meeting this magic triangle of performance started with fuel efficiency, then the traction requirements, and the wear resistance was the points what we used to talk about. But now what I mean by wear resistance is, after the introduction of silica technology, lot of overall the material durability, the wear resistance is already overtaken by a word called durability, because the cut resistance and the tear resistance of the tire is also extremely important. So this magic triangle is going to be another major thing. Now, if you look at all these things, if you look at whether it is high performance cars or electrical vehicles or the drives for sustainability, All these things are actually, pressurizing the compound development engineers to enhance this magic triangle of performance. What industry has done over a period of last 20 decades, in that last decades, if you look at, we can see if you look at a typical car tire, close to 50% of the reduction has happened already in 21. Now the tires are coming, say if I started looking at somewhere in 2012, 2013, that time to FY21, when I just looked at it, a particular typical type of a tire that has undergone 50% reduction in the rolling resistance. That means 1 kilogram of reduction is equivalent to 63 kilogram of carbon dioxide equivalent, which is very, very big achievement we can always be proud of as a material scientist. Now, this is a slide just to give an overview about which are the type of materials we are concerning within a tire material technology. So all these 5 pillars are extremely critical and all are important to be worked on for improving or enhancing the tire performance or meeting the regulatory requirements or making tires typically for EV tires and so on. Now, I will start with solution SBR. There is no doubt today in the mind of any person that solution SBR is a versatile polymer compared to emulsion SBR. So they are extremely, extremely important ingredient for every compounding engineers. So they give excellent, by modifying the micro and macro structure, they can be tailored to meet many of the challenging performance requirements. Hello? Am I stuck on my slide? Sorry.
Sir, you can continue.
Yeah, okay. So I'm just looking at another slide, which is talking about a comparison between emulsion SBR and solution SBR. I'm not going to read the entire thing. This is just for the understanding purpose. This is going to give, this is very, very clearly explaining why solution SBR is very significantly preferred choice over the emulsion SBR. Now, this is a slide which is summarizing the various type of microstructures possible, that if it is a high styrene, what is the range of styrene and what is the range of vinyl in a compound, and why, and for particular type of application, how this is going to be useful. Say, for example, we all know that high styrene means it will give an extremely high traction, high vinyl, moderate traction, and so on. So this slide is summarizing that. So finally, we can say that all tailor-made properties of SSBR are extremely beneficial for controlling the rolling resistance and achieving the required grip. Functionalization is a big thing which has happened over a period of time. I'll be showing one slide about this, and they are very, very clearly improving the polymer filler interaction and also improving the hysteresis. So if you see, this slide is a summary of various generation of solution SBR. Now we are talking about 6th generation, which I have not put in this slide, but if you look at the first generation, they are all only tin and silica coupled. That is how it has started, almost a couple of decades back. Now today, we can say the latest generations are mostly focusing on functionalization, high molecular weight, which are needed for EV tires, and also the good balance of functionality needed for improving the processability. So all those changes are happened over a period of time in the solution SBR. Now, if you look at one particular case, if you look at it, this is an image which is showing how a new generation solution SBR is able to disperse silica in a very, very nice way. So this is very clearly showing one advantage of that. So just to summarize about solution SBR and emulsion SBR, there is no doubt that SSBR is the most preferred polymer. There is no doubt we should be thankful to the polymer manufacturers for coming up with many advanced grades of solution SBRs, which are very, very useful for improving the EV tire performance, improving the performance of tires for RR, grip, and the noise, and also, for making a perfect tire. Now I'm moving to the second part of my presentation, that is about liquid rubber and resin technology, how they are able to support the solution SBR and silica. So liquid rubber, we all know that this is a slide which is comparing with its molecular weight. So almost all types of liquid rubber are possible, like that of SBR, BR, IR, and also its functionalized forms are also available. And if you look at a chart, this is a chart which is showing how they were over a period of time, how these kind of the liquid rubbers were getting introduced in the industry. And if you look at this, this gives a summary about its characterization in terms of molecular weight, etc. And this is also showing how, when we are comparing them with plasticizers and resins, how they would look like. So a deep understanding is important before we start using them. So, sorry, yeah. Here, now the second part is about resins. We know that there are various types of resins used in tire. There are 5-6 applications are there in the tire. It could be for tachiness, homogenizers, reinforcing agent, dispersing agent, etc. And in this particular presentation, I am going to talk about only about the tire tread traction resins. So this right side is talking about there are 4 or 5 categories of resins are there, including hydrocarbon resins, coumarin induced resins, alpha methyl styrene resins, terpene resins, phenolic resins. There are many. And we all know that there are resins which are of natural origin. There are synthetically produced. There are 2-3 types are there. So if you look at synthetically produced, C9 and C5 are of naphtha origin, and then from coal tar we can get the phenol type of resin. So this all are giving a summary about that. So how they help to how they help a compounding engineer to improve the grip. So actually resins are viscoelastic, very good viscoelastic modifiers. If you replace resin if you replace the oil, traditional TDA oil with this kind of a resin, as I mentioned earlier, up to 30 or 40 PHR you can replace, up to 45 PHR I have written in this slide. And truly they improve the viscoelastic characteristics. It can be shifted towards a better grip area, and that which can be done at a reasonably good mechanical properties, and also without losing the wear resistance. So that's the advantage. And this is a chart normally people use to select what kind of resins are more compatible. So compatibility is important from the point of overall the strength of the toughness of the rubber, the strength of the rubber, the wear resistance. For all, the compatibility is very, very critical to select which resin should be used for which kind of polymers. Now I am coming to the third part of my presentation. This is talking about why silica technology is very, very, how it is advancing, and how can we married all the solution SBR resins, everything to the silica technology to achieve the best tire performance. So if you look at the silica technology today, we know that carbon black, we have various ASTM grades like 1 series, 2 series black, 3 series, 5 series, and 6 series, 7 series. There are few such series are emerged basically on the surface area. Similarly, in silica also we can see a pattern starting with 125 surface area, which is used for winter tires, very low modulus, very supple tires it can produce, and 160 was very, very standard till this recent decade. And this decade we can see a big change which is happening in the more and more surface area versions coming up in the industry. They are basically able to improve the abrasion resistance, improve the tensile strength, which are all the challenges which silica technology used to have earlier. So this is just to give you a glimpse of what it is. And we all know by now that it's a very mature technology, silica technology today, that all these polar groups on the silica need to be selenized, and before it behaves like a carbon black. Now, silanes are very, very important role. It plays a very important role. Now we are going to talk about what are the advanced silanes. So SA69 was the first generation, I would say. Then SA266 came with a little bit of marginally drop in properties compared to SA69, but excellent processability and reduced scrap it could produce. So industrialization of the compounds were very, very easy with SA266 and SA75, which are very similar. Now we are going to talk about how to improve further the RR. So there are various grades are available in the market. There are SA363, there are NXTs. So these are all can significantly reduced. I would say both are able to do wonders in reducing the rolling resistance. This chart is talking about that. If you look at a disulfide silane, I'm not going to name any of the brand here, but how much it can improve. This is what it shows. So the low RR silanes are having close to 24-25% rolling resistance advantage, still maintaining the wet traction to close to 17%. Yeah. So this silane technology is extremely important. And these hydrophobation reactions, controlling the hydrophobation reaction, whether it is low RR silanes, what we have seen in the earlier slide, or the first or second generation silanes, everywhere controlling the selenization or hydrophobation reaction through the pine value is very important. So lowering the pine value will be extremely critical. Now, I'm not going to get into the details of this slide. This chemistry of that selenization is well known to almost everyone. Now, let me get into, we have introduced 3 or 4 material technology now. Now, I have a couple of slides. Those material technologies cannot be taken forward without the support of the mixer manufacturers and also the equipment manufacturers. Like, thanks to the RPA for controlling the silica in the process, and thanks to the tandem mixing systems which are introduced recently. So this slide is talking about that. So silica is, when we process the silica, it is a reactor. So we need to control the reaction. So here we are talking about a very good, there is a series of changes which are happening in the Banburys. The Banburys are taken over by intermix. Now the intermixers are taken over by tandem mixers. So the tandem mixing systems are really supporting the silica technology. So there are 2 mixers in series. So the top mixer one and the bottom mixer. And the bottom mixer is having a ramless system. And primarily the filler incorporation is happening in the top mixer. And the entire process is temperature controlled in an efficient way. That is what it is. So this is just to show a glimpse of how the top mixer and the bottom mixer graph of a tandem mixer will look like. This very clearly showing how easily the top mixer can incorporate the silica well, disperse it well, and pass it on to the bottom mixer where there is no ram pressure, but the selenization is completed in the bottom mixer. And also the temperature control is an excellent one because there is no much pressure from the ram also. I would like to summarize in this slide what I have talked. We have talked about advancements in the solution SBR, silica, silanes, and resins, which are happening of late to meet the magic triangle of performance. There is no doubt that resin technology is the most support it gives to the silica technology in improving the tire grip without losing the mileage. So we also seen that how silica is overtaking carbon black. So when it comes to fuel efficiency or rolling resistance reduction, there is no other technology which are now proven for, in the tire industry or in any industry for improving the roll and resistance. So the silica really see, I can see that many of the factories are having a huge silica compounds today compared to the carbon black. Now, when we talked about such material technology, when we are introducing, we need a lot of support from mixer manufacturers. So the tandem mixing systems, we have seen that how it is helping to incorporate, accommodate the silica technology in a proper way. Finally, we need to control the entire, silica mixing, which is happening in the factory, finally using the pine value measurements. So the best measurement to control silica is not, so all the rheometers are slowly taking its place. The RPAs are taking the place of rheometer in the factories when it comes to the silica process control is concerned. That's it from my side. Thank you so much.
Thank you very much, Dr. Nair, for your excellent presentation and overview.
Yeah.
Maybe one question. Yeah, please come here. Dr. Nair, there's a question for you. Just
yeah,
just
I can
wait
take that.
for a while. Just wait for a while, and then delegate is coming, and then we will ask this question. Please.
This one?
Yeah.
Yeah, Dr. Nair, good afternoon. This is Shankar Banerjee from Finocam. And excellent presentation, but the amount of information you have given, it will take some time, at least for me to go through that and understand. One slide you showed on the selection of the polymer of various resins of the hydrocarbons, terpene, phenolics, and gum resins. Could you also elaborate something on the phenolic resin based on that selection of, based on the polymers, the selection of the phenolic resin, maybe now or maybe at some point? Yeah, thank you.
Yeah, phenolic. See, the entire resin technology is, I would say, it is emerging. There is phenolic resins are also used for cut chip resistance. It is used along with certain amount of traction improvements, or it is possible. But the problem with some of the phenolic resins are when it comes to the rolling. So we need to be very choosy about. So sometimes people blend of resins also. But I would say this is an emerging area. I have seen only from an academic perspective, only I could share what I have given here.
Okay, thank you, Dr. Nair. Maybe when we meet or I get an opportunity to meet you, we can discuss on the same. Thank you so much.
Sure. Yeah.
Thank you, Dr. Nair. I think also one of the student is, Dibyendu, who is working also under CET project, and I think he is also looking into different aspects of resin in details. So I think we'll be having more information and share to others when we publish the paper. Yes. Thank you so much for your time. And I think be there online for the rest of the presentations. There will be another presentations next to you about silica as well. Okay. So be there, please. Thank you very much.
Thank you so much. Thank you.
You can go with. What feels my phone? This is next, right?
So, good morning, everyone. So, till now, a lot of people have talked about the silica and the importance of silica fillers in the tire industry. So, I will make an introduction in a very brief manner. And a lot of work has been carried out by 20 people, like Madam Kanika is there, and Vilma Kedakis, then Anke Blume. They have done a lot of work. So, I initially started my PhD work by studying these people's work. So these are the contents like introduction, challenges, and those things. So introduction, now all the countries are trying to race towards the net zero. So what is net zero? Net zero means like zero carbon emission. So almost some countries already attained the net zero, whereas like countries like India is planning to attain this net zero by 2070. So I will connect this. What is rolling resistance is nothing but the resistance of a tire to get rolled. That means it consumes more energy. That means some energy is getting dissipated as a heat, which is a loss. So why I'm talking about tire and CO2? So how tire is related to fuel consumption? If you see, 15 to 25% of the fuel is consumed by the tires, whereas remaining 75% to 85% is consumed by the engine transmission, then aerodynamics, air resistance, and those things. So how does the rolling resistance is related to CO2 emission? If you see that 1 liter, if you are burning petrol, it will emit 2.31 kg of CO2. So that means if you are trying to reduce rolling resistance by 20% in tire, it can save you around 2.6 liters for 1,000 kilometers. It's a huge amount because it will save 6 kg of carbon dioxide emission for 1,000 kilometer run. So this is where the green tire plays a role. So green tire is nothing but the tire which is having lower rolling resistance. So this is not possible without the silica filler. Whereas if you use silica filler, this magic triangle get expanded. But one condition is that you have to use silane coupling agent. I will come to that. So what is the scientific reason behind this? Instead of carbon black, if you use silica, this silica filler has a nature which will give high hysteresis at high frequency. That means at the low temperature region where you will use for this grip and braking. It gives low hysteresis at lower frequency. That means high temperature. This is the main thing because tire is running. It won't be in the room temperature. It will run at 60 to 80 degrees Celsius on the service condition. So at that temperature, silica will give low hysteresis. That is what we needed. So typically without coupling agent itself, your silica is giving better rolling, lower rolling resistance, which is indication of tan delta at 60 to 70. This without coupling agent, but it is inferior to carbon black in terms of wet grip. So this we can attain by adding coupling agent. So we need coupling agent to have this chemical covalent bond which will form with the rubber, and it will try to connect the silica filler and the non-polar rubber. So polar surface and non-polar. It is like oil and water. It will never get that much connection. When you're adding water into oil, it won't connect good. So to make some compatibilization, we are adding silane coupling agents. So what is this? This is a chemistry, okay. So industry, what they are facing challenges. If you see, the industries are facing challenges. Silica mixing is a reactive mixing, unlike carbon black. Whereas carbon black, you can just mix the carbon black into the compound for certain time and temperature not more than 140. Your carbon black will be incorporated and your properties will be good. But whereas silica, your mixer is not only the Banbury mixer or tandem mixer, it is also acting as a reaction reactor. So whenever you have any reaction or reactor, you need to control some parameters so that you will get the highest yield point. In chemistry, we do that. So this reaction parameters plays a key role in final performance. Even though you are making good compound, when you are not processing it properly, your overall property will be lesser. So now little bit of chemistry. So what are we know silica filler. So what is the surface chemistry of silica filler? If you see the silica filler, it will have surface siloxanes, geminal seranols, isolated vicinal. These three seranols is actually considered to be reactive. In this, vicinal is not reactive because this H will always have some hydrogen bonding with the nearest O, so that this H is not ready for reaction. It's very difficult to have a reaction with this OH, vicinal silanols. And surface siloxane is not going to react as it is already having the equilibrium. So only we can do silanization in geminal silanols and isolated silanols. So how much percentage is there? That we have to find. There has been already previously research has been done by Anke Blume and their co-workers. So they have found out that only 25% of the silica filler surface is having is highly reactive with silins. That means this 25% is geminal and isolated, whereas remaining 75% is not going to react. So this means that when you're adding, if you're adding more than 25% of silanol, coupling agent, it's not going to react. It is going to be waste only. So maximum is 25%. Okay, now come to the industrial point of view. Without tandem mixer, when you are mixing it in a Banbury mixer, which most industries are doing, for carbon black you can go for 2-stage mixing, but whereas in silica we have to go for 3-stage mixing. First batch, master batch 1 will be a dispersive mixing, where you will incorporate all the chemicals into the rubber. And mainly in second master batch is a reactive mixing. Here you are going to, your Banbury is going to react as a reactor. So you need some certain temperature and time, which will fulfill the reaction between silica filler and silane coupling agents. And in final batch, we are just going to incorporate sulfur and other accelerators. So if you see these 3 stages of mixing, high energy is consumed only in this second masters. So huge amount of energy is getting wasted or utilized in this second batch. So somehow we have to reduce this energy so that our compound performance property will be good and also with less amount of energy, because industry energy means money. So this is a typical mixing graph for the second stage and first stage mixing. I'm not going into this. These are steps followed in industry. And I will go, what is DOE? DOE is nothing but design of experiments. So consider that you are baking a cake. So this cake is having some quality like taste, color, and consistency. So it depends on some several factors like what oven you are using or what temperature you are baking it, what sugar you are buying and how much sugar you are adding, what flour you are using, how much flour you are using. So this depends on several factors and levels. Same thing when you are going for silanization or silica compound, this will have final output green tire, but it is based on several process parameters also. If you have same formulation but different process condition, it will also affect the final properties. It's not about only the compound development. Process technology is also important. So this is the brief formulation. I have not given all the chemicals as it is industrialized. It's using in an Apollo tires. So a little bit of formulation I have given, main ingredients. And this whole project I have optimized and done in Banbury mixer by Farrell. It's a plant, like miniature of Banbury plants level. And these are the parameters which from literature and experience, we found that this might affect this salinization. Okay, so feed door condition, fill factor, temperature, salination time, TCU temperature, and ramp pressure. So this boundary condition is nothing but lowest value and highest value. We have to choose it from the literature and experience. So this we have chosen it. Initially, we have carried out screening DOE because some people have already studied how temperature affects the salinization, time affects salinization, but not in the statistics way. So we have adapted the statistical method to find, okay, we have this many parameters. Out of this, which is really contributing, which is not contributing, and how much percentage it is affecting, that we have to study. So we have used a screening DOE, Takuchi method, L18 run table. And these are the main properties we have checked, like reinforcement index, pain effect, tan delta, mixing energy. These 4 will give direct indication about salinization. It's an indirect measurement. Like if you have, say, like reinforcement index is increasing, that means your salinization is good. Whereas your pain effect is less, it is good. Tan delta less is good. But energy, we need to reduce. We need to reduce the energy also. Just a glimpse, same formulation with a different process condition, you can get like very bad compound also, very good compound also. So this relies completely on the mixing condition of the Banbury mixer. And these all parameters having a interaction. That means your time and temperature is always having some interaction. Then ramp pressure is also having interactions. So it is not a easily we can predict like, okay, I will just fix out of 3 temperature 1 is good, I will fix it. It's not like that. So we have to optimize all the parameters in a single time using statistics. So finally, from screening DOE, we have calculated if the percentage that what is the contribution of the individual parameters. So you can see time, salinization time is highly contributing for salinization, then fill factor and temperature. So these 3 parameters is a highly contributing factors for the salinization compound. So if you have industry, mainly you have to focus on these factors. Then you have to optimize your process condition. So to validate the DOE, we have done experimental values. So the error percentage is less than 6%. That means the DOE is validated and corrected. And least significant parameter means feed door condition and ramp pressure, because these 2 is not going to affect your final properties of the salinized compound. So we have found out, okay, these 4 are the main factors which is affecting the salinization. So now we have to optimize it in a statics way. So we have carried out like a Takuchi method, then DEAR analysis, and also RSM method, response surface analyzer. So using this, we have now only chosen fill factor, salination temperature, salination time, and TCU temperature. Only these factors. We will optimize it because these 4 is going to highly affect your final performance of the compound. So these are the results, like whatever results we try to take. In this, these red color results are mainly correlating with the silica compound, like salinization. Same, like bound rubber content increases means your salinization is good. You have a good filler to rubber bonding. And tan delta, 60° rolling resistance, and reinforcement index. So for this, each properties, these different parameters will affect differently. Now we will go just for the energy consumption. As we know that if you increase your mixing time from 60 to 240, obviously your energy will be more. You are consuming more amount of energy in the plant. And when you are increasing temperature also, your heater is going to consume more energy. And when you're playing with the fill factor, the fill factor, if high means it will consume less energy. Then TCU also, if you're going for higher, then energy will be more. So like that, this is indicating which parameter affects the energy consumption of the mixing. And now on pain effect, which is a direct indication of the silica compound. If you see that fill factor reduction means higher, good amount of salinization happening because it's a SN ratio, signal to noise ratio. And when you're going for higher temperature, it's good for pain effect. When you're going for low temperature, it's bad for pain effect because 135, the reaction is very less. You need at minimum 145 to 155 TSPD silane. This is for TSPD, not for TSPT, not for SI363. And when you're giving more time for salinization, your pain effect value is good. So if you want to optimize or you want to take some value in between like 145 to 155, you cannot do it directly in this plot. So the contour plot comes. In this dark green area indicates a better salinization. So you can choose a value between like 222 or 225 and temperature like 150. You get the best salinization. If you are going to this red region, then your salinization is very bad. That means your compound is going to perform very poor in the tire. Then goes for bound rubber content, which is another direct indication of the pain effect. Salinization. So here also you always try to choose the highest like a green side. So green is good for the good salinization compound. We'll go quickly. Same goes for tan delta. Rolling resistance will be better when you are choosing the high temperature and medium or low fill factor. And in same for high time and high temperature. This will favor the reaction. So now we have to optimize. So we used DEAR methodology because we have a lot of parameters like bound rubber content, pain effect, tan delta. Each response will be affected differently by the parameters. So we will try to make an index out of it. that is called multi-response index. So we use this equation to convert this response into a single index, and we have run the Takuchi method. From there, we have chosen the best method, like best condition for the salinization. And we found out that fill factor 50% and even 55-60 is also good. And temperature of 155 and time 240 is giving the highest yield, like best salinization in this condition. So we have to verify it. So whatever control means whatever condition we are already mixing it in Apollo tires, and this is the optimized condition I have derived. You can see for the same formulation, same PCR compound, there's a huge difference of 12 to 13% RRC reduction, and also the filler is disposed properly in this optimized condition for the same compound. Then we have found time and temperature is a very important thing. So we went for RSM method, and we found that then we went for RPA kinetic study. If you see that 135 degrees Celsius, the rate constant is 0.1733. When you are increasing 10 degrees Celsius, here the salinization is not happening. 135 is not good for salinization. When you are increasing the temperature of 10 degrees Celsius, your rate constant is doubling it actually. So that means your salinization reaction is happening good. When you are going furthermore, the rate constant is increasing but not doubling. So always choose 145 to 155 degrees Celsius for salinization. So these are the conclusions I have told. And I haven't not only worked on this statistics and all, we have worked on catalyzed salinization, moisture assisted salinization, everything. So these are the publications. If you are having any doubt, you can refer these papers in the Google. Thank you.
Maybe you guys have any questions to the guy?
Not a question, but I think he's doing very well, and I would like to say well done. And so it's a publication, and I think he present nicely to show us this one is already DOE, so we can see clearly, visually, which condition is the best. So, yeah, to say.
Well, we
Thesis. Yeah.
So I request Dr. Sikula would get further development the good team. Our next presentation will be made by Dr. Ronak Ghosh. Okay, he did his master in Rubber Technology Center long back already. So from IIT Kharagpur, and then he was also DAT student. He did his MTech thesis work also in Aachen, right? At WTH Aachen, Germany. And then he joined as a PDeng, right? In University of Twente. Also after that, he completed his PhD. And I think a couple of months back, he who was also awarded PhD degree. So Dr. Ronak Ghosh, welcome here. And he will be speaking on this new vulcanization process, which is also, I think, it's going to be an exciting talk. Okay, over to you.
Thank you, sir, for your nice introduction. And yeah, as sir already introduced, I am Ronak, and in next 20 minutes, I am going to tell about my PhD research topic. First of all, good afternoon, everyone, and thanks for joining. So it's my pleasure that Kingship sir invited me. Before starting my research topic, I will like to introduce that what is the importance of rubber recycling. In every year, almost more than 25 million tires are discarded at the end of their service life. And where those tire goes? Most of the tire goes for the energy recovery purpose. Still now, landfilling that causes lots of pollution. Then also we do landfilling in some parts. Then the material recycling, and very less amount goes for the tire to tire recycling. And what is the challenge for the rubber recycling? Because rubber is infusible and insoluble in nature because of its three-dimensional vulcanized structure. So we can't do rubber recycling easily, just like thermoplastic. And now this is a global challenge, that how we can do the sustainable rubber recycling. I would like to introduce the recycling scenario of the EU. Though EU is much advanced compared to the Asian countries or the African countries, but there is also lots of challenges and limitation they are facing. They almost recycle 30% of the recycled rubber in the synthetic turf, 24% in the granulated molded products, few parts in the construction industries, 18% around in the downcycling, and only 8% is for the replasticized. That is, replasticized also contains the reclaiming and devulcanization together. And within that 8%, only 1% is devulcanized rubber. So you can see this is a drawback, or we can see this is an opportunity for spreading the devulcanization technology. Now I will focus on the aim of my research. In a one line, closing the tire loop was my target. If we can use old tire recycled material in the new tire, that is the most sustainable solution. Before my PhD, I also worked with a natural rubber and carbon black field system. But for my PhD work, I mostly focused on the SBR, BR, and the silica field, because SBR, BR creates a chemical bonding with the rubber. So synthetic rubber with silica field system devulcanization is the very challenging, and we took that challenge with our expertise. When we developed the devulcanization process, we kept in our mind that the devulcanization process must be environmental friendly and feasible with our existing system, and that must be possible to upscale the whole system. I will give a brief overview that how we focused on the problem. At first, we screened different kind of devulcanization aids. And they are mostly, my project was with Evonik, so I focused on the silent coupling agents because they are bifunctional in nature. And bifunctional agents works that when we break the bond, they couple with both the polymer parts and efficiently devulcanize the crosslinks. Then we screened the different kind of DAs. Then with the efficient DA, we did the process optimization. We opted for thermomechanochemical process. I will explain little detail later on. But after the process optimization, we focused that how can we further improve the properties with using the different DA combination and different DA components. Then after that, yeah, as a researcher, this is the most critical part, that to explain. If we have the result, then we have to explain that how it is working, not what results we have found. So we did the FTIR, GC, and also with the NMR, we proved that how our chemical is efficiently devulcanizing. Then in the devulcanization process, along with the devulcanization aid, there one other component is also added, that is the process aid, to swell the material and control the temperature, and also for some advantages. So we used process aid initially with the TDAE oil. Then also we went for the sustainable process oils like sunflower oils, Sorry. Then as our material was silica filled, we further introduced silane to check that how it is behaved with the field system, and also we added the further additional filler because we wanted to use our devulcanized material in the new tire. So it must be able to take few more filler, or it must be compatible with the other part. Then when we are claiming that we are trying to do the rubber recycling and tire to tire recycling, then we need to prove that how much percentage we can blend. So we tested different kind of application studies. Finally, we compared our material with the commercial materials, and we tried to upscale the process from the internal mixer or the batch process to the continuous process in the extruder. Now, starting from the basic, what is the difference between the reclaiming and the devulcanization? In the reclaiming, we break the main polymer chains as well as the crosslinks. So we get lesser mechanical properties, or the mechanical property recovery goes very less. Compared to the reclaiming, when we do the devulcanization, we try to break the crosslinks and keeping the main polymer chains as much as possible. So if our main polymer chains are mostly intact, then we can expect that compared to the reclaimed material, devulcanized material will show the higher or the better mechanical property after the devulcanization or for the subsequent usage. Now I am going to introduce a new concept of the devulcanization triangle. All of you are mostly familiar with the magic triangle of the rubber or the tire. So abrasion resistance, weight grip, and the rolling resistance. But similar to that, there is also a devulcanization triangle which I developed to measure the devulcanization efficiency. So in this triangle, the three axes are the efficiency of the devulcanization rate. So if we have the efficient devulcanization rate, we can do the devulcanization in a higher extent. If the length of the crosslinks are higher, then it is easy to break. So if the length of the crosslinks are longer, devulcanization efficiency increases, but the reverse thing goes for the crosslink density. If the crosslink density of the material is very high, then it is very difficult to devulcanize. So starting from the most difficult situation, that where the length of the crosslinks are very low, the crosslink density is also high, and the efficiency of the devulcanization is less, then we can expect that the devulcanization overall performance will be less. Then the most easier will be the exactly opposite to this situation. But what happens to the practical situation? In the tire vulcanization, they use mostly with the conventional vulcanization system, where we can expect a moderate level of crosslinks with a higher crosslink density. So our starting point was the violet triangle because we used the commercial rubber granulate, which was supplied by the Guinan, who were the granulating company, and they supplied us especially with the silica field, and the granulate size was 0.7 to 2 millimeter sieve particle. And our target was to improve the efficiency of the devulcanization aid by the process optimization. So from the violet triangle to the green triangle was our target. Now I'm going to explain that how we proceed with the experimental process. We swelled our material with the devulcanization aid and the process aid in a fixed percentage. Then we did the devulcanization process in a thermomechanochemical way. We analyzed the crosslink density and the viscosity of the material because that shows us the proof of the devulcanization partially. Then we devulcanized the material only with the curatives, and we analyzed the tensile strength. Also, we analyzed pain effect of the cured and the uncured sample. We also tested the miscibility. I'm going to show the results later on. So for the DA screening, what we kept in our mind that the DA must have the potential active moieties, otherwise it will not devulcanize. Then the processability must be easier because the commercial available DPDS or DBD have the very bad smell. So we need to use that in a process line. So that must be chemically sustainable and following the EU safety regulation or all the safety regulations mostly, that must not be carcinogenic or like that, and definitely with the innovation. We kept, for the first instant, we kept the process oil and the fill factor of the internal mixer constant. We varied the temperature from the range of 140 to 220 in that range, with a residence time of 4 to 8 minutes, shear rate variation, and the concentration of the DF. Now going to the results. We added only curatives and measured the tensile strength of the revulcanized material. We took the different silane based, so polysulfidic silane like Si69, disulfidic 266, and there are lots of existing papers with Professor Day and also Wilmers, my supervisor. So we started with the already proven reference samples, and we found the tensile strength of the model compound was around 16 MPa, and we was able to recover around 35 to 40% in terms of tensile strength. And then we also tested aminosilane and the mercaptosilanes like AMEO and like that, Si263. Then we tried with the vinyl silane like VTEO from Evonik. And then also to improve the further properties, you can see we find the tensile strength recovery around 9.5 MPa or more than 9 MPa tensile strength we found for the 100% devulcanized material. And then we further improved that with the vinyl silane peroxide, which is VP, which we already have the patent, so I have no issues to disclose the name. That is Silfin 301. So that material I developed, and that is also now available with the Evonik Industries. So we took actually 2 patents. First one with the devulcanization aids, and second with the process aid. And VP, or the vinyl silane with peroxide, we found the most efficient one. Now that shows the highest tensile strength recovery, or the highest tensile strength for the revulcanized material, then the highest network breakdown. So we considered this as the best efficient devulcanization. Now we also tested the miscibility of the material. We made a very simple test. We took the 10% of the devulcanized and blended with the 90% of the white rubber compound. White rubber compound was polybutadiene and the titanium dioxide based, and we blended. And if the particle is devulcanized, then it can be easily mixed or miscible with the white compound. And if it is immiscible, then it shows like the granulates. And considering that, we measure the miscibility and plot it against the tensile strength. And we found when going from the right side to the left side, efficiency of the devulcanization increases, but when we increase the temperature further, the main polymer chain breakdown started. So the tensile strength again dropped. So our target was to go to the left top corner, and we achieved around less than 0.5 MPa of the total area of visible particle and 9.5 MPa tensile strength. Considering the both miscibility, network breakdown, and the tensile strength, VP was screened as the best DA. After that, we tested mechanism and all those things, which I am not going to show. If you want, you can go to my PhD paper, PhD thesis. This is already online available. And then we blended the devulcanized material and the rubber granulates, which was almost in the same size, but one was cryogenically and the second was mechanically ground, because this was the demand from the company that how your material is superior compared to the other available materials. Then we found that the mechanically ground material was little bit superior compared to the cryo ground, because during the cryo ground, the mechanical surface was quite smooth, but the devulcanized material was much more efficient compared to the other ground materials. We found almost no significant reduction in the tensile strength up to blending the 20% of the devulcanized. And that shows that our devulcanized material was comparatively much efficient than the ground or the finer ground material. Then we upscaled the process in the extruder, and then with the upscaled process, we developed or we improved our devulcanization quality or the devulcanized material quality further, and then blended with the tire thread compound. We took a model tire thread compound and then we blended. In the left side, you can see the property of the 100% model compound, which is around 16 MPa, and the tensile strength around 16 MPa, and the 300% elongation at break. And we blended up to 20% devulcanized it and found no significant reduction or less than 10% of reduction in the tensile strength and the elongation at break. We also compared the oil reclaimed material in the same concentration of blending, and we found around 20 to 25% of the tensile and the elongation at break sacrifice. So we can clearly see that how our material was efficient compared to the reclaimed one. We also blended further and also tested for the 100% devulcanized material, where our target was to use the devulcanized material completely for the thicker or the lower grit application, where tensile strength was not important, but around 20% was the target for the tire to tire recycling. Now, if we can see on the comparative basis, we tested different tire properties, and we found that we improved the aging resistance properties because the devulcanized material or the feed material for the devulcanized rubber was the already aged granular. So the aging resistance properties got improved for the when we blended the devulcanized material, and also we improved the weight grip properties and the tear resistance properties, because the fine particles of the devulcanized material creates the hindrance when the crack propagation takes place. So it improves the tear resistance up to a certain percentage, and then after that, the properties get reduced further. Now I'm going to explain comparative results where we thought that we can directly implement our internal mixer results to the extruder, but that did not happen, of course. So we started in the internal mixer around 180 degrees centigrade as the optimum temperature, but due to the shear forces, the temperature increased in the internal mixer. But in the extruder, the temperature control was much more optimum. So we found the optimum temperature in the extruder around 210, while in the internal mixer is the 180 degrees centigrade. And within 2 minutes, we efficiently did the devulcanization, and you can see we almost break down 75% of the network, and the viscosity is in the processable range. Now, my last slide with a summary. According to our claim or the different results, we found that from the existing solution, we found that 15 to 20% better devulcanization efficiency, and VP or the vinyl silane with peroxide showed the best one, and we improved the devulcanization efficiency. Otherwise, I would not got the PhD degree for sure. So we recovered the 55 to 60% of the tensile strength, 70 to 70% of the network breakdown. We claim that we can mix 20% of the devulcanized in the new tire without significant reduction in the property. And finally, for the lower quality material or the thick material, 100% can be used. And the upscaling or the industrialization of the process is also possible. I would like to thank my department and the funding company, Evonik, for supporting my research. Thank you all.
Thank you very much. One question. If not, it's fine.
Thank you. Kanika, please.
You showed that the tensile strength and elongation at break more or less the same, right? Just like less than 10% reduction. But you mentioned that you have hand strength and grip improvement, right? Am I correct?
Yeah.
And how can you explain that? Why do you have a better hair strength?
When we blended the 20%, you can see.
Yeah, what can be a mechanism behind it?
Yeah.
I wonder why you have that better chance.
Yeah. The devulcanized particles, when it is in the very fewer in number, that creates a concrete effect that harder particles restricts the crack propagation. That's the mechanism for the improvement in the tear resistance. And when we increase the further concentration of the devulcanized material, then that crosses the defective spot. If there are lots of devulcanized material, because devulcanized materials, the weakness is the surface interaction. That's the problem because of the difference in the viscosity and the cross-link density. But if the particle is very fine and it is in the crack tip, then energy dissipation takes place. Yeah. Are you satisfied with the answer? Otherwise, I can answer it.
Which person can get worse.
Yeah.
It may see the optimum at certain level of confidence.
Yeah, exactly. So you can see in the 50%, the tear strength reduced drastically, the yellow line. The 50% is very poor. So if we increase after certain concentration, then it gets reduced, definitely. Yeah.
I think it's possible.
Yeah.
I agree.
Thank you.
We need to stand here.
Yes.
Thank you. Thank you. Very much. This question. No. This one is in thank you. Just one second. So last talk in this session will be given by Dr. Vaishak. He is from MG University, Mahatma Gandhi University, and I think he completed PhD last year, right? Last year, and now he is currently a research associate and working with Dr. Srikala, who also presented today morning. So what to you, Vaishak? Okay, please.
So good afternoon all. Thank you. First of all, thank you, Kinzuk sir and Team Technobis for giving me an opportunity to talk in front of the senior experts here. So previously you have heard about the advantage of devulcanized rubber in tire sector. Now I will be presenting the advantage of reclaimed rubber in the tire sector, and also I will be giving a cost-effective tire tread formulations. And for that, I have used two grades of reclaimed rubber. One is the whole tire reclaimed rubber, and the another is a latex-based reclaim. So the whole tire reclaimed rubber is actually obtained from used tire products, whereas the latex reclaim is obtained from used NR products. So for a quick introduction, as you all know, the automotive tire industry is one of the biggest industry in the rubber sector. And nowadays, all are running behind the concept of sustainability, and tire sectors especially are finding new ways to obtain to attain the target of carbon neutrality by 2030, 2050, 2070, like that. So for that purpose, they are trying to reduce the raw material consumption. They are reducing the dependency from petroleum origin source. They are finding new consumable, renewable resources. They are trying to improve the quality parameters and all. So For that purpose, several economy models are being suggested. After industrialization, it was linear economy model where we will extract the material, we will consume, and later on we will dispose. And this equation has changed, and this dispose thing is replaced by several other R's that we call redesign, renew, reduce, reuse, repair, recover, and recycle. All these have their own strategy, and the use of devulcanized rubber, use of reclaimed rubber, all comes in the strategy of reuse, where we will upcycle the waste materials. So my area is on reclaimed rubber. In the market, there is a large amount of different grades of reclaimed rubber are available, and my focus is on whole tire reclaim and latex based reclaim, and have looked the utility of these reclaimed rubber in tire tread formulations. So why reclaim rubber? Due to the fluctuating price of the natural rubber and synthetic rubber and more accumulating waste rubbers, people are market demand for reclaimed rubber is being increased, and the quick market outlook for reclaimed rubber. The main factors that drive reclaimed rubber is the sustainability manufacturing, the cost effectiveness, several government regulations. I think tire companies are being imposed with certain regulations, they have to dispose their own tire tread materials in a proper way, and also the environmental impact reductions and all those things. And one of the challenges that we face to use reclaimed rubber in the market is that last time we have suggested a proposal to one of the Russian company, and the thing they are saying that they are not willing to market reclaimed rubber. What they are telling is that they are not getting a consistent source of reclaimed rubber. If one batch reclaimed rubber provide, the next time the reclaimed rubber that is with different source, so it is very difficult to get a consistent source of reclaimed rubber. I think we should address that area also. So that is one challenge that we face. And also from our side, we should focus on the research and development to produce a high quality rubber, high quality tire tread formulations without sacrificing cost efficient tire tread material without sacrificing the quality. So the major segments are the Asia Pacific regions. They are due to the increasing amount of automobile sector. China, Indonesia, Vietnam, Thailand all are anticipated to become the main growing market for reclaimed rubber. Coming to the European region, there a black cycle project is launched in Western European countries. It is backed by European Union's Horizon 2020 program, where this black cycle project is considering reclaimed rubber as a second generation raw material that can be used to develop any sorts of rubber products. Okay, so as I have already mentioned, from what I have studied, the challenge is that whenever we are incorporating reclaimed rubber into a rubber system, the property will deteriorate drastically, mainly in case of abrasion resistance. So we need to balance these properties. More research is needed. So this is the main objective, to develop a cost-effective tire tread formulations complying to national standards. Why complying to national standard is that when I was doing my PhD, the main thing is that all are going for a academic level of paper. No one is going for a practical sense. They will say this will increase, this will increase, but no one will look upon the practical, whether they can be commercialized or not. And for that purpose, when this is the formulation that I have studied, I have replaced natural rubber with the reclaimed rubber, 2 grades of reclaimed rubber. And after replacing that, I have studied whether I have gone up to 30 PHR of reclaimed rubber by replacing natural rubber. And the thing is, we have also studied whether this will find a utility in developing tread rubber that will satisfy the ASRTU specification. And these are the benchmarks that is needed to be fulfilled by the tire tread. It should have a specific gravity of 1.14. It should have a hardness in the range of 60 to 70. These are the modulus range we need. We need at least 20 MPa tensile strength, and especially the main thing that we focus is the abrasion resistance, and it should be 160 index. Okay. So these are our benchmarks, and we are trying to find whether these formulations will fulfill or not. So initial study is based on whole tire reclaim, and coming on to the cure characteristics. So the main thing you should think in mind is that since it is obtained from a used rubber products, it have a residual curatives present in it, residual fillers will be present, crosslink gels will be present after reclamation. So these all factors have definite effect on overall properties of the system. So here we can see that the optimum cure time and scorch time in all systems, it is decreasing with the increase of the reclaim content. This is because on further vulcanization, this will the residual curatives present in the system will affect all these properties. Now coming to the tensile strength, as I have already told, the mechanical properties starts to deteriorate upon reclaiming upon addition of reclaim rubber, and this is due to the incorporation of low molecular weight reclaim rubber, and also there is cross-linked gels present in the reclaim rubber. So when we are adding this reclaim rubber into it, these cross-linked gels will act as stress concentrating points, which will concentrate stress in that particular area, resulting in the failure of the mechanical properties. This has what happened here, and you can see certain formulations that fulfill our SRTU specification. Okay. Now coming to the abrasion resistance, this was a bit, we have not, this is the main drawback of whole tire reclaim. Even after addition of 10 PHR of latex reclaim, even in the synthetic rubber rich system also, we have not fulfilled that 160 benchmark. All are dropped below 160, which we need to be addressed. Then coming to the elongation at break, these are all there is no need to worry about elongation at break and tensile strength and all. We can adjust easily. The main thing is we should address abrasion resistance. And here also, as Raunik in the previous talk, he told that his tensile strength had increased. But in my case, the same thing, these crosslink gels act as stress concentrating points. So crack propagation might not be that much good actually. In my sense, I think so, because these concentrating points from that crack will start to initiate if so maybe any other chemistries might be behind that of them. Now coming to the modulus, entire according to the specification, 300% elongation is the main thing we will focus, and we have that for all the formulation satisfies that limit. And this increase in the crosslink density is due to the residual curative system, which will enhance the crosslink density and further vulcanization. Now compression set has increased, and this is because introduction of reclaimed rubber. This is a low elastic material. So when we are incorporating more and more reclaimed rubber to the system, it will reduce the elasticity. And as a result, when a stress is applied, there will be no irreversible flow, because due to the lack of elasticity, and the compression set will increase, and due to the increase in the residual fillers, obviously hardness will increase. Now we have studied the thermogravimetric analysis to study the degradation temperature, and also we have calculated the activation energy upon incorporation of reclaimed rubber using Cotret-Fund plot. And here we can see that the thermal stability had increased with the incorporation of reclaimed rubber, and this might be due to the increased crosslink density. So this is a morphology. As we can see that NRBR have with the control sample have a homogeneous morphological system compared to the incorporation of reclaimed rubber, and upon addition of 30 PHR, the homogeneity is disturbed, and this might be due to the this might be the reason for the inferior mechanical properties. So this is a quick synopsis of what we have discussed. And modulus at 100 and 300%, compression set hardness increase with the increase of reclaimed rubber. TG analysis showed that the thermal stability of NRVR blend system was increased with the incorporation of reclaim, whereas tensile abrasion mechanical properties obviously goes down. And so coming to the next reclaim, this is latex-based reclaim, and one of the I'm not going to that much because the same trend is had obtained compared to Voltaire reclaim, but I will show some advantages here. We have more formulations since it is obtained from used latex products. The RHC content is too high for Voltaire reclaim. Its RHC is around 48-50 like that. For latex based reclaim, it is around 80%. More rubber, we will get more amount of more properties, and it is clearly evident that even after addition of 30 PHR of latex reclaim in NRV system, we have that 20 MPa benchmark. And this is the modulus are similar. So abrasion resistance is this is one of the good results that we have got. Even after 30 PHR of latex reclaim in a synthetic rubber rich system, we have that abrasion resistance index of 170, which is, I think, when coming to the class of when we are looking at the cost, this 30 PHR of latex reclaim is huge, I think. And similarly, the costing density has increased the thermal stability. And we have just looked upon the homogeneous distribution of carbon black using carbon black dispergrator. And these are the X values that we have obtained. And it is clearly seen that the homogeneity is disturbed upon addition of reclaimed rubber. And this is the SEM analysis. And this is the synopsis. So for a quick glance, these are the comparison of latex-based reclaimed rubber with a Voltaire reclaimed rubber. And if you want a good abrasion resistance with a reclaimed rubber in the formulation, we can go for a 40-60 and a 50-50 blend system. And in 40-60, we can go up to 30 PHR of latex reclaim. And for a 50-50, maybe we can, after 10-15, up to 15 PHR of reclaimed rubber can be incorporated without sacrificing the abrasion resistance. Similarly, all other properties. Now, just a quick analysis of cost. This is for a latex-based reclaimed formulation, and about 24% of cost has been found to be reduced compared to the control sample with the 30 PHR of latex-based reclaim. So thank you.
Thank you.
And I forgot. Actually, the thing is, we need to work on. This is the initial stage of our work, so we need to work more because companies are asking how can you address this, because the thing is the reclaimed rubber have very low molecular weight. Low molecular weight in it, so we need new techniques to reclaim the rubber without reducing the molecular weight. We need to find ways for that. So that would be the future, and we are planning to submit some proposals regarding that. So I would like to acknowledge it, Technobis, and I have done, the work has been carried out between Mahatma Gandhi University and Rubber Research Institute of India. Thank you.
Any quick question? Is there any study on the final product?
Yes, there is lots of academic papers are there, but yes. I haven't gone that much far, but this is the initial stage. We have studied. First, we have to optimize the basic mechanical properties, then only we can go for, because when if I have told that 40-60 blend system have an excellent abrasion resistance up to 30 PHR, maybe we can go more. If we add some small amount of PR, we can for ternary blends, maybe we can go for extra amount of latex reclaim. So, but at that time the tensile strength is going down, so we need to optimize first. And yeah, that's it. And we need to first optimize the mechanical properties first, then only we can go for the noise and all. And that another thing is that we can further reduce the cost of the material, because I have told that these have residual curatives present in it. In most of the companies and conference and talks, I have heard that they will reduce the cost of the rubber products usually by incorporating fillers. If they instead of carbon black, they will add calcium carbonate, like that, all those things. So instead of that, just look for the curing systems. We have residual curative systems present in this reclaimed rubber. Make use of that residual curing systems during production stage. Get rid of cure systems, raw cure systems. Get rid of that sulfur and all. Make use of these residual curatives. This can further reduce the cost. But if from your point of view, first we have to optimize the mechanical properties. Okay.
Like in reclaimed rubbers, right? If in India, scrap the tires with non-sterilized way, right?
Yes. No, that is a challenge I have mentioned. Yeah. I have told now the companies are not willing to take up market the reclaimed rubber because of this problem. Maybe someone from here is.
Last question. Actually, that fuel is receiving accelerators.
Yes.
It's good proposal. So it's usually final backstage.
Final
Backstage. Mixing. Final batch.
Yes.
Not.
No. Because I have done in the final master batch, because from the literatures it has been mentioned that whenever we are incorporating in the initial stage, it is already a low molecular weight system. So we are again masticating again and again to further reduce that. So we have introduced in the final stage.
And secondly, supplier or all around suppliers.
All along the suppliers, this is a situation actually, because in our work also, this latex reclaim that we have obtained, when we get the first batch, it was different, and the same person that they supplied the latex reclaim, when we tested the TG analysis, the residue had changed, the RHC had changed, like that. So that inconsistency is a big problem, especially the whole tire reclaim. Latex products, I don't think there is no much variations in the formulations can happen, but in case of whole tire reclaim, it's a problem. We have to work on whole tire reclaim actually. Tire based is
Session. Please.
okay.
So once again, thank you very much for your. Thank Dr. Anand, very talking over here, my batchmate as well. You do the honor. Thank you. Thank you. That is nice. I have a question, the last question for all of you. Are you hungry? Please go. Shop to pay. No need, sir. Perfect. Okay. I will read the question. I know reunion will have this. I'm your group. Hello,
It looks like I may not able to do this one in this program because it's so tight. Schedules. Oh my God, yeah, right, last time. The last, I shouldn't pay you. Still somewhere is covering, somewhere some short, somewhere. So that's room we have. So today is a bit challenging also, and I had 2 sessions, but I have a lady here.
You communication thing there or all okay. But my slides are there.
Check, that will be a one session. So this are good. आप लॉगिन आईडी किए हैं? हेलो, आपको हाँ जी साहब, सर लॉगिन आपको मैसेज में ना लॉगिन आईडी और पासवर्ड आया है, तो लॉगिन आईडी से आप लॉगिन कर दीजिए और पासवर्ड डाल के आपको खुल जाएगा, तो अपनी 2 आदमी को वोट दे आपको मैसेज में आया। नहीं सीडीएस तो शेयर नहीं है, सीडीएस को हम लोग अपॉइंट किए हैं इलेक्शन कंडक्ट करने। आप सीडीएसएल में डालिए, सीडीएसएल में डालिएगा तो ये आ जाएगा लॉगिन आईडी और पासवर्ड। आप लॉगिन आईडी में उसको लॉगिन करिएगा और फिर पासवर्ड डाल। नहीं वो आपका सीडीएसएल ने किया है मैसेज में, सीडीएसएल ने मैसेज में आप खोलिए मैसेज को, उसको दिया हुआ लॉगिन आईडी और पासवर्ड। हाँ सर जेट, हाँ कहिए सर, कुछ प्रॉब्लम हो तो बताइए फिर हम लोग कर। अच्छा हाँ जिसमें आपको बैठेगा ज्यादा हो गया। अब इसके बाद देखिए नेक्स्ट मंथ आपका जो है वो जरूरी है। नेक्स्ट मंथ से जो है ना, आपको डिस्कस कर रहे हैं। हाँ आप कह रहे हैं नहीं आप भी रहिए, हम लोग प्रॉब्लम नहीं है, हम लोग का तो जितना कंप्यूटर हम तो बहुत फ्रेंडली है, हम चल रहे हैं। अभी आप ये आपका लीडर मैं 4 कंपनी का लीडर, चारों हम लोग साथ में बैठे अभी मेरे ऑफिस में सब वो चला था, वहां सब नहीं आया है, मैं था मेरे मीटिंग हो रहा था और ये सब जितने भी लोग आ जाएगा, मैं आपसे बात कर लीजिए। वही कह रहा था कि इनका डबल प्रोडक्शन हो रहा है, सारा अरे यार दुनिया में कोई भी चीज छूटता नहीं है, हम लोग क्या करें, हम लोग तो ऊपर ही आपको बात बताए सर, हम बड़ा सिंपल काम करते हैं। आप तो बात बताइए, जिसका जो काम करने का है आप अपने सिस्टम से चलिएगा, कंपटीशन रहेगा, काम करना है इसी के अंदर तो सब काम करेंगे, जो माल प्रोडक्शन हो वो बिकेगा ही, अप्रूव भी करेगा। ये ना पार्ट ऑफ रजिस्टर्ड कंपनी, हमको तो सब पता नहीं पड़ता है मार्केट में, इसी को भी प्लांट बन गया, हमको तेजी को सर्कुलर देना पड़ता है, मधुपुर कितना गया इनका प्लांट मेला है हमको बताना पड़ता है, इसलिए नहीं बताएंगे तो हमको कुंभ मेला में ये और मार्केट है ऐसा, ये बॉम्बे की सेल देखते थे, वहाँ पे देखते हो दिल्ली का उस वो महीना तो वो टाइम महीना थोड़ा बेकार, मतलब ऐसा फाइन मॉडल कहते हैं, मान लीजिए आपको हमको माल दिया, हमको कहीं खराब बात नहीं लॉस, आई थिंक और बड़े बड़े वॉल्यूम वाले कस्टमर के साथ पर यूज करेंगे, और उसके बाद जो डाउनफॉल शुरू हुआ बीच में थोड़ा सा ठीक हुआ था, बीच में ये आया था ना पंकज तो कुछ ठीक किया था, लेकिन वो अभी एक बार ये वाला भी हुआ था 13 14 से जाने के बाद
18-19 तक नहीं रहा, देखते ये दोबारा बना। बहुत बढ़िया चल रहा था, पूरा बेच दे रहे थे, 100% एफिशिएंट लिए उसको। और नॉर्थ में 1100 टन पहुंच गया, बाकी 3 रीजन में 400 टन, 15 करोड़ रुपए। अरे कौन है अभी राशन से प्लांट मतलब जोड़ा में नहीं अपने क्या बने, अरे अपना भी बंद नहीं होता है, इसलिए ये तो बंद करना ना होता है। लखनऊ साइड नहीं करता है लोग, क्या लगता है बच्चे मोटा से नहीं लेकिन वहाँ वाले के लिए मिले दोबारा कैसे आपके अंदर अच्छे मिले, यही लास्ट में अच्छा फैसिलिटी है, 24-25 साल उसमें भी है मिडिल आप थोड़ा मेहनत कर रहा है, मारवाड़ी कंपनी में गया नहीं तो मिडिल का तो राज चल रहा है। एग्जाम में था, कल बोला है दिल्ली के सामने खाली 1 से 5 तारीख तक ये काम करता है, वो भी दिन 1 2 घंटा का काम है। लड़की को स्पीच लगा के उसको छोड़ा था, जहाँ ले जाके घर पे छोड़ के फिर 2 घंटा काम करके फिर मस्ती की। करके तो उसको कहीं बुलावा ना कॉर्पोरेट जो स्टेज वाला फिर तो मैं नहीं आ रहा, बिल्कुल तो फिर ये प्रेशर में है कि जब को इस बार भी नहीं आता ये सब सारे जो टेक्निकल आदमी आए ना, ये मतलब मैं क्या बोल रहा उसके बाद फोन किया तुम्हारे तुम्हारे वही मिलेंगे गूगल में जो मेरे यहाँ के लोग आए थे वो तो उसने सारे नहीं कर रहे यार एक दिन पहले हम लोग ने कहा सबके साथ मैंने कहा यार तू ऑफिस आया लेकिन उसका आरपीएम जरा फास्ट है, ज्यादा नहीं जाती उसको बंगाली बंदा है वो है बंगाली बंदा है, जैसे हमारे मुंबई के पुणे में होते हैं ना, टिपिकल पुणे मराठी 1 से 4 आराम करने वाले इसको तो लगी आराम मिल रहा है, इसको कुछ करना नहीं पड़ा। अब तो आराम मिल गया, अब तो बेटा रगड़ के रखा हुआ है, रात 11 बजे फ्लाइट से आओ, लास्ट फ्लाइट से आओ, फर्स्ट फ्लाइट से जाओ, 11 बजे अटेंड करो, का पूरा चक्कर बच एरिया बहुत बड़ा दे देना और इंडिया मार्केटिंग करने में 150 करोड़ का हैंडल कर रहा है आपको बता तो हम 150 नहीं चाहिए आप अपनी बात करते हैं अभी जो है हाँ सीरियस है तो सर मैसेज किया है परसों इस नंबर पे कि आपका हैंडल नंबर पे गया है अरे इसमें ऑप्शन है, आप खोलिएगा तब ना ऑप्शन मिलेगा, उसको भी कहीं बाहर जाएगा मिलेगा। अच्छा मैं अपने आदमी से मैं आपको 1 मिनट में बात कर रहा हूँ, 1 मिनट हाँ चलेगा हाँ ठीक है यहाँ पे कॉपी काम का तो आप ये भी कर सकते हैं और वो जो पढ़ा खोल लिया था मैंने সুন্দর সুন্দর আমি মেট্রো রাখবো করবে সুন্দর করে রেখে দেবো ठीक है सर यहाँ पे 4 बजे की पूरा और वहाँ में जाओगे ना वो 4:30 बजे 4 बजे 2 हो गया ये तो अपने इंडिया में ना दो टाइम का होना चाहिए 4 ये साउथ का अपना तो लंबा है नॉर्थ में ना तो नॉर्थ का देखना हो कंट्रीज में एक होता है पहले नॉर्थ में रहे होते हैं ये वेस्ट ये तो सिस्टम हमारे यहाँ तो 7 बजे तो स्टूडेंट्स होते हैं 7 बजे हमारे यहाँ जब भी साढ़े घंटे होते और यहाँ कोलकाता घूमने में 1 घंटे 2 तो आराम से अरुणाचल प्रदेश और मुंबई में मुंबई का पहाड़ ईटानगर मुंबई में 1.5 घंटे का यहाँ 4:30 जगह होता है ईटानगर में और मुंबई का होता है तुम्हारा 6 घंटे
পেন ড্রাইভটা লাগাও এই তো অপর্ণা
আরে ওটা আগে পুরোনো আমি চেঞ্জ করেছি এখানে তো
হ্যাঁ
হচ্ছে না কেন?
দেখি দি
না এখানে তো নয়, এটা তো অন্যরকম।
না না এখানে নয় একটা পেন ড্রাইভ খুলতে হবে এই পেন ড্রাইভটা কার আছে
এটা আমি বলতে পারবো না।
ওইটা খোলো ওইটা
এইটা খোল, এটা খোল, এটা কি আছে? এটা খোল, চার্জার আছে।
এটা চার্জার আছে
চার্জারের
না চার্জার
আলাদা।
পয়েন্ট ঢুকবে না তুমি ওইটাই খোলো ওইটা ইজেক্ট করা আছে ওই ইজেক্ট করতে হবে না খুলে দাও ঢুকিয়ে দাও
আরে এটা ঢোকাতেই যাচ্ছে
না
ঢুকেছে।
ঢুকেছে না এই যে কোথায় আছে
নিচে পিপিটি দেখ, নিচে একটা টান, এই যে লাস্ট
এইটা
হ্যাঁ কপি
করে ওদেরটা আপনার নেন
এটাকে ডিলিট করতে হবে।
না দাঁড়াও আগে আগে এখানে পেস্ট করি
পেস্ট করা যাবে?
হুম
আচ্ছা এটা রিপ্লেস
So we like to move to other room first.
কপি অ্যান্ড রিপ্লেস
This one.
এটা একটু খোল।
এটাই নাকি
হ্যাঁ হ্যাঁ এটা খোল, চেঞ্জ গুলো
এই তো
এসছে
3টে আর
নিচে এটাই
এটাই তো
ঠিক আছে।
হয়ে গেল?
আর একটু নিচে, পুরোটা নিচে, হ্যাঁ ঠিক আছে
ঠিক আছে
হ্যাঁ
ঠিক আছে তাহলে ওটা রিপ্লেস হয়ে গেল
হুম
হুম
এবার এটাই
এখানেই থাকো এখান
না,
থেকে
কিন্তু এটাতেই হ্যাঁ করবো, এটা তো ঠিক
এটাকে
আছে
চেক
যদি
করি দাঁড়াও শুনুন এটা যেমন শুধু ঢুকিয়ে দাও নাকি
এটা কিসের বলতো?
কি জানি আমি তো
ওটা paper pointer.
ও আচ্ছা ওটা
হ্যাঁ হ্যাঁ এটা হচ্ছে হল 1 এই হল 2 এটা হল 1 আমি তো হল 1 আছে Please, carefully, please.
Which one?
Conference call. No, that.
Okay, first one.
Nothing is there. Oh, it is there.
Oh no. And
Something I will say that.
so this one I delete, right?
It's not actually not sent this one.
Okay.
They will not send me. Let's let's check it. Just who's this? Otherwise, that person if don't have very much permission.
This is another person. This one is yours, right?
Yes, Mr. Let's check. Sent. Now, once you put it in this one, it will disappear. Just you can put it here, no, and it will get disappear.
Yeah. So
And don't delete that, because there's an issue for a month. Where is that?
okay, that's fine. Here's the see.
Thank you. Not now.
Yeah, okay.
Let's just leave it up. Is big.
Yeah.
This is center.
Yeah.
Listen up.
Okay.
Where is it?
So next.
Where is laser? This one, no?
This one laser. Yeah.
This is for next.
Yeah, it's changing.
Okay,
That's right.
অনেক আসে কত দিয়েছে কিন্তু ওখানে কিন্তু একদম সফটওয়্যার করে যায় তখন কি হচ্ছে আর তখন আমি এই কারণটাই কারণ জানি তারপর কিন্তু নেই ওটা কিন্তু কারণটা পেয়ে যাচ্ছে আবার যেগুলো সব নেই ওটা কিন্তু বাজারে এখন আপনি কি চাকরি করেন সেটা হ্যাঁ আমি কিন্তু নিজে থেকে এসেছি ডাইরেক্ট এক্সপোজার লেন আমি হয়ে যাচ্ছে আমি দেখেছি ভালো করে হাতে বাড়ি একদম সুন্দর লাগলে মানে ওই জিনিস মানে আপনি আর তখন যখন কাছাকাছি তোমারটা বেশি এত খারাপ না
টায়ারের জিনিস সেটা হয়ে যাওয়ার পর আবার সেটা তাহলে হাওয়া
শিখছে কিন্তু এরপর মন করে কাটতে যাবে তাই দেখে কিছু আবার কি দরকার হবে মানুষকে ওরা আপনার টেকনোলজিক্যাল নলেজ কিছু লাগবে না নন টায়ারে যাবে নন টায়ারে বড় বড় কোম্পানি দাদা নন টায়ারে বড় বড় কোম্পানি জানি লস এরকম হচ্ছে না কোয়ালিটি বলবে এটা দিয়ে কথা না নিজে বলতে বিজনেস করে লাভ আজকে কি বিজনেস মানে প্রফিট করা বিজনেস মানে সোসাইটিকেও দেখতে হবে আপনি কি করতেন ইংলিশ শিখবেন আমি কিন্তু একসঙ্গে জল করা মানে সিম্পলি তিনি ক্যান্টিন থেকে অনেক সময় খেয়ে রয়েছে তখন তুমি খেলে এসছো অ্যাকাউন্টস কদিন থেকে ওয়ান নেই সেই রকম হচ্ছিল স্বাধীন হয়েছে সারা দিনে ঘটনা বলেছি আমাকে একবার পাঠিয়েছিল ট্রান্সফার আমি অফিস আপনি কোথায় আসছে আমার একটু করলেন বাড়িতে আমার পেয়েছিল আমার ডিউটি অনেক সময় আমি গিয়ে আমি ফোন করি সমস্ত আমি 12টায় ফোন করি তখন আমাকে বললেন আচ্ছা আপনি 12টায় ফোন করেন ওটা এসছে এখন কি করছি আমার এখন টাইম দিলাম ছিল আপনি ফোন করে এসেছেন আমি দিয়ে দাও হ্যাঁ আপনাকে ছেড়ে দিলাম আমি তো সারাদিন করবে তারপরে আমি ভাবলাম বাড়ি ফিরছি সন্ধ্যেবেলা তারপরে আমি এই ক্লাস স্টুডেন্টকে বললাম শুনে এলো আমার এসে শুনে এলো যেগুলো আজকে আর কথা বলবো না কেন এসে আমার সাথে আপনি হচ্ছে না বলতে দিন অবশ্যই বাড়ছে গাছটা আমি বস্তার সাথে তখন সব আপনি যদি কর্মসূচি মধ্যে রেগুলার আমি 10 থেকে বেরিয়ে বলেছি বুঝতে পারিনি কম করতে জলদি আমি ভাবছি তুমি বলেন যে আমি বেশি ক্লাস সব হয়ে গেছে আমি খাবার কথা হয়েছে আপন শুনলেন এই এক ধরনের ছেড়ে কিছু বললো এরকম ধরনের তারপর না অনেক সময় এমন সেটিং হয়ে গেছে এবার কি হয়েছে না আপনি শুধু আমাকে মানে কিছু মনে হয় আপনার সেপ্টেম্বরে আবার ট্রেন দরকার এই যে মন্টার কাজ বহুত স্পষ্ট এইরকম এরকম ইউজ করে এরকম কাজ সারাদিন ভাবতে তারপরে পঞ্চাশ মতো হয়ে গেল এক খাঁচা ভর্তিটা এই যে এই মুহূর্তে ওই পাহাড় পাহাড়ে ইয়ে টেস্ট করে ব্যালেন্সিং এই ধরনের থাকলে পরে এসব বুঝে কি হবে আমাদের পক্ষে নদীর মধ্যে মনে মনে পড়া যাবে এবং যখন আসছে তাকে লোক পছন্দ আছে হাইটেক যখন ওরা বিল্ডিং করে বিল্ডিং করতে একটা বিল্ডিং করছে যদি এই দিকে ফিটনেসটা একটু বেশি থাকবে এই দিকে থেকে তাহলে কিন্তু ডিসব্যালেন্স হবে এগুলো আয়রন না যে একদম দুদিকে ফিটনেস সমান পাবে এখানে 2.5 হয়ে গেল এখানে 2.2 আছে আপনি যখন ভাবিয়ে নিন যখন ট্রিকটা হওয়ার পরে ট্রিকটা দেখেন একদম ঘেঁষে থাকে তাহলে ট্রিকটা না সুশান থেকে বেরোবে যেহেতু এভাবে লাগাবে জয়েন্টটা কিভাবে হবে বাদ জয়েন্ট হতে পারবে তাহলে ওখানে প্রেশার খুলে যাবে তাহলে স্টেবলটা পাবেন ওভারটা আপনি ঠিক বেড়ে যাবে তাহলে কি করে হবে তাহলে এই সাইডে আমার খারাপ থাকবে এই দিকে আমার খারাপ থাকবে মানে ভাই আছে এবার থিকনেসটা বড় করে থাকে এই এক্সট্রা থেকে এক্স্যাক্টলি ওরকম কাটিং দিয়ে বের হচ্ছে বুঝতে পারলেন এরকম আমরা এক সাইড করতে পারতাম আর সাইড এরকম হবে এরকম জয়েন্ট হয়ে বা আসলে সেটা হলো মানে অ্যাঙ্গেলে থাকে এরকম কাজ করে না তুমি একই কারণ সেটা কি হবে যখন ভাঙবে প্রেশারটা একটা লাইন ধরে চলে আসছে একটা প্রশ্ন করার এবার আমার কি করছে ওজন পেয়েছে মিনিমাম বেশি আছে টোটাল রাবারটা নিচে তখন ওজন বেশি হয়ে গেছে ওদের ওজন করা আছে ওই যে শীতটা বেরোলো ওটাকে আবার রিসাইকেল করবে ওটাকে ইউজ করবে আবার ডিপোজিশন ঘুরে আসবে এই যে টলারেন্স লিমিট আছে প্লাস মাইনাস মানে সেই আবার ঠিকটা তো হবে পিছন দিকে নেবে একটু জানা তো কোন বেশি আছে তাহলে লেবার কি হচ্ছে ভীষণ ইম্পর্টেন্ট এখানে নিজের এখন তো 2 বছর লেগে যাচ্ছে আমাদের রং ক্লাস বিল্ডিং আমরা এখন কাজ করে হচ্ছে তখন ক্লিনিক্যাল ফর্ম আমরা তো দাদা মানে রাবার মানে হচ্ছে টেকনোলজি কেমিক্যাল মানে রিসিক্যাল অর্গানিক কেমিস্ট্রি সব অর্গানিক কম্পাউন্ড কার্বন রাবার অ্যাক্সিলেটর অ্যান্টিঅক্সিডেন্ট সব আছে জিঙ্ক অক্সাইড করে আছে কার্বন খালি কার্বনই আছে হাইড্রোজেন আছে কার্বন হাইড্রোজেন জাতি আছে অপশন গুলো আছে খালি জিঙ্ক অক্সাইডটাই আর সিলিকা পিলার দিতে পারে এগুলো সবই এগুলো অর্গানিক কেমিস্ট্রি মানে আমি বললাম যে এখানে দেখেন এগুলো হচ্ছে নাইট্রোসাম কিউরিক বলছি না কি কেন ওটাকে বলছি নাইট্রোসাম সব বলে যাচ্ছে নাইট্রোসাম কি দেখে বুঝে এক্সাম্পল অ্যাক্সিডেন্ট বড় সাকসেস নামে বলে কি দেখে বুঝে গেছে এটা আমার এক্সাম্পল বলছো ধরো অ্যাক্সিডেন্ট ব্যাংক অক্সিডেন্ট কি কেন বলছো হোয়াইট নাইট্রোসাম এটাকে তো বলতে একটা স্যারের পুরো দেখলাম আপনার কথা বলা ভালো কিছু কিছু আইন দিয়ে নর্মালি ডিসিশন হচ্ছে কিছু কন্টেন্ট বাদ দিচ্ছে বাকিটা এরকম থাকছে যেগুলোকে বাদ দিচ্ছে সেগুলো কেন কি করতে হবে মানে যেটাকে বাদ দিচ্ছে যেগুলো তো স্যারেরা বলবে কোন দেখেছি কিছু কিছু জিজ্ঞেস করে গ্যারেন্টি দিয়ে দিচ্ছি ভালো কথা আছে আমি জানো তোমরা কেন ওই যে আইডি অয়েল বলছে দেখুন পিএইচ টাকে তো বড় পলিয়ামিক হাইড্রোজেন তো বাড়তেছে থাকছে তো পলিয়ামিক হাইড্রোজেন থাকছে তো জিনিসটা বাদ দিচ্ছে এগুলো কি কেন বাদ দিচ্ছে এগুলো কি হতো আমরা যেগুলো বাদ দিচ্ছি সেই কারণে সবাই কেউ থাকতে পারে আসছে এই প্রশ্নটা আমার উত্তর পাই না আপনার এদিকেই বলছি এই যে বলে না সরকার নিয়ে আসবে
Welcome you all in the welcome you all in the post lunch session. So our next speaker from our IT KGP by the next session will be by Muthamil Selvan. So please. Thank you. One second, just I need to share the screen.
Good afternoon, everyone. I am Uttamil Selvan from IIT Kharagpur doing PhD under the guidance of Dr. Tirthas Mandal. So today I will be presenting on the topic liquid elastomer based elastomeric skin for non-tactile sensor. Let's begin then. Like we all know the polymer nanocomposite, like we are blending of the nanofiller inside, like we are dispersed inside the continuous polymer matrix. And this nanofiller actually we should have the one dimension should be less than the 100 nanometers in size. So the nanofillers which commonly used for from zero dimensional material like fluorine and one dimensional material like carbon nanotube and nanofibers, and then two dimensional material like graphene, MZ like that, and three-dimensional materials are like that. And the polymers ranges from the thermoplastic, thermoset, and the elastomeric material too. And it find the various applications. So my work based on the sensor application. So what is sensor? Actually, it can the device which can detect and response to the various stimuli from the physical phenomena. Like let's say the physical phenomena may be light, heat, or maybe a temperature, pressure, or any other environmental phenomena. So, like for a few example, you can say like temperature probe or force sensor and pressure sensor. Maybe you can say ECG sensor. It's also the sensor. And my work actually based on the non-tactile sensing. What if mean by non-tactile sensor, which can detect when it in non-contact, which is not directly contact. So let's say the example like our skin, it can detect when not in direct, if the sun rays come from far, so you can sense the heat from the distance. So normally available the traditional sensor, you have a lot of drawbacks. You can say that wearing discomfort and high stiffness, which is not required for our future generation. Then we'll go for the flexible sensor, which having the lightweight material is having higher signal ratio. So we opt for the flexible sensor. Finally, our work actually I chosen the material liquid elastomer based material. It's like isoprene rubber. It has the molecular weight of less than 28,000, and the nanofiller like I have chosen for the multi-wall carbon nanotube. So initially, what we studied, like actually for my study, I have compared the crosslink property and also without crosslink density, crosslink material. Initially, we have studied the curing property by using the dichromacyl peroxide. The initial study was conducted for that various temperature. Here you can say 170, 180, 190. So once you're going higher temperature, you can say that the building of the storage model is getting decreased due to the termination happening, but you can say that curing time getting decreased. So here we can off the 170 degrees as final because it's storage modulus are higher because of higher clustering formation. For the another study, we have fixed the 170 temperature and we have varied the DCP content. For our study, we have chosen the 5% DCP was good enough for our study because higher DCP from the rigid structure, which is not inconvenient for our study. The chosen 4 pHz DCP, which give the clustering time of 26 minutes. So this is a fabrication for our sensor work. First, we mix the LIR and the carbon nanotube with DCP, and then which actually the planetary centrifugal mixer was used for our study, which give the 45 degree of planetary centrifugal mixing action, which gives the three-dimensional flow, which will help for the well dispersed carbon nanotube inside the matrix. And then we go for the stencil printing technique, which is lab made simple technique, also scalable for the industry. And we have used for printed the sensor and for measuring the electrical property, and we have made the silver line over two edge of the sensor. And then after that, we have encapsulated with silicone rubber. After that, we have put the copper wire for connecting the source meter. So as I told earlier, we have comparing the cross-link density of, cross-link material and so on cross-link material. So when you are mixing the conductive filler inside the insulating matrix, so it's from the percolation network, which from converting the insulating to the electrically conductive. So you want to know the what exact weight percentage which percolating, which is from insulating to conductive material. So you have varied the different volume fraction of the CNT content. Here you can say the if you increase from the volume fraction of 0.006 and from 0.01, increasing the conductivity you can see, which can be plotted using the classical percolation theory. We have found for the unclustering sample having the percolation network at 0.001, which is the very ultra low concentration we have obtained from our study. For the crossing, we have obtained the percolation network at 0.03, which is little higher than the uncrossing sample, because the crossing sample introduced little accumulation of the nanotube, which actually hindered the long range nanotube, which having also we have known that the electrical percolation conductivity, which is higher in the uncrossing sample compared to the crosslink sample, due to the it hindered the long range nanotube network by introduction of crosslink. And also we have obtained that what dimensionality of material which is forming inside the matrix. Yeah, we are using, if you plot it using log conductivity versus the log 5 minus pi c, if you value your t value, if you go for after 1.6, which having a 3-dimensional network, so both are obey this 3-dimensional network. So our sensor actually we have intended to use for the measuring the temperature. It is better to know the what sensitivity actually it is producing. So for that we have measured that sensitivity by measuring the resistance by increasing a temperature in range between the 30 to 50, because our body temperature around 37, which should be lies in our sensitivity. So here you can see once you increase the temperature, actually the relative resistance getting decreased, which showing the negative temperature coefficient for the unclustering sample. So what mechanism actually it is follow? So we have to plot by ln of conductivity by root t divided by t minus 1 by 4. So it should form a linear range. You can see here linear. It's obey the VRH mechanism, which is variable range hopping mechanism. The other mechanism will be tunneling, but it is not here for our study. It's only VRH mechanism because it is following the linear trend. Also, so whatever you are producing the sensor, each form should be the cyclic study should be better, because whenever you use for repeatability, you should have like a proper measurement whenever you use at first time. Here you can see like for unclustering sample, there is a basic decreasing the trend line, which is not at like it's not going back at initial resistance what we measured at first cycle, which is due to the actually permanent network deformation happened due to the uncrossing network. And also we have checked the sensitivity like uncrossing sample. We have measured for the crosslink sample. This is also obeying the negative temperature coefficient. And also same for the variable range hopping mechanism. Also it's follow for the crosslink sample. For unless like in uncrossing sample, the crosslink sample shows the better stability for thermal cyclability, because so unless in here you can say the basic decreasing the trend line for all the volume fraction of the filler, but the crosslink sample shows the better stability. At volume fraction of 0.006, it started forming a very good stability for the reproducibility. So we have chosen the final for the thermal characterization at volume fraction of 0.006, which is very low concentration we have obtained from whatever previously they have done in other research work. And also we have taken the 0.006 volume fraction of the sample And you have checked for the multiple cycle up to 35 cycle. You can say there is no decrease in the trend line. There is also forming a very good stability for the day-to-day usage. And also we have checked the current voltage plot at different temperature. You can say once the it's forming the linear trend, which is ohmic characteristics, it is obeying that. And also if you increasing temperature, you can say the current flow getting increases. So other characterization we have done for the thermal dynamic temperature stability, you can say we have increased the temperature from 30 to 55 at regular interval of increasing 5 degree. So you can show the once it's a temperature decrease, the relative resistance decrease. So once this is a baseline, but which is not increasing the temperature. It's from the stable relative resistance. Once the temperature increase, the relative resistance decrease. It's from the dynamic stability of our sensor. Here, so we have used for the non-tactile sensing, we have used the hot air gun. We have blown the hot air gun from the distance of 30 centimeter above. So here we have not blown the hot air gun. It's at the room temperature of 33.1. There is no relative resistance decreasing. So once you start blowing the hot air, you started seeing it decreasing the relative resistance. So it can measure it is not in current contact. So we have want to ensure that is not uh, due to the pressure is happening. And so we have blown with the blower, not hot air, is normal air. So you can see there is no relative resistance changes. Not due, we have confirmed it is not like pressure due to the pressure. So we are finding application not non tactile sensing. So what we did is like we have fixed the temperature sensor, and we have brought the hot water nearly 60-degree hot water container which have hot water. So we fix around 5 mm at the distance, which is not in direct contact. So here you can say like there will be no relative resistance changes here. So once you brought the hot water container near to here, the relative resistance start getting decreased. Also, we are finding like when you bring the finger near to the sensor, here there is no change in the relative resistance when it not brought the finger near to it. So once you started here placing the finger over it nearly 5 mm above it, the sensor, the relative resistance is started decreasing due to the thermal exchange between the human body and the normal temperature. So one can say that actually it is not due to the humidity, your sensor get also obey that relative resistance changes. So we have put the encapsulant, the silicon rubber. So it's actually having a better humidity stability over here. So we have checked from relative humidity from 45 to 100, but here you can see better stability. There will be no decreasing in the resistance. So what we did, we have applied this for a human healthcare application. We have checked with, we have attached the sensor on the mask. So once the normal breathing, actually, you can sense by your hand. So once you exhale hot air. So once you inhale, you actually inhale the cold air from the room temperature. So since our sensor is like monitoring the temperatures in non-contact mode, so we have attached the sensor on the mask. So once you exhale, less temperature started decreases. So when you inhale, it started going above. So for the normal breathing, we have obtained 15 breath per minute. Also the fast breathing like 72, which is in normal. You can see the thermal image. It is due. Here is the sensor. The temperature is 31 for the inhalation. Once you start exhaling, that sensor actually detecting the temperature. You can see the difference in both. I'm concluding for my research work, and I was chosen for LIR as a matrix, and the carbon nanotube as a model filler, and we have cured using the DCP. And we have checked the performance for the uncrossling and the crossling rubber also. We have obtained very good thermal stability in terms of crossling rubber. So we have applied for the non-tactile sensing application for various scenario like hot water and the human mask. Thank you.
So any questions?
Short question, so that you can use for problem.
What is the temperature used for crossing bridge?
We have chosen the 170-degree.
Why did you go for parachute?
Actually, sulfur curing we can use for our sensor. We don't want other fillers in it, like accelerator. You need accelerator, these things. So we don't want to do that. It's simple crossing. So
Inside scientist. So why?
which one? We encapsulated using silicon. Yeah, because we can say we have tested. Actually, we want to have a cross interference one, because once you breathing, you will also the resistance changes with the humidity and the temperature as well. So once you encapsulate it, so humidity, the response will be neglected. As other processing difficulties there, it is not compatible like carbon nanotube in natural rubber, liquid isoprene, because it is not a normal rubber we are using. It's a liquid elastomer. That is why we are able to achieve the very ultra low volume fraction, 0.006 percolation network, percolation threshold value.
Okay.
PDF আছে তো দেখুন পিডিএফটা দাও শুনবি একবার দেখো এটা করে চেঞ্জ চেঞ্জ হয়েছে এটা দিয়ে হতো এটা এটা দিয়ে হচ্ছে না আচ্ছা
So our next speaker is Polash Dash from IIT KGP.
Thank you. So, good afternoon. Good afternoon, everyone. So, good afternoon, everyone, and myself Palas, and the topic of my presentation is self-filling and recyclable 2D MXN based elastomeric composite for microwave radiation absorbing. So I did this work under the joint supervision of Professor Narayan Chandra Das and Professor Kingsley Musto. Hello. So these are my content of my this work. So in introduction, so while today is a day of electronic information, so while enjoying the electronic information like artificial intelligence, etc., So we are also facing a new threat, that is electromagnetic interference. So what is electromagnetic interference? So electromagnetic interference can be created in any electrical instrument or any. So for that reduce electrical interference, we need shielding. So for the shielding purpose, we did this work. So these are different EMI shielding material, like people are 40 to 50 years people are using metals and alloy. And nowadays people are going to prepare the conductive polymer composite. So these are some application of the EMI shielding material, like to protect human health as well as in radar application, space application, people are using EMI shielding materials. So why we are going to self-healing EMI shielding material? Because any product during their use, it get cracked and it lost its usefulness. That's why we need a self-healing EMI shielding material. So self-healing EMI shielding composite are synthetically prepared any elastomeric composite that have the ability to repair the damage itself. And this self-healing EMI shielding material are invented in the year of 1980s, and these self-healing materials has been performed in our biological system. And self-healing EMI shielding materials are classified into two broad interaction, like one is non-covalent interaction and another one is dynamic covalent interaction. And we are focusing on dynamic covalent interaction and specifically metal to together coordination bond. And the number of report from self-healing EMI shielding material are increasing day by day. So these are some applications of conductive self-healing material like supercapacitor, solar cell, adhesive, electronic skin, etc. And for our case, we are using carboxylated nitrile rubber. So carboxylated nitrile rubber has special properties, like it has good abrasion resistance property, and with the incorporation of carboxylic group, it gives extra cross-linking site. So these are my objective of my research work. So objective is that to identify a suitable nanoparticle which will give good conductivity while retaining other multifunctional properties like self-healing ability, recyclability, etc. And these are my some of material that I use for my work, carboxylated nitrile rubber, and for the conductive part, we're using MAX to prepare the emerging filler, that is new generation filler, that is MXN. So these are my some characteristic techniques for my work, from mechanical properties to DC electrical conductivity and EMI shielding. For EMI shielding, we are using vector network analyzer. So in my sample preparation part, we are first to XNBF, and then we are drafting 1,3-aminopropyl imidazole, that is API. So a phase amide linkage has been formed, and then we are using metal oxide to prepare the metal to ligand coordination bond into the elastomer chain, which gives the self-healing ability to the material and gives recyclability also. And we are using two-step sequential solution cum melt mixing technique to prepare this composites. And these are some efficient events. So at lower filler loading, MXN are separated from each other. So it didn't create any pathwork or linkage for the DC for the conductivity. But at higher loading, it's connected and it created an infinite network inside the elastomer phase, which gives the DC conductivity and electrical conductivity to the composites. So now we do the mechanical property. So as we are using polymer, so polymer composite has very light. So the lightweight we are keep the sample into a flower, and for the mechanical properties, the tensile strength increases with increasing the filler loading, but it is not increasing up to the mark because at higher filler loading, filler interaction happening. So it is not, and the elongation of the leg is decreasing with increasing the filler loading, and the modulus of the material is increasing.
So these are the optical image as well as the AFM depth value image. So which prove the self-heating ability of the material. And these are some the real life experience of the composite. So after healing more than 95% detection of EMI effectiveness and exposure to sunlight as well as after bending as well as some chemical detergent treatment. So the retention of EMI sealing effectiveness is more than 90%. And we also did the recyclability test. First, we cut the sample into small pieces, then remolded, so we can use more than 5 to 10 times. One sample we can use more than 5 to 10 times. So in conclusion, we fabricated the MXN-based elastomeric composite for EMI sealing effectiveness, and EMI sealing effectiveness was reached to 27.2 dB at just 1 mm thickness, and minor variation of was observed after prolonged healing effect and environmental effect. And this composite gives very good electrical conductivity as well as thermal conductivity while maintaining the other multifunctional properties. Thank you.
So any questions?
Yeah. This material that you have developed, we have suggested for recommended for microwave.
Yeah.
So what frequency it can work? Like is it work for radar frequency like a K, 2, what is there?
Yeah, this is working in X band, that is
You'll be working in X.
X band 8.2 to 12.4 gigahertz.
Is it possible to tune that your material to various frequencies?
Yeah, yeah.
Which is a changes that you just to tune the multiple frequencies. Because if I want a broad frequency
Yeah.
to cover the various frequencies, so how to do that?
The thing is that for any EMI sealing material, the first factor will be it should be electrically conductive in nature. If it is electrically conductive, so you can use up to into K band. If the conductivity reaches up to into 10 to the power minus 2 Siemens per centimeter, like 0.01 Siemens per centimeter, you can go up to K band, KU band. At lower band, it will work at higher band, but in terahertz band, it is not working.
Change the conductivity value. That also is possible to tune the component.
Yeah.
That also you can study.
Yeah.
The effect of Willis on permittivity
Yeah.
or dielectric constant of the
We are also working to add some magnetic nanoparticle, yeah, which will increase the permittivity also. Yeah, permittivity. Thank you.
Any questions? Okay, then Dr. Rono Bush, will just come and send over. Oh, back back forward.
So once again, IIT Kharagpur, Romita Hor, please.
Good afternoon, everyone. Myself, Romita Ho. I'm a Prime Minister Research Scholar from Rubber Technology Center at Kharagpur. The topic of my today's presentation is sustainable approach of using waste materials for the fabrication of rubber-based vibration control system for electric vehicles. If you are here for something which is written in the program agenda, which is vehicle control system for electric vehicles, certainly it is not. But I wish I could design a vehicle control system because, when I was coming here today, I was stuck in the traffic for around 2 hours. Yeah, and in the 24 hours of span of our life, per day, it is span of our life, 8 hours sleep, 8 hour work, and remaining 8 hours, if we spend 2 hours or 3 hours in traffic, I wish I could develop a vehicle control system. Anyway, my counterparts. This work actually has been done in joint solution of Professor Shankar Chakrabarty and Professor Paul Banerjee. And this is the content of my previous presentation. I'll start with a brief introduction, followed by formulation, and the materials I have used and then methodology, followed by characterization, and my conclusion remarks. So, what is a vibration control system? It is something which is responding towards the vibration. And how it is responding? There are basically two specific ways, right? One is vibration isolation, another is vibration damping. So, vibration isolation is actually associates with the elastic property of the material, whereas the vibration damping associates with the viscous property or viscous component of the material. That's why while we are choosing a vibration control system as a package, we tend to use viscoelasticity so that we can have both in our bag, right? So from this graph, which is at the left, you can see the transmissibility versus frequency curve that I have pointed three zones. The zone 1, where the natural frequency and the excitation frequency actually becomes the same, the amplification is occurring. Right. At the zone 2, which is the critical frequency zone, and beyond which the zone 3, that is the region of isolation starts. So the particular damping, that damping part is actually operating at the zone of amplification. How much damping we can provide, that is operating in the zone 1, where at the zone 3, the isolation operation happens. Now, it is already established that natural rubber as a matrix for vibration control system, but the thing is, generally these are carbonaceous filler, like quite a high dosage of carbonaceous filler has been incorporated in this type of vibration control system. So my aim is to reduce the carbon footprint as much as possible. And if we are talking about the reduction of carbon footprint, why not using some waste materials which already contains a few amount of carbon in it? So two ways. One is reduction of carbon footprint, another is a waste utilization. Both we can actually work with. So what we have done is we have collected the waste filler. Here we have taken basically the cream of slag, and we have done mechanical grinding followed by sealing so that we can have a particular range size as a filler. And here I have shown very general what we generally do for mixing, that we start with the internal mixer, At a certain temperature, I have used here around 145 degrees centigrade temperature for mixing the fillers with the rubber along with other additives, definitely not the curatives. The curative mixing has been done thoroughly, followed by checking the TC90 value, which is the optimum cure time, and then we have done the compression molding, and then we went for sample characterization. So here we have used basically two types of filler. One is carbon black, another is the waste black. The images here, or rather, I should say, the micrographs here, pointed as A and B. These two are of carbon black. You can see from the partial size distribution at the designated as E. The carbon black is having size quite low, around 100 nanometer, whereas in case of slag, which is designated as C and D, and particle size distribution is designated as F, the average particle size is in the micron range. So it's basically a combination of nanofiller and microfiller. So this is the typical formulation we have used. I have represented here only these three. Other optimization has been done, but only for the time constraints, I have only shown the major three. So the two extremities, 30 pHr maximum dosage we have used for carbon black, and another extremity is 30 pHr of SAC. And particular combination that is for black and carbon black we have taken. Now, if we see the curing properties over here, you can see with the increase in slag content, the optimum cure time or the score-safety value is not that much affected, right? But the delta dot is getting decreased. So there is an impact in the curate index definitely. And if we see the mechanical property, it is quite hidden here. But if we see the mechanical property, there is no such drastic change when we are using the 50-50 blend of carbon black and black. The interesting property over here is that the mechanical histories we performed to establish the damping property of the composite. What we have done is we have capital this mechanical hysteresis and 300% elongation for 15 cycles with a test speed of 500 mm per minute. And then we have plotted the data and calculated the area in between the forest and the field view, and we have found that the C3, which is the 50-50 combination of slag and carbon black, is actually giving us the highest value, the highest area above. So we can say that yes, the C3 combination is actually providing us better damping property. The last thing I was thinking was majorly of static mechanical property. Now coming to the dynamic mechanical property, we have done amplitude speed and ranges from 0.001 to 100% strain. Here, this okay, at the top left corner of yours. And this is the strain data you can see, and from this data we have got the strain effect. You can see that it is a difference between the this value on the lowest the storage modulus as the lowest strain, and the value of the storage modulus at higher strain. That is the difference we have calculated here and I plotted this. And you can see the value of pain effect is actually decreasing for the C3 combination. That means it is indirectly proving when you have a filler combination where nano and micro filler is working together, it it is actually providing you better polymer filler interaction. We have also done frequency and we have covered the frequency range of from 0 Hz to 100 Hz, you can see, and I have plotted the storage module as data from here. You can see a higher frequency range as we are approaching towards the 100 Hz. Almost they are giving similar type of property there, merging at this point, but when it is the lower frequency range, the combination again the P3, which is the combination of the 50-50 like the ratio of slag and carbon, that it is giving like a better property. Another interesting study that we have done is the ITC or interval isotropy test. This test I'm talking about, it is actually a test where we have varied the shear rate. We are actually working with two different shear rates. One is the lowest shear rate, that is 0.5, and the highest shear rate of 10. Okay, and we are applying the shear rate at 30 seconds of interval. So total span is 250 seconds, 5 intervals. As you can see here, for C3, the structural regeneration is way better than this C1 and C2, which are the two control compounds. So again, when this carbon black and slag operates together, they're actually providing better structural regeneration and structural recovery. So these are the surface morphology of all the composites. You can see where there is only carbon black, there are a lot of aggregation. Definitely the filler, the carbon black, they when they are alone together, they love to be with each other. So they have formed good amount of aggregation here. And when this B, which is the C2, which is having only black, and C3, where you can see the particles distributed quite well. So from here, it is a very much primary type of optimization. So from this primary type of optimization, we can conclude that with the three bases like interval isotropy test, which is a structural recovery test, next is the hysteresis data, which is for the damping test, and third, based on the polymer filler interaction that has been again polymer interaction that has already been established by showing the surface morphology as well as the P method. So we can say that we have achieved 50% substitution of carbon black in this type of system, and black can be used as a like additional filler with carbon black, and it can substitute carbon black to the extent of 15%. So these are a few of my patent and publications. Thank you so much for your attention.
Any quick question? Yeah, I have a question. So you are developing this vibration isolator, rubber isolator, not a rubber dam.
Yes, I'm trying to develop something which could have a combination of isolated and damper. That's why I've named it as vibration control system of the isolated vertical wire.
Then what is the type of carbon black that you are using for
For this optimization, I have used N770, that is a semi-reinforcing coating.
Right. What I am asking is we should not go for high surface area carbon black.
Yes, sir. Yes, sir.
You want to have a more tan delta value and damping value in addition to that isolation property. So you have to use better thermal block even compared to SRF. You use the thermal block in combination with the nano. That will be working good.
That N900.
Yes, N900 you use it. You will have. Then one more thing, as it is finally you are going to suggest for vibration isolation. So this you have to do the transmission details.
Yes, sir.
That is the most important. Okay.
Yes.
So you talk about vibration isolation or damping. Transmissibility, that's a frequency, will give you direct idea about where you are going to do the frequency. That will you will get more idea. Okay, otherwise it's a very good presentation. Thank you.
Yes.
So I have a question. So the slag is a protein gamma material. It's not the last models which will are processes.
Yes.
So how you could interact with the non-polar analysis?
Yes, okay. I am very clear. Actually, we have done the X-ray photon spectroscopy of slag material, the slag sample. So we have found the activity concentration here, and we have found there a significant amount of it is what it is, it's a hybrid composition. Slag is having hybrid composition. Okay. So it has a significant amount of carbon as well as silica. As you know that the carbon chemistry and the silica chemistry is already in balance with rubber. So that's why I selected slag.
Tolerance.
Thank you.
So may I ask Dr. Kanika to present? Yes. So our next speaker is Aparna Buchai from RTC, ITHP. Just one second.
Good afternoon, everyone. I am Aparna Buchai from RTC Rubber Technology Center, IIT Kharagpur, and I am going to deliver a few of my PhD work in this great forum. The name of the project is Functionalized Epoxide Natural Rubber for Flexible Electronic Application. This is my today's agenda. I will briefly talk about the introduction, followed by some experimental work and then conclusion. As we all know, that research in the field of flexible electronics is increasing day by day. So among the various electrical device, sensor is such a device that can sense some physical stimuli like heat or temperature or motion and etc. I have listed few of them over here. Here we are interested in temperature and humidity sensor. As the name suggests, the temperature sensor can sense the change in the temperature and the humidity sensor can sense the humidity around the environment. So the flexible sensors used in the commercially is generally made of inorganic material like silicon, stainless steel, ceramics. But those materials have some disadvantages, like they cannot be formed properly, they are not flexible, and it doesn't have any adhesiveness. So if you want to make wearable electronics, then we need flexible nature and comfort in the material. For these, people are making polymer-based flexible electronics. And for these, commercially available materials are PDMS or PBTF or polyamide, but those materials are not sustainable. They comes from petroleum-based material. So that people also working on sustainable materials like starch, gelatin, cellulose, etc. So being in the rubber technology center, I have selected epoxide natural rubber for my raw material. Why I selected epoxide natural rubber? As you can see that this material has epoxy ring in the main chain. So this oxygen atom is electronegative in nature and the carbon catalyst with the oxygen molecule is prone to nucleophilic addition. So if you want to modify this material, it's a very good candidate for that. And it has several other properties, like it has very good polarity and very good addition. And we can also add fillers or different polymer into the system. So we all know about the conventional applications like in the tire or in the computer plate and so on. But in this field of flexible electronics, this area is not very much explored. So we have explored this. We have modified this material to different molecules, which has some different functionality, so that we can get desired properties. So based on this, we have selected our scope and objective. First, we grab the material from sustainable resources, then we modify it using some modifier, following some very easy steps, and then finally we made flexible electronics out of it. For this, we have used different modifier. One is Jeffermin M2070 and another one is gallic acid. So in the first one, what I have done is we have modified ENR50 with polyethylamine, and where the long chain is contained, you can see from the graph that long chain having ethyl group, and we have modified it in presence of PEA as a catalyst and reacted at temperature of 80 centigrade for 24 hours, and we used different equivalent weight ratio. One is 0.5 and one is 1, and used solvent as solvent. And the modified material used in the conventional adhesive formulation, and you can see from the first formulation we have used ENR50, and for the next two we have replaced the ENR50 with the modified one. So we have characterized thoroughly in terms of spectroscopic analysis to determine how much grafting we have achieved. And from the FTR and the NMR, we have achieved that 88% of grafting we achieved from 0.5% of, one equivalent weight of PEA. So here you can see that the peak at 873 is decreasing the increasing amount of PEA, which can indicate that with the increasing of polyethylamine, the epoxy ring is decreasing. So we also have characterized this material in terms of thermal analysis. We can clearly see the change in the PG. We also have done frequencies with taste and many other rheological analysis. I am not going into the detail to characterize how the material is working. So the modifier is hydrophilic in nature, so that the hydrophilic property is increasing after the modification, which was determined by the water absorption study and water vapor uptake study. You can see clearly that this is increasing after the modification. It also characterized by contact angle measurement, and we also have carried out the adhesive property that you can see that increase in the tag property and also in the pin strength. So finally, the humidity sensor. This modifier is hydrophilic in nature, so it can absorb a lot of water molecule into it. So for that, if we change with the change in the relative humidity, you can see the current increases exponentially. That's a basic testing for humidity sensor. If this material can be used for monitoring the breathing pattern of a human body. So in the lead scheme, we have modified epoxy natural rubber with gallic acid. The act of the gallic acid reacted with the epoxy ring via the ring opening reaction, and at the temperature of 60 dB for 12 hours in presence of THS solvent. Now we have processing this material with ATCL3, and here two types of reactions are forming. One is reacting with the epoxy ring, and another one is reacting with the modified gallic acid that phenolic OH group is forming metal-ligand coordination bond with Ag3+. So in the conventional curing system, the temperature needed is 150 to 170 centigrade. But here we have cured it at room temperature sensor. Sorry, room temperature like in 30 to 35 degree temperature. So we characterized the material in terms of spectroscopic analysis, UV analysis, and X-ray analysis. All these experiments prove that the material is successfully modified. We have also studied the thermal property and contact angle measurement, which is also doing the same thing. So these are some characterization that the successful metal-ligand bond is formed in terms of FTIR and X-ray analysis. So mechanical property, we have seen that with the increasing amount of HCl, the mechanical property is increasing. So processing density is also increasing when we increase the HCl content from 0.022 to 0.15. And we have also changed the self-healing property, and we have gained almost 80 to 50% of recovery for 0.02% of APCL3. And we were making emphasis, we use CNT for the conductive as a conductive filler. And here you can see the when we change the temperature from 30 degree to 50 degree centigrade, the relative resistance is decreasing, which is indicating a negative TCR value, like temperature coefficient resistance. And we have conducted the same for 5 consecutive cycles, and the data is showing very repeatable data. So from the next graph, we are getting a linear nature which represents the hopping mechanism of the temperature sensor. And if you want to know about more about this work is presented. This reference is given here. So finally, conclusion, we have shown a different way of making ENR in the flexible electronic sensor. We have modified two ENR with two different molecules and have explored in these two different sensors. So here I would like to thank both of my professor, Professor Shantanu Sarkopata and Dr. Kitan Mullah for guiding me. And I also want to thank my center, CRA, and IIT Kharagpur, and also I want to thank Technobees for giving me this opportunity. And finally, but not the least, I want to thank my family and friends for their support. Thank you. Thank you for coming.
Why you will choose gallic acid for grafting and then for the DNA?
Gallic acid is having one acid group, and that it can react with epoxidine. That's why, and it has a phenolic weight like catechol like rather pyrophenotype type structure which can undergo create coordination bonding with metal.
Yes, that's very against catechol type structure. Also, some little toxicity is there for gallic acid. Not why not tannic acid or some other.
Tannic acid structure is very weak actually.
Yes, but
yeah, it's very weak actually, and it is very difficult to directly, and it is a solvent-based system. So if very large amount, very big size tannic acid is used, actually in some cases it can be used, but not in the solution mixing. What?
The staining against something higher in case of gallic acid.
No. Tannic acid doesn't have any reacting group like yes it has, but for like
due to the higher sustainability.
tannic acid doesn't have any free acid group in this. It has pyrovalency group outside. So for reacting, I am trying to react epoxy ring with acid group. That's why I have. And if you want to react epoxy group with phenolic OH group, then the temperature needed is 150 to 160. Higher temperature is needed for epoxy and phenolic OH reaction. Higher temperature is needed. Here I have used very low temperature for the reaction, and the reactivity of the acid group is higher than the phenolic OH.
You studied with hydroxyquinone?
No, I have not tried.
Why?
Why?
On the way back, you can ask 100 questions. Why can't? Next step. Okay.
I have just one short query. How you recover the solid from the system?
We simply first we purify the material. Recovery means we have purified the material in ethanol, and we get that material in the precipitate form and dry. Then simply wash and dry.
We are using solution mixing, no?
Solution reaction. I have done the reaction in the solution, and then I purify the material, and then the solid material I use.
Any other questions? May I ask? Dr. Rita? They want to see this. Yes, that's right. Yeah.
So over to you, our another speaker, Barkat Aziz from IIT KGP.
Good afternoon, everyone. Myself, Barkat Aziz, doing PhD under Professor Kinshuk Naskar at Rubber Technology Center, IIT Kharagpur. The topic of today's presentation is cross-linking of bio-based elastomers, method and sustainability. And the content of the presentation contains, as usual, introduction to conclusions. Let's start the introduction part. The economy has crucial role in our climate change, and in order to achieve sustainable future, we have to shift from linear economy to circular economy, because the main theme of linear economy is take, make, and dispose, while the main theme of circular economy is make, use, and recycle. In brief, the linear economy is mainly focuses only profitability, while the circular economy focuses the renewability and sustainability. Now, if we look into the current scenario of the rubber technology, we will observe that except natural rubber, all rubbers are petroleum based, which is obviously not a sustainable source, and most reinforcing fillers derived from fossil fuels, leading to increased carbon footprint. And most importantly, the cross-linking network between the rubber chains, which is covalent, and hence it is very much difficult to recycle. Now, in order to achieve the circular economy in true sense in the rubber product, we must replace the petroleum-based raw material to bio-based raw material, and at the same time, we have to replace the non-recyclable cross-linking system by recyclable cross-linking system. Only after that, we can achieve the circular economy in the final end product of the rubber technology. Now, in this particular research work, keeping the circular economy in our mind, we have chosen the bio-based EPDM rubber, which is the special grade of EPDM where the ethylene content came from the fermentation of sugarcane followed by the acid hydrolysis. While in case of conventional EPDM rubber, the ethylene content came from the crude oil. Now, if we only replace the ethylene content by bio-based source, we can achieve in the end product from 20 to 60% bio content, while in case of conventional EPDM rubber, it is absolutely 0%. So the benefits of the bio-based EPDM rubber over the conventional EPDM rubber is that it reduces dependency on the fossil resources as well as the reduces carbon footprint, and at the same time it is truly sustainable as validated by life cycle assessment, and it do not compromise with the quality as compared to the conventional EPDM rubber. Now come to the cross-linking systems in the rubber technology, in the rubber products. Basically, the covalent cross-linking system like sulfur cross-linking system, peroxide cross-linking system, and resin curing are used, which can exhibit the excellent mechanical property, but they are insoluble and infusible, and hence they are not recyclable. If we come into the ionic cross-linking system, they can produce the recyclable cross-linking network, but they cannot produce the excellent mechanical property, and they have no solvent registration property. In such a case, we can choose the dynamic covalent cross-linking system, which is the best option to produce the rubber product by which we can produce the smart composite which can exhibit simultaneously self-healing, self-memory, as well as material circularity. In the case of dynamic covalent network, there is also several kind of systems, but for my particular this research work, we have chosen the trans-esterification reaction that I will discuss in later slides. Now come to the motivations. The main motivation for this research work is to utilization of the biomass as a feedstock, followed by the use of Wittimer chemistry to cross-link the system, thereby produce sustainable rubber product which can exhibit renewability, recyclability, as well as biocompatibility. Now we can show the schematically the objective of this research work. The first objective is to epoxidize the bio-based EPDM rubber to produce epoxidized EPDM rubber, followed by the utilization of green cross-linking system. In this case, we have used decandioic acid, which is also came from the bio-based source, to cross-link the epoxidized EPDM rubber. To cross-link the epoxidized EPDM rubber, thereby produce beta hydroxy ester bonded cross-linking network. And ultimately, the understanding of the Wittimer property at high temperature in presence of trans-esterification catalyst. In this case, we have used zinc catalyst. Now come to the experimental part. I have shown here the brief schematics of the epoxidation process. And if we look into the formulation part, we have made 4 formulations by varying the decandioic acid doses from 3 to 12 pHs, which corresponding to 50 mole percentage, 100 mole percentage, 150 mole percentage, and 200 mole percentage relative to the epoxy group present in the epoxidized EPDM rubber. And in case the trans-esterification catalyst zinc acetate varies 20% related to the decandioic acid in each formulations. And I have shown here the experimental characteristics that I have carried out for this particular research work. Now come to the research, come to the result and discussion part. The epoxidation of EPDM rubber has been confirmed by both FTIR and proton NMR spectra. you can see that in case of EPDM rubber, there is a peak at around 808 centimeter inverse corresponding to the carbon-carbon double bond. But if we look into the FTR structure of the epoxidized EPDM rubber, there is an additional peak at around 871 centimeter inverse, which is corresponding to the epoxy ring present in the epoxidized EPDM rubber. And finally, we have calculate the quantitative calculations from the peak integration calculation. We have calculated that more than 75% double bond has been converted to the epoxy ring. Now, if we look into the DSC plot of the epoxidized EPDM rubber and EPDM rubber, it is observed that there is not much variation in the glass transition temperature. This can be explained by the mainly the epoxidation is take place in the pendant groove, and hence it do not affect the restriction of the main chain of the EPDM rubbers. Now, if we look into the comparative DSC plot of the D50 to D200, we can observe that the melting peak corresponding to the free diacid is increasing from the D50 to D200, which suggests that D200 contains the highest amount of the unreacted free acid, while the D50 contains the minimum amount of the unreacted free acid. Now the typical torque versus time plot, we observe that there is a typical cure characteristics for all four samples, but for the D200, they shows the reversion type of phenomena. This is because at high temperature, the unreacted diacid acts as a plasticizing, and in this case, as the unreacted diacid is highest in the D200, this is for this reason that the plasticizing effect predominates over the torque value by the cross-linking, and hence it shows reversion. While in case of D50, since the unreacted diacid is minimum, and hence it shows the highest amount of the delta torque value. The formation of the ester bond is also confirmed by the FTIR analysis. Now come to the mechanical property and cross-link density. It is observed that from the D50 to D200, the tensile property as well as elastic modulus increases. This is because even though at high temperature, the unreacted diacid exhibits the plasticity effect, but at ambient temperatures, it behaves like reinforcing fillers, and this is for these reasons the tensile property and elastic modulus increases. While the cross-link density measurements from the both solvent soiling method and Mooney-Ribling equations observe that in all four cases, the cross-link density for all four samples is almost similar. It suggests that the reaction between the epoxidized EPDM rubber and the diacid is almost in the same molar ratio for all four cases. And to validate the victimeric behavior of this material, we have experimented the stress relaxation experiment, and we are trying to fit this stress relaxation plot by famous Jenner model, which is frequently used to validate this stress relaxation phenomena. And we have observed that for all four samples, the correlation coefficient value is more than 0.9, which shows the quite suitable fitting for the all four samples. But it observed that for D50, the stress relaxation value is higher compared to other three samples, which suggests that at high temperatures, the dimensional stability of the D50 sample is best among the other four samples. And since the dimensional stability of D50 is the best, we have chosen the D50 for the further studies, and we have increased the temperature from from 180 to 190 to 190 to 200, and it is observed that with increasing temperatures, the stress relaxation time reduces, which shows that this particular materials obeys the Arrhenius equations, and the activation energy for the trans-stratification reaction is around 62.7 kilojoule per mole. Usually for the trans-stratification reactions, the activation energy ranges from 30 to 180 kilojoule per moles. And since in this case, the activation energy is 62.7 kilojoule, which is below the range, and hence it is very much practical possibility to produce this type of victimeric materials and trans-stratification reaction. Now come to the recyclability test. From the first recycle and second recycle, it is observed that the recovery ratio in all three cases, like tensile strength, elongation, break, and modulus at 3%, is quite high, and hence we can say that by this technology we can use upcycling of the recycling methods. And from the same images of the for the original D50 first recycle samples and second recycle sample, it is observed that there is not much deviation or cracks in the morphology, and hence we can say that it is easily possible to recycle the materials. Now come to the conclusions. This green curing technology proposes the cross-linking of bio-based EPDM rubber with diacid, which exhibits excellent mechanical property as well as recyclability. And from the physical, mechanical, and stress relaxation test, we can say that all four sample is quite promising for the practical applications. Even though the D50 exhibits the best mechanical and dynamical property, but the excessive diacid loading in the D200 shows the deficiency in the rheological property and stress relaxation property. And after comparing all four samples, it has been observed that D50 is the best in terms of rheological, mechanical, and stress relaxation behavior. And finally, the possibility of generating eco-friendly rubber vulcanizers and victimer-like elastomers is significant through the concept of preparing and reprocessable cross-linking bio-based EPDM rubber using simple stratification reactions. And this all work has been published in the ACS Sustainable Chemistry and Engineering. If you want, you can easily access in online. Thank you. And finally, I want to acknowledge Arlencio for providing me the bio-based elastomers for this research work. Thank you, and thank you IIT Kharagpur, thank you Technoboost, and thank you our beloved Rabat Technology Centers, our lab, ARCT. Thank you. Yes, sir. Yes. What? No, sir. Actually, our concept is to form beta hydroxy bond so that we can re-exchange it at high temperatures. So if we do not convert the double bond to the epoxidation, we cannot form this kind of chemical structure like beta hydroxy structure bond. That's why it is essential to epoxidize this double bond. Yes, this is another step, but we have to chemical modify. Otherwise, this kind of technology, this kind of victimer chemistry, we cannot apply.
So, any more questions?
Okay, because you use EPDM, so I wonder how many percent of the use in your
Diene, it is 4.6 weight percentage. 4.6.
Okay, medium.
Yes, medium, right. Right.
If we use high diene content, we can have more
cross-linking system. Yes.
Try using EPDM with this.
Yes, ma'am. Actually, not we have don't use because the availability of this kind of grade is not still available. It is only Kilton Eco 5470, and other type of rubber I have to then check. But still now we have not check it.
So you want to stick with eco?
Yes, yes.
Because of this.
Actually, our intention is to avoid the fossil fuels from the raw material also, and also the recyclability of the cross-linking system. That's why we take these two combinations.
Yeah, one more question about the stability of this cross-link.
What?
The stability of the cross-link? Okay.
Yes, yes.
Please, we it can be recycled, but in terms of stability at different temperature, what can we expect from this kind of cross-link?
Stability, it is you can it is from the covalent network, so it is stable even up to 200 degrees centigrade. The crosslink structure, crosslink form bond. But it is only exchange. It is only exchange in presence of trans-substitution catalyst. There is a no bond breakage at all. Always the crosslink network, crosslink density will be remain constant. If one bond is break, another bond will form. Okay.
We studied our EGA.
Okay.
So I have one question.
Okay.
So can we change the catalyst
Yes.
to achieve the
Yes.
giving properties?
Yes, yes. There is also in literature there is so much catalyst, trans-distribution catalyst. You can use it.
So can we use similar theories?
Of course, there is also literature. There is also some paper.
And he offered a couple of classes.
Mm-hmm.
I get this.
So can I ask?
What? I should not be it. I mean, it's quite there.
Yeah, you're asking us to do it. All the best. Let's go.
So our next speaker from IIT-KGP, Shongit Paul.
Thank you. Good evening to all of you. Myself Sangeet Paul, and today I'm going to present my one of the short chapter of my PhD thesis, that is recycling of waste tire through supercritical fluid assisted development process to promote circular economy. Dr. Ronak has already given some talk on this topic, and here I have used little different techniques that I'm going to present. This work has been funded by the Government of India, Imprint 2 project, and this is waste to wealth topic. Now the global tire production and production is all we know that it is increasing due to the higher number of automobile vehicles, and this is the global study And now this is the Indian context that we all know that the India has got the third in world automobile sector, and it is expected that in coming years the number of tire production will also increase. So the from rubber waste, that is the 63% coming from the automobile sector, and this is one image in Kuwait, from the satellite also it can be seen, and we can see that the volume of the waste tires. Here is the life cycle of the tire, and this is the now using OS tires in various sectors, where we are using the OS tire in road application, in OS in rail track, and some sidewall, river sidewall. So circular economy is the concept that is from linear to from open chain to closed chain, that already has been talked by few speakers, and so we have to close the loop and this is the closing loop. Now, sorry. This is the emerging practice in waste recycling, waste recycling management, and we from incorporation of from the all stakeholders. It's important to manage the waste properly. Here is a biodiversity chart here, where the most important thing is the reduced consumption, but it is not possible just because the now the world population is around 7 billion, and it is expected that in 2050 it will come around 9 billion. So we can expect that reduced consumption is not possible, but it is possible to produce all the products sustainably, and then using this product and recycle them in open manner. Here is the in one mapping that is possible tire disposal and recycling pathways depending on the material circularity. That is, landfilling has the least material circularity, where the devulcanization and has the most circularity in waste tire recycling. My thesis actually comparison of this process, recycling process, that is pyrolysis and thermochemical recycling. But here I am going to present the thermochemical devulcanization method. The thermochemical devulcanization method we are using supercritical CO2. In supercritical CO2, the waste tires, mainly fuel, and introducing this devulcanizing agent, diphenyl disulfide and other standard devulcanizing agent, we can break this mono di or trisulfide bonds in the vulcanized tires. And here is the instrument diagram where we have used, and this is the instrument that we are using in our lab for the devulcanization study. And we applied the DOE technique for this process optimization. And here we have taken the pump pressure extractor temperature, holding time in the extractor, circulation time of the CO2 and DD concentration, and for the as a input variables, where the response variable has been taken that the salt content, cross-link density and sulfur concentration. We use the Taguchi DOE run table L16, and according to the run table, we have run the experiment on the in our equipment, and we got the result, and we have listed here the experimental result. Depending on that, so we have then we done the calculation part. From here we get that the DD concentration has the most impact on the devulcanization of waste stars, followed by pressure. And similar way, also we check the input variable effect of input variables on the cross-link density. Here also we got the DD concentration has the most, and it is rank 1, and the pump pressure followed pump pressure is the second most important process variables. But for sulfur concentration, we got that the DD concentration has the most important process variables, but the holding time inside the extractor is the second most important process variables. For the process optimization, and we use the DR method, and it is from calculating from MRPI value. We got the main effect plot, and here we got that DD concentration is the most important process variables, and pump pressure is the second most process variables. And then we conduct the experiment on the we conduct the experiment on the our estimated value, and then we got that the devulcanization efficiency of around 45% and in our system. And we also use this devulcanized rubber for revulcanization, and this is the cure curve at 160 degrees centigrade temperature, and it is possible to cure in conventional sulfur accelerated curing system. And we got that the tensile strength is also increasing. So it is the in our in laboratory scale, we have not yet published this paper. Also, we have tested this application, and in conclusion, that devulcanizing agent concentration and pump pressure are the most influencing process parameters, and pump pressure of 350 bar, extractor temperature of 80 degrees centigrade, and holding time 30 minutes and 120 minutes circulation time has the optimal process parameters, and 45.25% devulcanization achieved at optimized process conditions, and response variables lies between error of 10%. So it is we can say that our model is quite acceptable. And one point is that the optimum condition was obtained at the top level, and the fixed cost and the operational cost will rise considerably for the higher degree of devulcanization. Means if we go beyond beyond the value we have targeted, then it may be possible that the devulcanization percentage of devulcanization may rise, but the fixed cost also rise simultaneously. Thank you.
Any questions? to audiences. Anyone?
Yeah, what is the G1 percentage in your?
You are in the percentage. Percentage is we achieved 45.12%.
Anyone?
Otherwise, it's always okay. You use supercritical carbon dioxide, right?
Yes.
In your work.
Yes.
But if we, I don't know, you may see from the literature, maybe. If we compare by using this medium comparison with other type of system, can we expect a different demonetization efficiency?
Actually, CO2, here I have given that. CO2 has the lowest critical temperature and pressure. So if we go for water and ammonia, that is other supercritical fluids, then the instrument value or the capital investment that will be higher. So that's why we have to choose the minimum critical temperature and critical pressure value, and means in very low, if we want to achieve the devulcanization at low investment, and then we go for the lowest critical, which fluid is giving the critical means lowest value, we should choose that. That's why we are using CO2.
If we compare with, I would say, conventional demonetization, they use other medium.
Extrusion, that there is also one system that is also already talked by Ronak, that mechanochemical. But here we are using thermochemical. We are not using any mechanical force. Thermochemical only. No mechanical force, no shearing or no extrusions.
So can I ask a problem?
So over to our next speaker, Vivek Kumar Yadav from ITKGP. Over to you.
So as the world shift toward the sustainable development, the demand for eco-friendly and biodegradable packaging material is higher than ever before. But how can we protect some perishable items without synthetic material? Good evening, everyone, and sir and ma'am. My name is Vivek Kumar Yadav, and I am doing PhD in IIT Kharagpur. And today my topic is cushion performance of eco-friendly natural rubber latex foam composite with pineapple leaf fiber for impact protection of apple. So as we know that increasing environmental concern over plastic waste have driven the search for sustainable packaging materials. And second is problem with conventional packaging. Nowadays, expanded polyethylene formate is used. And as we already know that these are non-biodegradable and contribute to environmental pollution. And third is innovative composite material and focus on apple protection and sustainable and impact. And a research problem. The problem is mainly why we do this type of research. So first, I already told you that because of the environmental impact of current packaging, and second is underutilization of natural resources. As we already know that some natural fibers like pineapple leaf fibers, banana fibers, cotton fibers and hemp fibers have high amount of cellulose content and very low amount of lignin content. So we can directly use these fibers into packaging materials. And a lack of eco-friendly solution and need for comprehensive evaluation. And my objective is evaluate question performance. We used natural rubber latex foam net with the help of pineapple leaf fiber. So the cushion performance is very important for that. So that's why evaluation of cushion performance is important. And second is optimize material composition. And how to optimize material composition? So optimal ratio of natural rubber latex and to pineapple leaf fiber is important for that. And compare with conventional packaging, access mechanical property, and explore sustainability benefits and develop. So let's talk to the methodology. So many pineapple leaf fiber is already used in packaging in material. So how can we use pineapple leaf fiber in packaging material? So first we wash the pineapple leaf fiber and then converted into and then dried. And then this dried pineapple leaf fiber into converted into powder form with the crusher machine. And we already know that pineapple leaf fiber have approximate 85% of cellulose content and very low amount of lignin content, about approximate 6 to 7% of lignin content. So we directly use this pineapple leaf fiber into packaging material. There's no need for alkali treatment. And if you want to remove the lignin content, then 4 to 5% of NVS treatment is sufficient for that. And figure A shows the pineapple leaf fiber appearance, and figure B shows the same image of pineapple leaf fiber with the irregular shape and sizes. And then preparation of rapid silicon mold. So with the help of a SolidWorks program, we created a 3D model of foam net, which is shown in figure A. And in figure B, a CAD file is generated, and this CAD file is converted into G code with the help of Slicer. And figure C is 3D printer, and then silicone rubber and hardener were mixed before pouring into the inverted mold. And I want to told you one thing that PLA filament is used for the inverted mold. So, and figure 2D and 2E is the inverted mold and silicone mold. And then results and discussion. Natural rubber latex foam net with the help of pineapple leaf fiber we used, and only for the comparison purpose, expandable polyethylene foam net is created. So in figure A, natural rubber latex foam net in sheet form is shown, and this sheet is converted into cylindrical tube in figure B. And figure C is the cross section of expandable polyethylene foam net, and figure C is the cross section of natural rubber latex foam net. In this figure A shows the expandable polyethylene foam net, and from figure B to figure F, natural rubber latex foam net with varying amount of pineapple leaf fiber are used. And you can clearly see that in figure B, 0% of pineapple leaf fiber are used, and figure C 2.5%, then 5% and 7.5, and figure F is 10%. And you can already one thing you notice that from figure B to figure F, foam net color changes, and it changes into greenish color, and it is because of the pineapple leaf fiber have greenish in nature. And then the morphology and cell structure analysis. In figure A, you can clearly see that there is no rough structure, only smooth and dense structure you see, and also there is no roughness and lumpness you are seeing. And this is because of this structure is for expanded polyethylene foam net. And from figure B to figure F, natural rubber latex foam net with pineapple leaf with varying amount of pineapple leaf fiber are used. So you can see that the surface are more rough and dense, and also when we increasing the amount of pineapple leaf fiber, then the roughness and lumpness is also there. And this is the FTR spectra of pineapple leaf fiber. Peak 3326 it shows the OH stretching of cellulose, hemicellulose, and lignin. And 2918 it shows the CH stretching of cellulose, hemicellulose, and lignin. And peak 1628 shows the asymmetric stretching of carboxylic acid, which is present in hemicellulose. And figure 1512 is the aromatic ring, which is present in lignin, and 1033 shows the CO stretching of cellulose and lignin. And this is the conclusion of my research. The eco-friendly cushion of natural rubber latex foam were developed in an alternative for cushion packaging. And natural rubber latex is a primary material for that research. And Dunlop process and microwave irradiation used in the vulcanization step. And addition of pineapple leaf fiber and natural rubber latex foam net improves the cushion biodegradability. And moreover, other natural fiber like husk fiber, banana, hemp fiber can be used in the packaging materials. Hence, natural fiber from agriculture waste may become valuable material. So, thank you.
So, any questions from the audience?
Yes, sir. How long? No. Yes, sir. So, I didn't experiment how long it is stable. And some work is needed in this research, so that's why only and that much of amount of work is completed.
I have a question. TCP form that we have is unrealistic. That having a density of 5 meter. And the next level having a density of 1.3. So
Shrinkage.
So aging it will increase. So that will definitely transport cost because the improves should be transferred from one side, let's say from here. So do you think that one of that change can happen the transmission? That way of the packaging really right?
No, I didn't get your question. Can you? I didn't get your question.
Okay, so what the nature level home like visual and nature is it weight will be higher for the
No, but we used only 2.5% and 5%. We didn't go higher much now. Maximum amount is we use 10% of pineapple leaf fiber. So weight is according to me, weight is not our concern. But nowadays, environmental biodegradability and sustainable development is more important. So that's it.
Thank you for your time.
Yes, ma'am. Yes, sir. Yes, sir. Yes, sir.
So can I ask
So what to your next, Bhavya? Not present. Okay. Okay. Yes. So thank you all for attending this program session.
কোথায় হবে এটা? যাচ্ছে কোথায়?
তাও তো ঠিক
ফাইনাল হয়নি তো।
না ওই ওরা হবে তো বোধহয় নাকি ওরা তো খালি হয়ে গেছে ব্যাগগুলো নিয়ে নে।
ওই ব্যাগ নিয়ে তো Okay, bye. All the for you, thank you, thank you. Yeah. Hello. China.
ये फाइनल में तो কালকে একটা ছবি নিয়েছিল না
নতুন এবার গাড়ি নিয়ে আসছে না কথা
So I know.
Never, don't do pages.